Hello, hello.
Good morning, everyone, and welcome to the day one, track five, and our session starting from Azure Communication Service by Hemant, Jani, and Manish. The stage is yours. You can start, Manish and Hemant.
Okay. Can everyone see our screen?
Uh,
Manish, can
Ahmed,
you?
yeah, I can hear you and see you. You can start.
Okay, perfect. Okay. So, hi everyone. Welcome to this session about Azure Communication Services, presented by me, Tijani Mansour, and my dear friend Manish. Thank you for this wonderful opportunity. A quick word about me. My name is Tijani Mansour. I'm a cloud solution architect at Kofomo, which is a consultancy company based in Canada. I'm also the co-organizer of the Azure Quebec community. Feel free to join us. It will be our pleasure to have you on board. You can reach out to me on Twitter. And you have also my blog. So the first one is my blog in French. And the second one is my blog in English. Manish, will you please introduce yourself?
Sure, and thanks to Johnny. So, greetings everyone, and thanks again for joining the today's session. I'm Manish, part of Commercial Software Engineering Group CSE in Microsoft, and CSE is a global org in which we work mainly with the enterprise accounts to help them in building their epic solutions on cloud using the Microsoft and open source technologies. We do code with engagements with our customer for building production grade applications by applying all engineering fundamentals. Yeah, that's about me. Thank you, and back to Jenny, to you.
Okay, perfect. Thank you, Manish. So today we're here to talk about Azure Communication Services. So what is Azure Communication Services? Well, to tell you more about Azure Communication Services, you probably use many of these applications: Facebook, Twitter, LinkedIn, and so on. And what do all of these applications have in common? Well, they all have communication capabilities. Okay, so
Ahmed, Ahmed,
yeah.
sorry, but screens are not moving. Can you come on that screen which we are
Oh,
discussing? Yeah,
okay. Can you see it?
I am still seeing the first screen only.
Oh, okay. Let me just try something.
Probably
Okay.
till Ahmed fix this. Basically, the agenda that we have today is, if I just talk at a high level, it is about the Azure Communication Services. Probably we will share across in terms of what exactly this service is all about, what are at high level different features. When then we will try to cover a use case, do a demonstration and a code walkthrough of the same.
Yeah. Uh, so I will try to share my screen again. Okay. Let's. Can you see it
Yeah,
now?
yeah. Now
Yeah.
it's
Okay.
good. Yeah,
Okay. Perfect.
thanks.
So I mentioned earlier that many of the applications that we probably use in a day-to-day basis, like Facebook, Twitter, LinkedIn, and so on, have in common their communication capabilities. Okay, so this application allow you to do chat with one or a group of people. They allow you to do voice calls or voice over IP calling. They allow you to do group meetings with the sharing of cameras and probably sharing of screen too. Okay, so imagine if you could have or integrate these features right into your own application. So the application you're developing, that would be awesome, right? And that's what Azure Communication Services is all about. Azure Communication Services allows you to bring these communication capabilities right into your application. So you can perform phone calls, SMS text messaging, you can perform voice and video calls over IP, and group chat and meeting. You can also perform screen sharing, switching of cameras, uploading files, do file transfers, etc. What's interesting to know is that Azure Communication Services is at the basis of the many services on Microsoft ecosystems. The most known, the well-known one is, of course, Microsoft Teams, but you also have Microsoft Dynamics 365 customer services. And now we can rely on these communication capabilities brought to us by Azure Communication Services and integrate them right into our application through the use of SDK and APIs. So why would we want to use ACS or Azure Communication Services? Well, the obvious answer is to add or infuse communication capabilities right into our application. And how can we do that? Is by leveraging ready-to-use SDKs in many programming languages. So you may have .NET, Python, JavaScript, and so on. And this service is already a resilient services, like many most of Azure services. You have resiliency built in right into the service. Okay? Another important aspect of ACS or Azure Communication Services is that it is an Azure service. Okay, so being an Azure service, you can benefit from the centralized management. So you can manage this service right into your Azure account. You can have the billing for this service also, and monitor and access the billing information for this service right into your Azure account too. You don't have to rely on external licenses like Office 365 licenses, for example. And also you can secure your communication if that's what you want through various identity providers. So we can think of Azure Active Directory, Google, Facebook, Twitter, and so on. There are also non-technical benefits in using Azure Communication Services. One is the low cost of setting this or integrating these communication capabilities. So we don't need to be expert in networking or telecommunications in order to take advantage of Azure Communication Services. And we will be relying actually on the strength and experience that Microsoft developed over the years monitoring and managing Microsoft Teams. We also can rely on an on-demand scalability. So ACS works fine for two people up to million of people. Okay? And it allows us as a company to be competitive in this market and this new reality by allowing us to integrate features faster and have a faster time to market. So we can, using ACS, we can build robust solutions and application that offers communication capabilities to our customers. Now let's discuss some use cases of using Azure Communication Services. The first one is we can leverage Azure Communication Services to perform reminders for upcoming events. Let's say you have a system that allows people to register to your events or internal events for your company, for example, and you want the people to be reminded of an upcoming event. at Kofumo, we host many training sessions every month, and everyone is always busy, and we all have family duties, etc. And it may happen that people register for events and forget to attend these events. So leveraging services like Azure Communication Services, and in this case, the texting capability, we can send them reminders over text messages to remind them that the event is soon to happen. Another use case is telemedicine. Okay, with the pandemic situation, there were um, many shutdowns and many things that happened. And for example, for doctors, we couldn't see our doctors only for emergencies. So having this proximity with your doctor, and the ability to call your doctor and have a discussion with them um, is really important. So leveraging Azure Communication Services, you can build applications for your medical clinic in order to be able to communicate with your doctor. For example, we can see here that we can leverage texting and phone calls with screen sharing if needed. Another use case, which is quite similar to the second one, is remote assistance. Okay, um, also with the pandemic situation, it was harder and harder to have technicians come to your home to fix things. Okay, um, but there are many things that one can fix on its own. Okay, there are things we can fix on our own if we have some level of guidance. Thus, leveraging Azure Communication Services, we can build application where technicians can log in, and we can share screen and share camera with them, and they can provide us step-by-step guidance in order to fix some items that we have broken at home. And of course, we can take to another level with HoloLens and a mixed reality headset. There are obviously more and more use cases, and use cases for integrating communication capability, of course, are not limited to the three use cases that we presented. I simply invite you to think of and unleash your imagination to find out a lot of other use cases and a lot of scenarios. And with that, let's switch to Manish, and let's see Azure Communication in action.
Yeah, thanks Trijani for setting the context of ACS here. It helps me probably to probably take these use cases, and let's try to deep dive into one of these use cases.
Perfect.
Uh, and I am sharing my screen. Hope my screen is visible. So now taking one of those use cases which Jenny just called out. Let's just take a scenario of e-meeting or a virtual meeting, and let's explore how, along with Microsoft Azure Communication Services as a communication platform, we can quickly build an enterprise-grade solution with the capability of video voice calling, along with screen sharing, and maybe we can extend this to chat, and as well as for sending or reminding reminders using the SMS feature. So let's, for this session, take a business scenario, probably where an agent is trying to solve a need of his customer, and for that he need to get into a video call option. Now, definitely as one of the option, we have Microsoft Team meetings, but then with Microsoft Teams, we have we see the challenges around in terms of how can we extend those invitations to the audience who are like external to an organization. And in that scenario, probably we will we will see how we can have uh, our line of business or maybe our web application which we can probably integrate with Microsoft Teams. So scenario is something like you have this user request or probably your end customer who are on web or a mobile and who wanted to use this e-meeting for a video calling and probably leverage the ACS platform. And then we have these agents who are actually sitting inside an organization who already are on Microsoft Teams. So probably the scenario is where an agent is using the Microsoft Teams as a client, and users are using a web application which is integrated with the communication platform ACS, and then both of these can collaborate in a video call. And again, this scenario is probably relevant for all the verticals, be it a financial service where you are as end customer, you have some banking needs or some financial service that you want to leverage around loans or whatever it is. And then there are customer agents who are sitting inside an organization through which you want to interact. Could be a KYC validation where you want to show your KYC documents, and probably your KYC validation can be done. And then in a retail industry where probably you bought something from a store like any big store like Walmart or anyone, and then you are now facing challenge in using that product, and you are seeking a help of a customer agent through a video call, where your expectation as an end customer is that he can come into a video call and guide you with the assembly of that product. It could be a public sector, something like a virtual court scenarios, and then it could be a healthcare, which Tijani just mentioned, a telehealth scenario where we have proctors or doctors, and then we have a patient, so probably getting into a virtual consultation mode. So this probably talks about the use case. Now let's dive into a high level solution. So probably this is at a high level how exactly the solution looks like, and we will keep a solution quite simple for this session, but we will also meeting our technical needs, that basically is like in this solution we have two types of user, the mobile user and the web user. And this web application can be integrated with any website, and it is also compatible with every platform, be it iOS, Android and a Windows, to handle the external users. And then the client side web application can be a React based user interface that can use a Redux for handling a complex state, while leveraging the Microsoft Fluent UI for a quick and a flexible design needs. And then the underlying service is the Azure Communication Services. And my colleague just discussed about the ACS in the introduction. As like ACS is fundamentally a platform for the developers who want to add in the communication workload into their applications. And this application has a serverless backend. Uh, then we also do have a logic app which probably help us to schedule, automate the business process, and this can take care of your needs around the SMS functionality. So triggering the SMS using the ACS SMS feature uh, for sharing your probably a call details or a reminder on the SMS to your end customers. And then powering the front end is a C sharp function app powered by ASP.NET Core to connect this application with Azure Communication Services. And so now let's extend this solution up further down to make it a production grade. And that is where probably what all services that you would need is maybe an application insight to monitor your live applications, which can automatically detect the performance anomalies. And then for identity, secret and access management, we can introduce the Azure Active Directory, the Azure Key Vault for storing of the ACS keys, and then network security group for defining the security rules for the inbound and the outbound traffic. Uh, the system health monitoring, we can have log analytics and the Azure monitor. And then Azure web application firewall or the Azure application gateway for providing a centralized protection of the web application from the common exploits and vulnerabilities. And of course a load balancer we can introduce for distributing the inbound flows. Now quickly this was at a high level the solution, how it looks like. Now let's look at the demonstration part of it. So uh, let me quickly run this. So basically, the scenario here would be we will be setting up a Teams meeting. So this is where I'm setting up one sample team meeting by the name Azure Conference 2021 Azure Communication Services, and this is my join meeting URL. And once I have set up this meeting, uh, in my code at the meeting, this is where I will define my join meeting. And this again for the sample or for the session and the demo purpose, I have hard coded it right now, but we can have this dynamically take the values. So this is where I have defined my join meeting URL, and probably we will get into the code details after this. So I've just joined this team meetings on my Teams web client, and let me get inside this meeting. So and then once I am in the meeting, uh, and for the end user probably who don't have the Teams and who are external to the org, let me call my ACS application. And again, I've just extended our web hero sample here for the demo purpose. So let me start a call. So basically, this takes me into a configuration page where I can define the user. So let me give Manish, or maybe just let me just enter ACS user one, and then it is able to identify all the devices that I have. So the multiple camera that I had. And again on the microphone end, all the devices that are there in the microphone, I can do a local rendering of my myself to see if everything looks fine. Also check the microphone if it is working fine, and then start a call. As I start this call, this is where I start initializing my ACS component, and again we will talk in detail once we do a code walkthrough. And as soon as I do this at the Teams, this is where I get that there is a user, ACS user one guest, who's waiting in the lobby. And if I authenticate, I can admit him, or otherwise I can reject him. So once I admit him into the lobby, from the lobby into the meeting, that's where the ACS user joins the meeting. So now you can have a look. Manish Saluja here is basically a Teams client or an agent who's using a Teams, and ACS user one is your end customer who's using ACS or probably your web application, and both of them are right now into a Teams meeting. And these are the control that the ACS user again has if you want to switch his camera. So I've just started my camera, and my the Teams user can also see the remote rendering in Teams. And we also have the option for and in the Teams, let me start the camera. So this is my another camera because the device was same, and this is how it renders for the ACS user. And along with that, the in Teams also we have this. So I've just switched my camera in Teams, and this is how it will render for the ACS user. And on top of that, we can also add the other controls in terms of adding a chat component here, something on the similar lines as we see the user experience that is there for the Teams user. So we also have a control for looking at who all are the participant at the ACS level in this call. And probably I can switch on my mic or probably mute it. This is the share your screen in ACS, how I can share my screen, so different screens that I can see. And the another aspect is probably when the ACS user leaves the call, uh, there would be a notification in terms of showing the status of the ACL that he's leaving a call. So this is again something on the participant list tag. So both ways, like in the Teams on same lines we can design for this. So I have just left the call from the ACS end, and that's where in the Teams it is showing me that guest is leaving, and probably the guest left the call. So this was about the demo. And yeah, this was about the demo. And now quickly, let's see at a high level how the code structure looks like. And basically, yep. So let me Okay. So basically, we need three packages here. Uh, uh, the Azure Communication Administration, the administration package for managing the users, the access token, and phone number. And then we have a common package, Azure Communication Common, for providing the base type for the other client libraries. And then we have, since we are talking about the calling, so we have this calling package, Azure Communication Calling, for adding the video call for the application. And if I go to the controller, so this is basically, yeah, I'm just trying to maximize the screen so that it's viewable to everyone. Yeah, user token controller is, so this is basically where like the first step is to create the identities, users, and manage the access tokens. The access token basically allows calling the client libraries to authenticate directly Azure your Azure communication services, and to initialize the communication service client libraries on the client device. This access token is needed, and uh, if I this is where I'm setting up my communication identity client by providing the my ACS connection and string, and then this is where I'm actually creating my user using create user and token in sync, where I'm passing my communication token scope as VoIP. But then in ACS we have three scope. As we talked about the different features of ACS around chat, voice over internet protocol for your video calling, and then the telephony expect for the PSTN. So we have these three scope defined, chat, VoIP, and PSTN. But because we were just talking in this scenario around the video calling, so that's where I have just taken the scope as VoIP, but we can pass all these three scope for the token. And using this, probably I am able to create a user and generate a token for this. And now if we look at the front end of this application, so basically index.js is my, okay. Yeah. So this is my the front end where I have the my all the components that I've defined for my ACS in terms of the configuration panel, the display name fields, the end call, the group call, and then components for your local streaming, for your remote streaming, and then the media gallery that we are trying to create, and the controls for the media. And then we also have for the configuration. So this is basically where we have uh, the initial configuration screen that was coming, where you had an option to select your devices, the camera, microphone, and then have a local rendering to see like how exactly your local camera is rendering your local image. And then if I go into the containers, so these are my containers defined for the configuration, group call, header, media gallery, and the participant stack. And uh, basically we are using Redux here for the state management, and that is where we have our actions and reducers defined, again for the call device, and then streaming expects, and then uh, on the side effect, basically this is where we have a logic where we are integrating our ACS calls with our teams. And if I show you exactly, so this is where I've defined my meeting locator, which is basically coming from my communication calling SDK. And then and and then basically I am defining my meeting URL. So this was that meeting URL. So for this session I've hard coded, but again we can rewrite this to take it basically how we can have this scenario. If I take one step back is we can use the graph APIs for creating these online meetings. So probably again by writing a small logic of using the graph APIs, we can create a Teams online meeting programmatically, and then probably once we invoke the online meeting endpoint of the Graph API, we get the join URL as a response to it, and that join URL is something that we can hook up with our application, and that's where this meeting URL basically comes from. And once I have this meeting URL, so when I call my agent to join, that is where I give the context of this meeting URL and other call options that I need. And so basically this allows my ACS component to start or probably get into the Teams meeting. And this feature is basically our ACS Teams interop feature. uh, and then what else? Probably, yeah, I think I covered almost all from the code expects. And yeah, I think that's all I had from the demo and the code expect perspective. And we are happy to take any questions if you have.
Okay, I'll
Uh,
share my screen again.
yep.
Just give me a second. Okay, here, here.
Uh, Meanwhile, Tijani is sharing his screen.
Mhm.
Any questions, if you have, feel free to ping here or maybe reach out. Jenny would be sharing the details where you can reach out. We would also be sharing the presentation and a sample, the code that I walked through on a private or on a Git repo links where you can go and explore this further.
Yeah, so perfectly introduced. Now that we know a little bit more about ACS and what we can do with it and how we can work with it, thanks to your code walkthrough and your demo, Manish, where do we go from here now? So there are many resources that you can use to learn more about ACS. Here we share two of them, which will be the perfect get started documentation for you to get started with Azure Communication Services. You have the communication services documentation, the first link, and the GitHub repo of Azure Communication Services, where you can find the demo code samples. Okay. And with that, thank you very much for taking the time to be here with us. We hope you enjoyed this session. Feel free to ask a question in the chat if you have any question.
Or you can reach out to us on our LinkedIn handle
Yep,
or Twitter, on Facebook if you have any queries
definitely.
around this.
Yeah. So here you have my contact information.
I see a
Ah,
question. Couple of
okay, great.
question. Is the source code
Yeah.
available for the sample? Yeah, we do have a source code available, and in fact, the code that I used for the demo purpose was something that Microsoft has already published on Azure documentation, Azure Communication Service documentation. And I just extended that to integrate with Teams. So you will see a lot of quick starts available there for setting up a chat or a calling or maybe a Teams interrupt feature. And feel free to see that in case you find anything challenging or maybe you are stuck. Again, you're open to reach out to me or to Tijani on that. There was another question. Is it possible to call a guest user to a guest user? I couldn't get that, but yeah, with this scenario, that's what the beauty of this is, where you have your users who are registered in Azure Active Directory and for which you have M365 license. These users, you can probably use Microsoft Teams client, and then you can have all your end users uh, who don't have an Azure Active Directory or a team license to come via ACS route into a Teams meeting, and then you can collaborate. So with this scenario, the guest user can participate, something similar to how the Teams user participate in a Teams meeting.
So to illustrate your examples, if we think of the clinic for doctors and the clinic staff can use their Office 365 license and communicate over Teams. And while the patients, the customers of that clinic will use ACS to join with no Office 365 license needed, right?
Yeah.
Great.
Uh, there is another
So
question by Pavan. Yeah, sorry.
just
Jenny, you were
before you
saying
go,
something.
yeah, just before you go to the next question, I guess the repo that you mentioned was this one, okay? So where you can find the code sample that Manish extended.
Yeah, thanks. Yeah, so there is another question by Pavan saying, is the team involvement or is it mandatory to require a immediate, intermediate authenticated user? Uh, Probably no, it is not mandatory. And there is another question, team involvement is mandatory. Absolutely no. This was only for a scenario where you already have M365 licenses and you have some users or probably agents who are already into the teams uh, for their day-to-day work job. And that's where this was how you can extend ACS calling feature uh, beyond one level, where you can also interact with the Teams user. So you can absolutely create your only ACS video calling application without any involvement of Microsoft Teams. So and you can have all your users or a video calling experience outside of Teams as well. So this was because we are seeing a lot of pattern where a lot of organizations have already invested in M365, and there is a team who works on Microsoft Teams. So that is where a lot of pattern we were seeing, that how we can probably extend this for a scenarios which we covered initially in terms of the users where for whom we don't have a M365 license. So this scenario was typically for that, but yeah, you can create your own web video calling experience for the users, and there is no mandatory requirement of Teams for that.
Just keep in mind that Teams relies on the features of Azure Communication Services that you can also leverage in your own custom application. So you don't rely on Teams to integrate communication capabilities into your own applications. You rely on the Azure Communication Services here that is also used by Teams.
Yeah, and right now the other way is not possible. Like, you cannot in your ACS call, you cannot bring the Teams user.
Mhm.
It is only in the Teams meeting you can bring a ACS user. So that feature is only limited to a Teams meeting, and that is where the first step that I did of that demo was I created a Teams meeting. Because in my scenario, what I was trying to show was in a Teams meeting, how can I bring a ACS user to collaborate? The other way is not available yet, where in a ACS call you can bring a Teams user.
Okay, but usually it's we'll use the way that you described in your demo. That's the most common use case that we see actually. Yeah.
Yeah. Okay. I don't see any question. But yeah, probably I think we should be good if we don't have any more questions.
Thank you, Manish, and thank you, Rijani. That's very wonderful and something new I learned today by just moderating you both people like Azure Communication Service. And I think Pawan got the answer what he required from the chat. He asked one more question. Is there any limitation?
Limitations of ACS in terms of, like, if you are comparing it with the Microsoft Teams, so definitely there are some features which are right now in the roadmap, but if you're looking to create something from the video calling experience perspective or a chat experience perspective or the SMS, uh, the only limitations I see, but again, I will not call it as a limitation because this is something as a limit in terms of like how many users can be there, or the participant can be there in a video call, or how many participant can be there in your chat threads. So there are some numbers or the limits that are defined. Otherwise, there is no limitation. You can design the solution that the way you want. It's very flexible, very developer friendly. Okay, which is better, ACS or Teams, and so why? Probably, I would not say anyone is better here. ACS or a Teams both have their own functionality and they have their own space. ACS, only good thing with the ACS is, and again, the way the ACS is created in the backend, it is leveraging the Teams platform only. So it is built on top of ACS. So we have been hearing of late like Teams was not that much flexible for the developers to use, and that is where this Azure Communication Service was designed so that developer can develop their solutions using that. But eventually, ACS in the backend is using the Teams platform. So uh, probably no comparison, I would say. But yeah, looking at what exactly your needs are, if you are looking for something which is quite flexible in developing, probably you want to have your UI control, because with Teams the design aspects are like fixed. You cannot modify those, and that's where probably ACS fits for those scenarios where you are looking to have your own user experience, for designing your own user experience. So that way, depending on your requirement, there are scenarios where ACS fits in, there are scenarios where Teams fit in. Microsoft Teams platform is a very mature platform. ACS is somewhere, we are building on ACS with different features that we are seeing from our customers request. Okay, another question I see on the pricing model of ACS. So like any Azure service, the pricing model for ACS is on similar lines. So if you talk about a video calling, probably the pricing would work like the number of minutes the video call was on into the number of participants that were there, and then basis on that there is a cost with which it get multiplied, and that's what is for the calling. If you talk about the chat solution, uh, probably I think it's again around number of participants that are there in the chat thread and something on the number of messages. That's how it's calculated. You can go and visit Microsoft documentation around the Azure communication services, and you can get the detail of the different features and the pricing. So again, at high level, ACS is offering you calling, chat, SMS, and PSTN, telephony. So there is very clearly pricing that has been defined for all of these features. So feel free to have a look at the Microsoft documentation there.
Talking about limitation, one limitation that you may face is that for now, telephony is not available in all countries around the world. This feature is rolled out over time, but as far as I know, it's not yet available everywhere in the world.
Yeah, probably the the point there is like if you have your billing as your subscription billing in US, you can use that. Otherwise, not. And again, telephony you basically need for SMS and PSTN, and that's where you would need your subscription billing to be US. And using that toll-free number, that is US toll-free number, you can only send or send messages to the US region. So yeah. That's right now, but again, other regions are right now on a roadmap, so soon we will see other regions also getting those features.
Yep.
So look like Pawan is more excited with Azure Communication Service, and he just thrown one more question. Control sharing possible through ACS, like while sharing like other screens.
Yes, so we do have the API endpoints in ACS through which, like I didn't went into, but I just showed you in the demo. There was an option to share the screen, and then you can also extend this for controlling sharing while you are sharing your screen. So there are endpoints probably which you can leverage and create that experience.
So Manish and Tijani, we will wait for 2 more minutes, and if no QA, then we can move to the
Yep,
next session.
sure.
Okay. Thank you for being here.
Yeah. So we got one feedback from Pawan. Thank you for the awesome session.
Yep. Thanks. It was fun being a part of this session. Thank you
And,
all. Thanks for your time.
and being part of this event. We hope we will have a wonderful event and enjoy all the wonderful sessions that are on the agenda.
And like I shared one feedback form. You can share your feedback about the speakers and the session. Anything you can post through a link. I shared the link on the chat, so you can share your feedback in the link. Okay, Manish and
Yep.
Jani, thank you for your wonderful session, and good luck to you, both of
Thank,
you.
thank you
Thank
very
you.
much for having
Yeah.
us.
Thanks. Yeah. Thank
Yeah.
you. Bye bye.
Bye bye. Bye, Manish.
Bye.
So our next session will be AK storage option using CSA driver by Satish Krishna, and we will start around 11 a.m. So our next session will be given by Satish Krishna, and he's going to talk about AK storage option using CSI driver. Yes, Satish, you can go ahead.
Yeah, thank you. Hi, everyone. Good morning, and very early morning for folks joining from Europe. My name is Satish Krishnan, and I'm glad to be part of the Azure Community Conference 2021. And here to share some of my insights around how to deal with Azure Storage, and thanks to our partners who are sponsoring this event. About me, I have about 16 years of cloud experience on software development with about 7+ years on cloud computing. I was part of Microsoft India when I started working on Microsoft Azure, and then I've been working with Teradata and now leading the cloud engineering for UBS, where specific focus on cloud native technologies and data engineering specific capabilities. And today we will be talking mostly about storage options for Azure Kubernetes Service using a new capability called CSI drivers. I'll give some basics also, but the idea here was like I mentioned in one of my posts in LinkedIn as well. When we start Kubernetes or microservices-based deployment, our focus starts with building stateless services, where you're building a API service or a backend service which stores the data in an external data store like Cosmos DB or Postgres, Azure SQL, or Blob Store. But there will be times as you start moving into the cloud native implementations on Kubernetes where there will be requirement to host stateful applications on Kubernetes. It could be your own application where you want to store data, or you're trying to onboard a third-party application which has a dependency on a stateful component like MongoDB or Prometheus or PostgreSQL or Kafka, for example. So in such cases, it becomes important to understand how these components leverage the capabilities that AKS provides to provision or to store persistent data. When I say persistent data, the data that is stored along with your compute-related stuff, so that in the event of failure, that data, or when your pod or compute recycles, your data still remain persisted, so that your application can recover from the failure. We will focus specifically on how to expose Azure Disk and Azure File Storage to the containerized workloads running on AKS. But I will also try to cover some of the concepts on what CSI driver does and what other types of drivers are available that you could consider using in your applications. So let's start with AKS basics. I think for folks who are new to Kubernetes or AKS as a platform, it's important to understand what's the platform on which we are working. Kubernetes is by far the most popular container orchestrator currently in the market, and widely adopted by all the major software vendors, including the big cloud vendors like Microsoft, Azure, AWS, and GCP. And why it is popular is it gives you a very good mechanism to orchestrate your container workloads, where the aspects of availability, scalability, and security, networking, storage, everything is driven in an API-driven manner. You can define what is the target state of your application or your container workload, and the Kubernetes controller goes behind the scene and start provisioning your component in the right way. And because we are talking about a cluster, you may have hundreds or tens of hundreds of virtual machines. How do these virtual machines get created? How does your workload go and scheduled on each of these virtual machines and stuff is all taken care by Kubernetes. And it has two distinct components. One is the control plane component, or it's called as master. Master has some specific resources like API server, scheduler, and controller. They are the brain behind Kubernetes, which decides how your workloads should be scheduled. And then you have the worker nodes or the worker components where your actual container workloads will be scheduled for running. They have some components like kubelet and kubeproxy, which allows interaction with the master nodes, as well as the interaction with external network for communication and stuff. And it has a container runtime where your workload will be running. Again, this is not a crash course for Kubernetes or AKS and such, but I thought I'll just set the ground. And when you look at AKS specifically, there have been challenges in Kubernetes, managing the master component and stuff. Those who have done in on-premise would know that you have to ensure high availability of the control plane component so that your cluster is always available. And what the public cloud vendors came up with is a managed offering where they take care of the control plane components, and that's Azure managed. And what we as customers are responsible is only for the virtual machines on which the container workloads are running, or the workloads. And each custom managed component is in Azure is basically a Azure virtual machine or a scale set, and it allows you to have integration with Azure Virtual Network for networking up operations, and as well as allows integration with the underlying storage like Azure Disk and Azure Files, which we will be covering today. Some of the benefits that AKS provides, or a managed Kubernetes service provides, which I think predominantly all the customers on Azure are using instead of going with their own Kubernetes offering, is that it takes care of your patches and upgrades in an automated manner. It's a single CLI command. You can either go for automated upgrades so that your Kubernetes cluster in the most recent or N-1 version of the Kubernetes version released. For example, recently Kubernetes released 1.22 version. And if you go with automated upgrade, AKS will make sure that your cluster is running in the most recent version of Kubernetes with all the capabilities it provides. But it allows you to have API-driven approach to upgrade your cluster as and when you choose, so that you have the control. But when it comes to OS patching and stuff, most of these capabilities can also be automatically driven, or you can define maintenance schedules based on which Azure can apply the patches to your worker nodes. For the one that is managed by the customer, one is managed by Azure, is totally their responsibility. We are not concerned about it. And it provides high availability and reliability because the worker nodes are backed by virtual machine scale set, which has a 99.99% availability. It supports multiple availability zone so that your cluster is spread across multiple data centers within a region. It also supports you to have clusters deployed, like cluster 1 in East US and cluster 2 in Central US in different regions, so that you can plan for disaster recovery and stuff as well. And Kubernetes internal capability also allows to make sure that your pods can be scheduled across different availability zones. There's a new feature called as pod topology constraint. So you can say, for my production, I need 3 replicas of my pods running, and 1 replica on each availability zone. If you define your configurations like that, Kubernetes go ahead and do that. So in the event of a failure in a particular data center, I'm not talking about a region, but a data center in East US2 region, in that case, your application will still be up and running. You don't have to trigger disaster recovery or failure yet, because the region is available, just that 1 availability zone is down. And it's easier to set up. It's just a single command to set up your AKS clusters. You can deploy it using ARM template or Terraform script as well. And provides a lot of automation, and it is secure. It has a lot of security and compliance built in. It has integration with Azure Active Directory for making sure that there is fine-grained RBAC controls, role-based access controls defined to define who has access, what permissions the developer has, what permission does an operator has, and what permission does an administrator has. And scaling, it leverages the capability that Azure AKS provides, like the cluster auto scaling integration works with VMSs to make sure that as and when the workload increases, it provides you additional nodes so that you are not throttled by capacity of your underlying worker nodes. And additionally, self-healing. So if a virtual machine goes down, and then Azure VMSs automatically provides another virtual machine which replaces the failed one, and your workloads get scheduled onto the new one. And all of this capability is provided at no charge. Again, I think there should be an exclamation. When you start AKS, you get a free tier, but the free tier has just 1 copy of your master. It is not very highly available. So if you want high availability for multiple replicas of your the Azure managed control plane components, In that case, they have now recently released a paid tier, which allows you to have a high-level or uptime SLA defined. And this SLA, I think, is financially backed, so Microsoft will make sure your cluster master components are highly available. If not, they will pay you for the SLA times that are lost. So this is high level about AKS basics, and today our focus will be on persistent volumes. So like I said, the moment when you start looking at running stateful applications where I have my container which runs application code, but it also needs to source some data that need to be closely associated to my container, more like attaching it as mounting it as a volume to my container so that I can access it easily like a file value. There is no API call, there's no network request, multiple network calls. It is just accessible to you on your volume, and you could work it like a regular file share that you're working on. And the other aspect that persistent volume provides is, though it is mounted to your pod, it is the life cycle of your persistent volume is different from a typical from your underlying pod. So if a pod is failing and it recycles, it will not affect your persistent volume. Persistent volume would still be there. So when a new pod gets replaced or placed by AKS, that pod will be able to go and attach to the same persistent volume. How it will do that, we will review that. And there are other ways also to do volumes. Persistent volume is not the only way. Persistent volume is if you want to keep the lifecycle of data outside the lifecycle of the container. There are other ways to do. We call it as ephemeral volumes. You can have config map. You can mount config maps as a volume to your deployment. That makes all the config files available as to your container. You can have secrets mounted as volume. So all the secret files, Kubernetes secrets, can be made available to your container via volume. There are ephemeral volume also. These are temp or storage that's available as part of the node, underlying node, that is allocated to the container for some of the workload. But all of these are ephemeral in nature. When a container dies, that particular storage or that volume will also be removed. And all the data, again, config files are stored in a config map store, secret is stored in a secret store. So we don't mind losing the data because when the pod comes up again, the data is available to you. But when you're editing, when you're writing, when you're creating new data, and you want the data to be secured even when the pod is going down, I would recommend considering persistent volume because its life cycle is totally different. So there are three components that makes this persistent volume implementation possible. One is the volume itself. So the persistent volume has direct integration or mapping to the underlying storage. In this case, it could be Azure Managed Disk or Azure Disk, and the other one is Azure File Share, where you can have data shared across multiple pods. And but this persistent volume, it is attached to the pod via a resource called as volume claim. So typically when a pod comes up, it says, hey, I need a volume of this particular requirement. And that's defined in the claim. We'll see the sample in the demo. And the claim will then go and try to find, is there a available persistent volume matching this requirement? Right? And there are again two approaches here. We call it a static provisioning and dynamic provisioning. In static provisioning, there is already a volume created by your cluster administrator, or you're bringing your own file share. You want to reuse that file share for your volume mounting, or you're working in an environment where you don't have the permission to create underlying disks that's managed by a cluster administrator. So you will go and create the persistent volume ahead of time. All you as an application developer is responsible for is just defining the volume claim, and the volume claim try to find, is there a matching volume already in the cluster meeting my specification? If it is there, then it will go and attach that volume to the corresponding pod. And there's also ability to create dynamic provisioning, which is where storage class comes into picture, where you don't have this persistent volume in place, but when you deploy, you just deploy a pod, a storage class, and a persistent volume claim. And the claim will say that, hey, do I have existing volume? It can't find a volume. So it go and now ask storage class to create one for itself. So then the Kubernetes API server will go ahead and call the underlying storage to go and create the corresponding component or the disk or Azure file share for you. We will cover both the scenarios in the demo today. And The storage class, like I said, defines what type of storage do I need, what tier do I need. Do I need premium tier? Do I need standard tier? And what kind of reclaim policy? Like when if I delete this persistent volume, do I still want the underlying disk to be available? Or do I want, when the volume is deleted, I want the underlying disk to be deleted automatically? Again, this is important to understand because typically there are two modes in reclaim policy. One is delete, the default one, another one is retain. So when you use a delete reclaim policy, when the underlying volume is deleted, or if there's no claim for a volume, then the persistent volume automatically deleted and the underlying resource is also removed. So which means it will not create any orphan resources, a resource or data store without any claim available for it. But in some cases, you want to make sure that I don't lose any data. I want to make sure that I can have some copies of the data available. Then you can go with the reclaim policy as retain, so that even if there is no claim, the data will be available for you for access. And yeah, like I said, the volume claim is the one that defines whether it needs Azure disk or Azure file with specific requirements, and then based on that, Kubernetes goes and provisions the volume for you. The primary differences between disk-based and file-based volume is disk can be mountable only to a single pod, a single container. You cannot share it with multiple pods. It supports read-write once. So scenario, so it attached to only one component. So on that component, you can do read and write. And this can use premium storage or standard storage. So you can go SSD-backed premium storage or HDD-backed standard storage. Both options are supported depending on the performance requirement of your application. Files, it uses the Azure file share capability, and that share can be mounted to multiple pods, multiple applications at the same time. And it's mounted as read-write many, which means from multiple pods you can write or read at the same time, but the application has to make sure that there is synchronization between when the pod is writing so that you don't have any overwrite kind of scenario. And files also supports Azure Premium Storage for SSD-backed Azure files, or you could use standard storage as well. And I mean, I'm not going heavy on slide, but I just wanted to come some theory of what we are going to see in the demo today. Final part of this is the CSI drivers. Now, what is CSI drivers? Prior to 121 or 118, I guess, all the storage implementation was tightly coupled with the core Kubernetes implementation. We used to call it as entry storage drivers. Now, the challenge with that approach was you have a Kubernetes, the plain vanilla Kubernetes, and then there is a cloud components, right? Cloud implementation of that Kubernetes, like Cloud Control Manager and stuff, which gives you Azure specific or AWS specific implementation. So when you deploy Kubernetes on AWS, it has to create EBS storage for your disks. And when you are deploying the same on Azure, it has to create a Azure disk for you. And if you're creating Azure files, if you're going file-based storage, then accordingly for AWS and Azure, it has to create different stuff. Now, the challenge here is that with this approaches, every time there is new updates that the cloud provider has to provide, they have to wait till the Kubernetes release to be available. They will not be able to provide it independently. It was always tied to that, and it was creating some challenges. So they came up with a new specification called container storage interface. And all the definition of how volumes can be attached to the container workload got defined in container storage interface. Again, this is not very specific to Kubernetes. It supports all the orchestration platforms that supports containers. It could be Mesos or other container platforms, but for Kubernetes also it started, the support via CSI driver is available. Now the implementation, CSI driver implementation has two components. One is the CSI plugin or the control plane component of CSI, which so the node part of the CSI driver, which sits on each virtual machine we saw earlier. So on each worker node, you will have a CSI node driver that is responsible for attaching the corresponding persistent volume or disk to the pod. And then you have a controller part, which understands some custom resources that are introduced by CSI and accordingly take some action for you. So the benefits that CSI driver will provide you is It manages the lifecycle of your underlying disk. So we will be reviewing two types of CSI driver today. The disk CSI driver manages the lifecycle of Azure disks, and it also supports full or incremental snapshots. So one of the biggest challenges that we had in EKS so far is you could create persistent volume, but there was no native way for you to create backup of your persistent data, like take snapshot from a Kubernetes native way. You had to go with Azure backup and other ways to take snapshots and then manually have to restore. It was becoming cumbersome. With CSI driver, they supported ability to take snapshots and also ability to restore those snapshots on a persistent volume, so that in an event of failure, you are not losing the data. You can recover your application to that failed one. When I say event of failure, when the disk also is lost. So when a pod recycles, the volume is still there, but when when the disk also got deleted by some human error or for due to some disaster, as long as the snapshot is available, you will be able to restore your persistent volume and your application state can be recovered. We will demo that. We will watch that in today's demo as well. It also has support for cloning your volume. So if you have a dev environment, you want to quickly spin up a test environment based on the data that is already created, then you can clone your existing persistent volumes and then mount to your new environment that you're creating. And it also supports for storage expansion. So let's say you started with 5 gig storage of disk, and slowly your application started growing, and then you need more storage. Instead of deploy or deleting, recreating the application with higher capacity, you can configure storage expansion, and it also allows you to expand your disk size accordingly. Similarly, the file CSI driver, it supports the lifecycle of file share. So it can dynamically create a file share or attach to an existing file share. And it supports storage access via private endpoint. So if you're in a corporate environment, enterprise environment, and access to storage is only limited via private endpoint, Azure File CSI driver supports that. And it also supports expansion. So you can increase the size of your file share. As far as I know, there is no capability to do backup or restore, because Azure Files itself has Azure Storage itself provides redundancy across regions. So geo redundancy or zone redundancy, you can configure them. So there is no specific implementation in CSI driver, but I think there is something coming which make it very specific to Kubernetes specific implementation. I don't have much information on that. There are a few other types of CSI drivers that are available. The one that's most popularly used is the secret store CSI driver, which allows you to either connect Azure Key Vault or HashiCorp Vault and mount all the secrets available in that vault as a volume to your underlying pod, so that you don't store them as Kubernetes secret. You can securely access those secret values from your underlying pod volume. The other one is Azure Blob Storage CSI driver. Recently it went GA, but it is still an open source based implementation. It uses blob fuse driver. It allows you to mount your existing object storage, blob container or existing blob as a volume to your Kubernetes pod. But today we will only focus on the disk CSI driver and Azure File CSI driver. So with that, let's jump onto the demo. The demo is available in this link as well. Sorry. Okay, I'll share this at some point of time so that you could access this. Let me quickly jump to the demo. For our testing purposes or demo purposes, I've already created a cluster and the corresponding storage account. We will just have an experience on how you can go ahead and create disk-based persistent volume for your application, and also try to test the backup and recovery scenarios. So if I do case list, so here I'm trying to get the current cluster that I have. So this is the demo cluster that I've created. Let me get the credentials for the cluster. I think I already have. But So this allows me to get the kubeconfig file, generate the kubeconfig file for the AKS clusters that we have provisioned for demo. So if I do kubectl cluster info, it will show us if I'm connected to this cluster. Right. So I'm connected to the azconf demo cluster. Now let's check if CSI driver is and because we are in 121 version, I think I failed to maintain the point. If you're upgrading your Kubernetes to 1.21 version or AKS to 1.21 version of Kubernetes, CSI driver becomes a default capability. It is available for use, and it also supports I think your existing persistent volume claims, even though they are using different storage class, they will be supported specifically for disk-based implementation. So how do you verify if the components are available? Let's do kubectl get pods. All the CSI components are installed in kubesystem namespace. So here you can see the disk drivers specifically for the CSI drivers for Azure Disk and CSI driver for Azure File. These are again daemon sets. They sit on individual. There will be one instance of the pod running on the node. They are responsible for talking to Azure, provisioning all the disks or the Azure file-based volumes, and then attaching the volume to the underlying pod. So if you're deploying a pod and if your pod is not running properly, if you're getting volume mounting error, I may advise you to go and check the logs of this driver to see if there is some information available for you to troubleshoot. Again, depending on which node the volume is, the pod is failing, go and check the CSI driver logs of that particular node. So we have CSI up and running here. So what I'm going to do is deploy a sample application. It's a voting app. It has two microservices, a Python front-end service, which allows you to vote for multiple options. And then all the data is stored in the Redis backend. And that Redis backend is supported by an Azure Disk as persistent volume. And we will see how the data is persisted and what happens if I cause a disaster. So let me quickly show you the voting app. Nothing fancy here. It has a persistent volume claim. Here I use dynamic provisioning. So I provide a storage class based on which the disk has to be created. And I give access mode as read write once. And I also give a capacity that I need only 1 gigabyte storage for this disk. Again, this is not the standard. You have to determine this based on your actual application requirement. Right, and then when you go into the deployment section, I have a backend application which uses Redis as the backend or the container image, and this is where the volume is mounted. The persistent volume called voting backend is mounted on a path called /data. We will see that as well, and it's exposed via a service so that my front-end pod can call, and front-end pod is a simple Python service. And it talks to the Redis backend and exposed on port 80, nothing fancy here. And it's exposed as a load balancer. I'm not using REST in this example because the focus was only about CSI drivers and persistent volumes. So I use load balancer, and it will have a public IP using which we'll try to load the app. So let me go and create this application. I mean, you can go ahead and try this sample in your home. I will share the link later. And let's deploy the app. Let's watch if the application is deployed correctly. All the pods should go into running state. The voting backend typically will take few minutes because it has to create the underlying volumes in the Azure Disk and then attach the volume to the pod. So it takes a few more seconds than the front-end app to come up. The external IP is already generated. Once the container is going to running state, we will call this external IP to check if the app is loading. But let me see if I can give this in the comment section. Okay, I don't think I can chat. If the users could access this link or IP, you can try to vote some of these values and see how much votes we gather, and we will try to see if that value is persisted. Takes a few minutes. Meanwhile, let's go to the browser and check the Azure resource group. So typically, when you deploy AKS cluster, you deploy the cluster component under resource group, and it also creates another node resource group where all the virtual machines and storage gets created. And if you observe here, it has created a new resource called PVC. So this is a managed disk, which is created by the claim that we created in voting app. We can verify this with the output as well. So the app is running now. Before we go and access it, let's quickly do some checks on this particular stuff. So if I do kubectl get PVC, that's a voting app. So this is the persistent volume claim that got created for us. And if I do kubectl get describe, oh sorry, name is voting method. So I'm trying to get the PVC. So it gives details about the volumes getting provisioned by the CSI driver, and once the operation is completed, it says successfully provisioned the volume on this one. Let's check the volume details also to see if it maps back to the corresponding Azure resource. So if I do kubectl describe persistent volume is not bound to a namespace, so I can give without a namespace. And if you can find here the volume handle property. Again, these are new CSI driver specific properties that get returned to the persistent volume resource. And if you observe this, volume handle points to the persistent volume resource or the disk resource that got created under the subscription. So we will verify that. It starts with PVC DEDD. And if I go to the portal here, refresh, you see a disk called PVC minus DEDD. So this is the resource that gets created by my volume. And let's quickly go ahead and run the app as well. So this is the voting app. I see there are some votes. Thank you. We will create some more voting. So all this information is captured. Please keep adding more votes. Now what we'll do is we'll see how the data is persisted. Redis persists data in a certain way. If I go to the underlying pod, so if I do list on this page, it shows me a file called, okay, let me bring it up. So let me try to get the file data here. If you see, you'll find append-only.ao file and dump of file. These files are created by Redis. This is where the data is persisted by Redis. Redis has replication option as well, but this is a sample example where how the data is persisted using the AOF option. And what we will try to do now is cause a disaster and see if I'm able to recover the data that got deployed. So again, this information allows us to go and check the volume and the volume snapshot content to verify that everything is created as expected. So these resources, right, volume and volume snapshot, these are the, okay, now we are in the snapshot part. Okay, these are the new resources, custom resources. They are defined by CSI driver. They allow you to take snapshots of existing volumes. Like I said previously, that capability was not available with CSI driver. Now you can take snapshot. Before we go do that, let's quickly verify the manifest of that. So what does a snapshot class say? It says, hey, I am trying to take, using CSI disk driver, take a snapshot of my application, which with incremental mode, with the mode as incremental true. By default, incremental is enabled as true, which means every time you take snapshot, it only takes the differential, but you can configure it to take full snapshot as well. If you set it to false, it will take a full snapshot of your disk. And if you go to the snapshot object, this is just a definition of under what, using which driver I need to take snapshot. But which object to be snapshotted is actually defined in the volume snapshot resource. And here we provide the class name, the above class name that was created, and the persistent volume claim name, which we need to be backing up. So if you see in the first example, we created a persistent volume claim called backend. And in the snapshot object, we define that, okay, I need to take a snapshot of this persistent volume created by persistent volume claim name voting backend. So CSI driver will identify the corresponding PVC or the volume that got created and do a snapshot of that resource. Okay, so let's verify that. Okay, the snapshot got taken. Let's refresh. What was the value? Last time, okay, we had 13 cats and 9 dogs. Let's see if that value is restored when we get back. And if I go and quickly check these two resources, status of them, you get the volume snapshot says it is ready to use, which means the snapshot is taken, and the snapshot content has data about its operation as well on what it has done so far. And one more thing I will want to do is to verify if this snapshot matches what the snapshot taken in the Azure portal. So if I go ahead and run this snapshot content details, okay, it says I'm taking a backup of the volume handle, which starts with PVC minus DDD. We saw that. And then it also does the snapshot handle, which is where is this snapshot taken? It says the snapshot detail as well. Snapshot name is snapshot minus F9BDF. Let's go and verify Azure portal quickly if this is done. So you will see that there is a resource called snapshot F9BD. It's a snapshot type taken by the CSI driver. The app is still there. So let me go ahead and delete. So again, this is just disaster that I'm simulating. You wouldn't have this in a typical scenario. I'm deleting the application that I created in the first place. Let's say by mistake somebody went and some operator went and removed your application. You lost all your data. How do I recover my data? Right. So I'll go ahead and delete this one. Don't try it in your production. This is just for sample purposes. Let's wait for the resources to be cleared. Right, once these components are down, even my service will basically go down. If I hit this endpoint, it will just keep rotating. I think it's not available because the service and the corresponding parts are removed now. And underlying disk storage that got created by Azure will get cleared in a few minutes. It takes some time for the PVC resource to be removed. So this is the disk where the data is stored. We are simulating a scenario where the disk is deleted, and I'm trying to use the snapshot to bring up a new disk using CSI driver. Right, so now the application is down, the disk will go away in a few times. We will review on how I can restore my application. Now for restore, I have another manifest created. So what the restore information contains is, I have to define a new persistent volume claim. The first one is for creating a new resource, right? Dynamically provisioning a new resource. But for the second one, I'm specifically saying that, okay, I want to create a dynamically provisioned persistent volume, but instead of creating a new or empty volume, use this data source, this snapshot, to restore the data on that particular volume that you created. And once this is set up, rest of the configuration will remain the same. I just define a different name for the volume called restored volume backend one. because this is the snapshot name that we provided. Volume backend render is the snapshot name that we provided. So I say I'm trying to restore. This is a restored volume, and give the same PVC reference for the pod so that it knows which volume it has to attach to the underlying pod, and then rest of the details are same. So before we go ahead and apply this, let me do this kubectl get all my voting, and you should see there is no resource found in this namespace. Everything got deleted. And if I go to the portal, you will see that the PVC resource is also gone. You only have the snapshot object. So let's do the magic here. Let CSI driver do the magic for us and apply this resource. So now it's saying, okay, I'm trying to restore the backend data, and then it also creates the rest of the application. Let's watch if both the pods are running. And then let's see if the application is restoring the data that we created before. Voting backend will take some time. We can see the whether the resource is getting created here. Okay, Azure is still performing the operation. I could open the driver. I have to know which node the pod is running, and the driver should be able to give some logs on what it's trying to do. But keeping time in mind, I'll just go through this one faster. So you see persistent volume claim resource is created now. And let's verify if the endpoint is, so this is the new endpoint. Don't hit it yet because the backend is not ready, but you can keep it in your browser. Okay, now both are in running state. Let's do the magic here. I hit the new endpoint, and my data is back up. I still have my data restored, and application is still working. We can do multiple snapshot, incremental snapshots as required. But again, you may find some of these operations are very manual in nature, but this is just to give a perspective of what CSI driver can do and how it does this capability, so that if there is a failure, you're not able to see a snapshot or a backup available or data is lost, you can go and figure out how to recover your application. You can do some customization, some automation around having a Kubernetes job or a schedule job, cron job, which can take snapshot on regular intervals. And during failure, you can have a script that says which particular snapshot you want to restore to bring up your volume back to its state. So all of that can be done, and you can also maintain how many copies of your snapshot you want to retain and stuff. There's another popular tool called as Velero, which can automate some of these stuff. We will not cover in today's session. That requires a separate topic for itself. But Velero is a great tool, open source by VMware, which allows you to do backup and restore of your entire application, including persistent volume, your pods, your config maps, secrets, everything can be backed up to a object store with the snapshots and other capabilities and can be restored as required. So that we will, you can take a look at it at some point of time. Right, and the next one is, okay, so let's quickly move on to the Azure file-based implementation. I'll try to wrap it up by 11:50, so I'll leave some time for questions. So for file-based implementation, the only difference is we will be able to access the storage from multiple pods. I'll try to demonstrate that. Storage account is already created. Yeah, one thing that I did differently here is most of the examples that you would see online about using persistent file-based persistent volume is you need to use Azure storage key, store that in a Kubernetes as a Kubernetes secret, and then provide it as an input to your persistent volume or volume claim, or storage class. There is with CSI driver, there's new capability where you can use managed identity to access your volume. So what I've done is identify the kubelet identity of my cluster. And yeah, this cluster is created using managed identity. So I take the kubelet identity of the cluster and then assign a specific role, which is the storage account key operator service role. Now this role allows CSI driver to query the storage account key. You don't have to store the storage account key as a Kubernetes secret. The driver automatically retrieves the key you during the mounting operation, and using that key mounts the drive to your pod. And yeah, your pod's available. Next time, if something changes, if your key or something changes, you have to take some remediation steps to rotate the key on your corresponding application, which means just restarting your application. Your volumes will be refreshed to use the latest key. You don't have to store the key as a Kubernetes secret, which again has some security implications as well, because you're taking a key from some other source and putting it in Kubernetes as a base64 encoded string. So I have already done the storage account and the assignment. Only thing I will do is create a new app, Hello World app, where we will deploy this application. Let's quickly review the Hello World application. It has, again, a persistent volume definition. Here I'm using static persistent volume. So I've created a Azure file share already. I'm trying to mount that file share. So you will not see storage class. It just has the volume definition in it, which says what kind of volume it needs to be created, which is the resource group where the volume is, what is the storage account for that, this one, for the component, and share name. And like I said, it supports private endpoints. If you're using private endpoint, you will need to give the FQDN or the private endpoint domain name of your storage account so that it can go and connect to the storage account as required. These are the default mount options for your file share. You can explore other options as well. And the volume claim does not use a storage class. It is empty. Instead, it directly points to the volume name. This is the bigger difference between option 1 and 2. When we saw first example, it will only have volume claim with corresponding storage class reference. There is no reference to the persistent volume. This is the dynamic option. When we do static option, we will not have storage class, and instead we will just refer to the corresponding volume it is used. And here I'm giving storage as 1 GB, right? And I'm creating a single deployment Hello World app with 2 replicas. We will see if the pod is deployed on both the replicas on /data path, and this is where the volume is, persistent volume is referred. So let's quickly jump back to our command. I will deploy this app. Let's watch all the resources are created. It's pending, it's provisioning those resources. Or pending could be some other stuff. Sometimes when you see pending error, it may be some issue with the deployment. Okay. Oh, I think I have to delete the persistent volume. Yeah. So this is an important information as well. In CSI driver implementation, if the volume, every volume needs to have a unique identity. fire to associated to it. If you're creating a static volume, you need to make sure this is unique. So I had already created one PV, so it was telling me that, okay, this persistent volume is released, it could not be reattached. So I can either update this value here or just delete the persistent volume resource. So again, you don't have to worry about deleting the file share because this is a static volume, so it will not affect the file share. Okay. Let me rerun this after removing the resource. So yeah, the only changes, there was already a volume. I was testing this before, so that volume was already present. Next time when you have to run, you probably have to give a new volume name because it's trying to treat it as a new static volume. The names are referred accordingly. So I've deleted the resources. Okay, so let me run this again. Okay, and let's watch the resources. Okay, both the apps are running now. Cool. Sure. Let's go and verify if the data is accessible in both the paths. So if I go, so I'm logging, debugging into the pod and checking if this path is available. / data is available. If I do go into the data path, if I do ls, there's already a file called CSI test. This I created in my previous test. So if I do cat CSI test, you'll see that, okay, this is working. So I'm on pod 1, and now I'll try to simulate this right example, right? So I'm going to echo a file, but I'll now write into a new file. So we were able to read. Now if I do ls, you will see two files, CSI test and CSI test 1. If I do CSI test 1, you'll see the file, hello world from AKS pod 1. Now let's quickly verify this from the second pod as well. So we created a new file in the first pod, and let's verify that from the second pod. There's a path called data, and if I do, you'll see both the files available in the second one as well. If I do cat test 1, you see the file that we created, and I will also try to write from the second pod. This was the one that we talked about, access mode, read write many, where I can read and write from multiple pods at the same time. Step 1. So if I go to the file, I'll see both hello world from pod 1 and pod 2 available here. Yeah, so that brings us to the end of the demo. I hope you learned something about what we did as part of CSI volume. Again, this is just to explain what CSI volume or CSI drivers could do to help you with your persistent volumes, persistent data. But there's a lot more that you need to, or configuration that you may have to do in order to make your application fully resilient for failures like this. Common scenario where you will need backup and restore capability is when you're doing disaster recovery. Your application went down in East US region, you need to bring up in Central US region, then you have to find a way on how I can copy my snapshot to the other region and restore the existing snapshot. And the other ones are if you want to duplicate an environment because your team is now doing some testing and you want to do performance tests, you want the same data to be available, then you can do cloning of the data and restore a volume from the existing clone. So that brings us to the end of the demo. If there are any questions, I can take.
Thank you, Satish, for the wonderful session. We still not received any question from the team, any of the member. But I have one question. I'm just starting with the AKS platform. So like we already have in the AKS system, which is running some 7 to 8 pod. So is it possible easily to migrate from that existing file system to CSI, or it will give a lot of challenges or anything?
Are they using persistent volumes or they are stateless services?
But right now persistent volume.
Okay, and they are disk-based volumes or file-based volumes?
Disk.
Okay, so disk-based volume, there is migration support available with CSI driver. So once your application is migrating to, when you're upgrading your existing cluster to 1.21 version, by default, the storage classes will move to CSI driver based implementation, and existing storage classes will also be provisioned by CSI driver. So if you're using managed disk instead of managed minus CSI disk, your managed disk storage class will still be supported by CSI driver. There will be some time where you will be asked to change your manifest to use CSI managed CSI storage class, but for now it will work as it is. For file, I don't think there is support. You will have to make sure that your manifest is updated to use the Azure file CSI driver. But the migration hassle is not much. You upgrade your cluster, you have the CSI driver components or capability available to you in 121 version.
So you feel like how long it will take because right it is currently running in a production. If I want to switch from, because it's a real time solution, okay, we should not keep halt not for 10 minutes.
Yeah, so existing volumes will not be affected when you, disk-based volume will not be affected. It will work the same way even if you're moving to CSI driver. I would still recommend doing it in your dev test or UAT environment before you roll it out to production. Make sure that your application specific scenarios are validated. But from a capability perspective, if you upgrade, it will not affect.
Sure. So thank you, Satish. And so whoever listening in session, like we have a feedback link over here, and there's a session code. So you can give a feedback regarding the session about the Satish session as well as the community feedback.
Yeah, and I will give you the link of my code, demo code. Yeah. Please pass it to the audience so that. So this is where you can access the demo, and just let me know if you have any questions. And I'm available on LinkedIn as well. If you have any questions, let me give my LinkedIn ID. I don't know how to get my public. Okay, I think this is the one. Yeah, so I'm available on LinkedIn for any questions related to this topic. Cool. So I hope you like the session. Please share your feedback, and looking forward to share more content in future. Thank you for this opportunity, Azika.
Yeah, thank you, Satish. So our next session will be how to really work as a team from sleepy to strong pairing, programming from our stage. So like just adding the stage. Hey Stace, welcome. Good morning. Stace, I think you have a challenge with your microphone. I'm not able to hear you. No.
Okay, now you should be able to hear me.
Yes, Stace.
Can you hear me now?
Yeah. Please go ahead.
Awesome. It was
And all-
StreamYard picking up the wrong microphone. Sorry
Yeah,
about that. Good
department is
morning.
yours.
Thanks for having me. Well, good afternoon. So, welcome everybody, whatever time of the day it is where you are watching from. Thank you to the Azure Community Conference for having me here today. And of course, if my clicker works, thank you to the sponsors for making all of this possible. So today we're going to be talking about how to work together as a team and how to get from sleepy to strong pair programming. Now, starting off with a little bit of background, I love working with my colleagues. I love bouncing ideas between each other. I love that we can complement each other's knowledge and that we can use those combined talents to solve complex business or technical challenges. Basically, I love working in close-knit teams. Unfortunately, that hasn't happened as often as I would like it to in my career. Rather, all too often, I've worked in groups where each team member is working on something different. Now, that might be that they're working on a different set of stories from the same project. Sometimes it's even been entirely different projects from each other. And that means that we are all working on something different. So that we're all basically independent from each other. Sometimes we have to be independent from each other. And I find that word interesting, independent. Because if we're supposed to be a team, then how can we be independent? Are we a team? Or are we simply a collection of colleagues working together at the same island of desks? And that word, independent, it comes with a cost associated with it. For starters, inside of my team, I now have way less insight into what everybody's doing. Outside of that 15-minute stand-up that nobody wants to attend because everybody's talking about completely different things and everybody zones out after about 5 seconds, we don't really communicate with each other about what we're doing. And because of that disconnect, because that connection is lost between us, even if we're a really close team otherwise, bouncing ideas, helping each other out, it becomes really hard. Because when we do try to bounce ideas between each other, when we do need to help each other out, one or other of us has to do a huge context switch. And that means that we're just interrupting people and stopping them from doing what they're supposed to be doing. And it gives our team other issues as well. We now have way more work in progress because everybody has their own sets of stories, which means that one person's having to do all of the work, so it takes longer to complete. The lead time is longer. And if each team member has their own set of stories, then we also have issues regarding resilience inside of our team. Because if each person has their own area, then what happens when that person wins a lottery and quits the next day? Or maybe more realistically, when that person goes on vacation for 2 or 3 weeks. even if they're just unexpectedly ill. All of these things interrupt our ability to provide value to our customers in a timely fashion. But I promised to talk about pair programming, and I've not really done that yet. So why do I think these things are connected? Well, one way that I think you can really help teams not fall into that trap of being independent people at the same island of desks is to pair program. Now, when we do this right, we get to work together. And I mean, we really get to work together to think of better solutions, to encourage that better collaboration, and to implement that value for our users with less lead time. Hi, I'm Stacey Cashmore. I'm Tech Explorer DevOps at Omniplan in Amsterdam in the Netherlands, and I've been developing software since around the mid-1990s. And for the last couple of years, I have been honored to be able to call myself a Microsoft MVP for developer technologies. Now, how did I get into pair programming? I want to quickly cover that before we get into the pair programming itself. And basically, I really started to do it at my previous job. I worked there for 14 years, really enjoyable place to work. I started back in 2006. But the day that I started, we didn't have teams. We just had a development department. And in fact, my first project on day one, as soon as I installed my machine, was to implement this really complex algorithm in the middle of our insurance engine. By myself, I could ask people for help, but I wasn't working with anybody. Now, we did have some bigger projects, and they did have more people working on them. But again, they were still individuals on completely different facets of this project. There wasn't that close collaboration. And we saw the issues that this could bring. We saw the problems with our projects. We saw things not being thought out because one person wasn't getting the insights from other people as they were going along. And so in 2012, we decided that we were going to introduce Scrum to our department. We were going to work in teams, and hopefully this was going to help us. But actually, all that we saw is that we then had teams full of individuals. And this actually brought us more problems than it solved in the beginning. We had questions coming out of the teams like, how can we all work on this same project? We are working on the same services. We are working on the same HTML. We're working on the same ASP.NET pages. It's in the same code base. We are in merge hell. This is just really slowing us down. We can't do this. Well, over the next 6-7 years, we spent a lot of time trying to find what worked for us. And my last team that I worked at before I left, we were always experimenting. It was a really rich environment to try new things. And always trying to find that thing that worked for ourselves to make our work more enjoyable, to make our work easier, and to produce better output. And pair programming became a huge part of this. It was an amazing learning experience. It did take an awful lot of effort to get working, but we saw the dividends that this effort brought back, not only for us as developers, not only for the team, but also for the company as well. So, if I say that it's so awesome, and if lots of other people on the internet say that it's so awesome, why isn't everybody just doing this? And well, I'm afraid to say the reason why is because there are things which, if they happen, and in my experience, they're likely to happen at the start, they make pairing slightly less than great. So it's not that amazing experience that I'm after. I'm going to talk about the two most common now, and then we'll see what we can do about them. Now, number one, I call sleepy pairing. Now, I'm sure if anybody's trying to do pair programming, the first thing that happens is this. That's always been my experience. I'm sure we've all seen it. Two people behind one machine. You have one person at the keyboard. They are feverishly working away there. They are bashing the keys. They are working through the problem. They're coming up with a solution. They're fighting that solution when it doesn't quite do what they want. And they're turning all of this into code and getting it into the computer. Then you have the second person doing one of two things. Maybe they're sitting just behind the person at the keyboard, silently, staring over their shoulder at the screen and the keyboard, making that person at the keyboard feel really uncomfortable. Or maybe the other one that I've experienced an amount is the other person, they're sitting like a meter or so away. They're a little bit distracted, maybe playing with their phone. Occasionally they glance at the screen and go, yep, before they return to Facebook, Twitter, shooting zombies in an MMO. And I liken this to a long car journey. You have the driver. They're concentrating the whole day. They are looking for traffic problems. They're trying to figure out which way they need to go to get to the destination. And they are watching the road, constantly trying to keep everybody safe. Then we have the passengers. You've got that backseat driver, making the driver feel really, really uncomfortable because they're just being watched the whole time and feel judged. Maybe you've got that passenger that's just sitting, staring out of the window, watching the world go by. Or maybe you've got that person who's really lucky that they don't get motion sickness and they are just binging on Netflix until the phone battery's dead. At the end of this journey, the driver gets out of the car. They stretch, they walk inside, they're exhausted, they're just looking for somewhere to recuperate. They've been concentrating so long, they've got a headache, the muscles ache, they just want to close their eyes and chill. Now, passengers, meanwhile, they're exhausted too. They're not exhausted because they've been doing all of those things, they're exhausted just because they've been doing nothing and trying to stay awake. And so it is with our developers in sleepy pairing. That person at the keyboard, that person doing the heavy lifting, they're more tired than they normally would be. After all, they've been doing the same as they normally would do. They've been doing everything. Only now they've been doing it with somebody watching them, so they feel judged the whole time without actually getting any help. And that person watching, they're also tired. It's really exhausting to watch somebody work at a keyboard the whole day when you don't feel involved and when you think that you're not quite using your time as wisely as you should be. And that person with a phone, they have an awesome score on that zombie MMO game. Amazing. But they also know that this isn't necessarily what they should be doing with their time. Either one of them feels useless because of it. And so the next day, we return to our own machines when we're allowed to work together in the physical world. Put on our noise-cancelling headphones to drown out the noise of the open plan office and go back to working independently. You know what? Yesterday was a complete waste of time, and so's pair programming in general. So that's our navigator being sleepy. But it's not only the navigator. The driver can be just as sleepy and the results are just as bad. And we saw this happen when we tried to introduce the driver navigator roles explicitly in our work. So we have our driver. They have the keyboard. They are entering the code. Then we have our navigator. They are now the person that actually have to solve the problem, and they have to tell the driver what to do. Now, doing this brings fairly instant results for getting both people working together. That sleepy person watching yesterday, the one who's taken the navigating role, well, neither the yupper nor the zombie killer can do either of these things. They have got to be actively involved, because if they're not, that driver, they can't drive. This is awesome. We now have both people involved in coming up with that solution and getting that solution into the machine. They are working together to solve problems. We've got the navigator coming up with ideas, figuring out how to solve problems, finding out which way we need to go. And you got that driver listening to the navigator, listening to that solution, creating that solution at the keyboard. It sounds idyllic. This is what I want from working together with my colleagues, doing stuff together. People around the typist here, they are actively involved. No more yupping. No more zombies. Only I'm not so sure. There is a zombie here. Only it's not the one in that MMO game. Rather, it is the typist. And I'm using that word very deliberately. The typist. They're sitting, banging in the words that the navigator tells them to do, sometimes down to put if statement on line 11. And whilst they're doing this, they're not thinking about what it is that they are putting into the computer. Going back to our drivers again. Have you ever read stories about drivers that are using a satellite navigation system? And they just take everything that that system says, and that is what they have to do. They do it without thinking. So they end up lost. They end up maybe in the middle of a field. In the really worst cases that you see, they end up down lanes that cars really shouldn't go down and trapped between two narrow buildings. Sometimes they end up in water. In the worst cases I've read about, when you've had the same destination in two different countries, they've ended up in the wrong countries. The navigation system says to them, "You have arrived." And the driver goes, "Well, yeah. Where? How did I get here? Why are my feet wet?" And with our developers in this situation, we get to that end of the day, and you know what? We're exhausted again. That one person that has been doing all of the thinking, they are truly exhausted. Because whilst they've been doing all of the thinking, they've had to explain so much to the driver, and they've had to wait for the driver to type in the words that they're talking about, whilst the driver's not using all of the shortcuts that they would be, so they're getting frustrated. It's not fun. And they can't continue their thought process until the driver's caught up, because otherwise you get way too much of a gap between the two people. And our typist, that person bashing away on that keyboard with no thought, they're also exhausted. Yesterday, the person at the keyboard was exhausted because they picked up all of the work. Today, they're exhausted because they've just been told what to do on a micro level the whole day long. And you know what? They didn't become a developer just to put somebody else's words into a computer. I'm not including Stack Overflow here. That's still allowed. So the next day, our developers return to their machines. They put back on their noise-cancelling headphones, drown out their open plan office, and they go back to working independently. Previous day, it was still a complete waste of time. And you know what? Except for maybe really complex problems, so is pair programming in general. Now, with these two issues, that sleepy navigator, that sleepy driver, when you hit these walls, it can be really hard for teams to continue past these stages. When I was working with my team and we were experimenting with this, we hit these stages several times and then stopped because we couldn't quite break through. And you know what? I've also heard them used as the biggest reasons for companies I've spoken to, for developers I've spoken to not even give pair programming a try. Because you know what? It's just too costly to pair. Teams give up before they've even started. But there's things we can do here. We can help these situations, and we can make it so that, like I say, that effort that we have to put in to get this work gives dividends back way more than we actually put in. So let's tackle that sleepy navigator first. Now, when we started to investigate why we ended up being sleepy navigators, something that we noticed is the world is full of distractions. And yeah, this is a huge distraction. Most of us in this day and age are kind of addicted to our phones. I know that I am. And they provide a world of distractions for us. Email, Slack, Teams, Twitter, Facebook, WhatsApp, TikTok, Instagram, whatever else you use on social media that's always coming up with updates. And if our fingers aren't busy actively dancing over a keyboard, it can be so easy to give into that distraction and pick the phone up. In fact, normally when I give this talk in person, there's like 1 or 2 people in the audience that like give me a really sheepish look now and go, yeah, okay, put the phone away. Now, getting past this distraction takes a lot of mental energy, and each person's going to need to do it in their own way. What worked for me was just getting rid of the phone completely. You see, when I started to notice this was happening, what I ended up doing was taking my phone and put it on the desk next to me so that it wasn't directly in front of me. But that didn't really work. And it didn't really work because all I did was when that click happened in my head, I stretched to grab the phone, I checked it, and then I stretched to put it back. This is great for the daily workout. Not so good when you're trying to work. Eventually, I realized I've just got to get rid of it completely. So I picked it up and I tossed it under the monitor onto my desk that was behind the desk of my colleague. Carefully, this is a glass smartphone. It's not a Nokia 3210. And when I did that, it felt awful. It felt really, really bad. Like I say, I am addicted to my phone. There's been studies to show that the human brain changes when you use a phone. You actually get pathways and you really do get physically attached to it. So it feels bad at the start, but it worked. After a while, that pain went away and I could concentrate way better than before and I could join in way better than before. I came to realize that none of the things I was checking, that Twitter, WhatsApp, TikTok, Instagram, whatever else you use, it's not actually important. It's FOMO, fear of missing out. Something's happening and I don't know about it. And it's also habit because we just get into the habit of doing it. Now, email was a much bigger issue for me. See, if I'm working on my own machine, then I get a notification from an email. Now, that's an entirely different talk as to whether or not that's a good idea, but it was there. And I could see if something urgent came in, if there was a question that I desperately needed to answer for somebody, if there was a major issue and we needed people to fix it, if production was on fire and the website's down and I've got to get involved. Now, when I moved to my colleague's desk, I still had that on my phone. I could still be contacted. When I got rid of the phone, now I don't have the notification. I don't have it on my phone. What happens if people can't find me and these things happen? Well, you know what? Turns out it doesn't matter. Because I came to realize that if something is that urgent that me not responding to an email is a problem, they're going to come and find me. And if they're not coming to find me, if they're not actively looking for me, then obviously it's not that important in the first place. So we can remove these distractions. We can get the navigator more into the flow, but we still need to take care of that sleepy driver. Now, we had lots of talks about this, and what we figured out is we needed to tweak our definitions to get into the right mindset before we started. So we changed it just a little bit. We had our navigator, somebody who thinks of a solution. And then they explain their solution, and they do that until the driver understands enough to write their own code. We never tell them the code to write. We explain our solution instead. And our driver is someone who listens to the navigator, and they do their best to understand what the navigator is trying to achieve, and then they turn that understanding into code. They never write the code the navigator is telling them. They have to write their own code based on the solution we're coming up with. To return to our driving metaphor one last time for today. When you're driving, you're using a satellite navigation system. Your job isn't to listen to that system and to do what it says without thinking. Your job is to take those instructions, to think about them. Are they correct? Are they going to make you reach your destination? Is it safe to use them? How can you make sure that you arrive at the right place safely? That is your job as a driver. And so it is with the driver in pair programming. You're not just typing in that if statement on line 17 that the navigator tells you. You are listening to that navigator. You are understanding the solution that they're trying to come up with. And then you are writing your own code. And if you don't understand what the navigator's doing, well, then you don't write any code. It's as simple as that. And as a navigator, you need to make sure that the driver can get this understanding from your explanation. And when that understanding isn't there, you need to do this in a different way. You need to explain it differently. What you don't do, and I've seen in the past, is simply grab the keyboard and say, I'm just going to quickly do this one and then we'll continue. The reason why we don't do that is because the second you do, we are back in our old flow. We are now back in sleepy pairing, and that person watching is doing nothing but watching. They don't know what you're trying to achieve. They're not looking at the code. Now, this can mean that if you really struggle to get your idea over, that you leave the keyboard, you walk to a whiteboard, you start to sketch out your ideas, and you have a proper discussion. I don't see this as a downside. We made much better software when we actually did this process than when we just quickly stole the keyboard. Because that other person, they are now actively involved. We are bouncing with each other, and we are making sure that we are producing the best fit solution from the both of us. Now, as a driver, there's going to come times when you're halfway through taking that understanding and suddenly that light bulb goes ding in your head. You get excited because now you know exactly how we need to solve this problem. You know how we need to take the solution and move it forward. And what we do not do is start to excitedly put our undoubtedly awesome solution into the keyboard. Rather, we excitedly give the keyboard to the navigator. We tell them about our amazing idea, and we switch roles. We are now navigating, they are now driving, and we now have to get them to understand what our awesome idea is. Because again, the second you just start typing, you lose that other person and they're no longer involved, they're back to sleep. Now, we found that if we ensured we fulfilled these roles in this way without distraction, being that active member of the pair, we moved from sleepy pairing into strong pair programming and formed a really great team. Now, all this can sound awesome, but I've been talking about doing things in an office, getting up and walking to a whiteboard and everything else, and for the last 18 months, that hasn't exactly been our experience, has it? So let's have a look at what we can do for remote pairing. Now, back in 2020, I gave this talk in Stockholm. And at the same conference, I was invited to take part in .NET Rocks, talking about pair programming in the presentation I'd just given. At one point, I can't remember who, it was either Carl or Richard, obviously, they asked me, what do I think about pairing remotely? That was a curveball. I wasn't expecting that one. It's not something I'd spent that much time thinking about back then. And I think if you listen to that episode, you can tell from my answer, because basically my answer was, well, I've done it once and it worked kind of well. You see, my colleague and I were busy pairing in the morning, but I needed to be at home in the afternoon. We didn't have audio because our machines in the office weren't set up for audio. So we were communicating through Slack, through shared screens, through Notepad that we could both type in. And it was really, really hard But we did manage to make it work. Even in that situation, we managed to make it work. But there's a proviso. At the time, I thought this is only going to work if we have a huge amount of psychological safety in place before we start to pair. Psychological safety is really important when pair programming. Me and my colleague, we had an awesome working relationship already at this time. We often paired in real life and we could bounce between each other really well. We thought on the same wavelengths and it just clicked. It worked. It was one of those colleagues that you find in your jobs that it's just, yeah, me, him, working together, awesome. And that meant that the hardships offered by this woefully inadequate setup that we had, it hit us, but it didn't hit us too hard. But without that trust, without that safety, you're not going to be able to pick this up remotely very easily, just from the start. I really don't want to do this without that safety net. Super hard, lots of challenges. This was 3 weeks before lockdown in the Netherlands. Interesting. And at the time, I was also changing jobs. In fact, I got back from that conference and then started my new job the next day. And that meant those 3 weeks, I was just getting to know my colleagues. And if I'm honest, I was there to help them improve the way that they work together. So in those 3 weeks, I was just really infuriating. I really didn't think that that psychological safety was going to be in place because who likes change, really? It's hard for people to do. But then suddenly, we're all working from home. We can't be in the office. We can't build up that psychological safety face-to-face. And to my surprise, that team I was working in, they all started pairing. They even started mobbing remotely without building up trust beforehand. And it still worked. The team, they really started to enjoy their pairing sessions. One of the things that it gave them, especially in lockdown, is actually a connection with the people they were working with. You see, ordinarily, they would be having lunch with those people, they would be having coffee with those people, they'd just be having 5-minute chats with those people when they needed a break. In lockdown, that wasn't happening. So this just gave them a connection to the team. Now, it did give a lot of other challenges. I'm not going to go too in depth with that, but I do want to talk about some of the things. So firstly, if you are remote pairing, sleepy pairing is way, way, way harder to avoid. It was something that the whole team had to work hard on to try and make sure that people are engaged because it's just so easy to tune out when you're in different locations. People disappeared from the stream and it wasn't seen. Maybe they were on mute because of background noise. Not everybody's comfortable having video on, so a lot of people were without video. Maybe they didn't think they had something to contribute at the time and they started to drift. They're just watching a shared screen, which is maybe blurry, it's maybe shrunken depending on resolution differences, and they fade away. Now, in the office, as a driver, you can kind of spot when this happens, especially if you're doing strong pairing, because it means you're no longer getting ideas from your partner. You can do something then to try and spark that energy back into this session. You can suggest a drink, a walk, a break. But here, we can't physically see that other person. We can't see what they're doing. We can't see when they fade away. And it's so much easier to just go back to programming by yourself with somebody else on the stream. We also noticed when pair programming remotely that switching roles, it just didn't happen as often as we'd like. It can be hard to switch roles when you're sitting next to each other to remember to take that step. When you're not sitting next to each other, it is really hard. You maybe need to give control of your screen to another person with all of the latency and lagging that brings with it. Or maybe you're going to commit, you're going to push to your central repo, The other person's then going to pull the repo, they're going to open their solution, and at that point you can continue working after a humongous context switch, which makes all of this harder because can you remember what you were doing before the context switch? Not always. And all these things added up, which just meant that sometimes one person was driving for hours and they shouldn't have been. They ended up driving and navigating together just because we couldn't switch roles easily. Altogether, this just meant that it was harder to bounce ideas between each other. When only doing voice, you can't see the body language of that other person. Even when you're on video, it's harder to see that other person. You can see the top half of my body now because I'm standing up and I'm a little bit of a distance away from the camera. But if I'm sitting at my desk, chances are you're just going to see my head and shoulders. You're not going to get to see the rest of that body language and you miss an amount of communication. Like I say, that's for people who don't mind having their camera on. For people who don't want their camera on, you have absolutely nothing. So what did we do to solve this? Well, one thing that we tried to make sure that we could swap roles easier was to use things like live share so that we could all code on our own machines. Now, that experience was either absolutely awesome or it was profanity-inducing annoyance. When it works, it's great. When it doesn't work, it's not fantastic. See, what it gave us is our own development environment that we could work with. I'm no longer looking at somebody's ultra-wide screen monitor with a load of black bars top and bottom and a load of squished text in the middle. They're no longer looking at my 4K display where everything's just squished. I'm using my monitor, my keyboard that I love, my mouse, I'm using my VS setup, my extensions, my themes, and I can take over at a moment's notice. If it wasn't possible to use live share, then we found that forcing those moments of switching helped. We started to use a Pomodoro technique. Every 25 minutes, we switch no matter what, just to make sure we had that cycle going. Trying to make sure that we kept everybody involved because you know you're going to be taking over soon. It wasn't perfect, but it did keep people engaged. And finally, when we're with more than 2 people in a call, we always made sure that somebody took the mantle of the devil's advocate and they took it to heart. They ensured that they kept us on track. They asked questions when everybody was all agreeing on the same thing, just to make sure that we weren't being blinkered, and we considered alternatives. They made sure that people were involved in the discussion, and if somebody was quiet, they would actively try and bring them into the discussion. And they'd make sure that if somebody was running away, driving and navigating at the same time, that they were stopped and we could swap and continue. Still harder than in the office, but if you get the discipline right, if you put that effort in, it still works amazingly well. And in fact, there's a few teams that just use this as their default way of working now. And I know they're planning on doing it when they get back to the office as well. They've seen the benefits that it can bring. So what benefits am I talking about here? Well, let's start with collaboration, because that is the thing when you get this right that really skyrockets. We are now really working together. We are not working on different things. We are not working on our own stories. We are working together to get a story finished before we move on to the next one. And that means that we are bouncing ideas between each other. We are helping each other improve. And this is a really cool one because not only are we helping each other improve with our knowledge of the application, our knowledge of the business, we're also introducing each other to new techniques in programming and new parts of the language and the framework that the other person doesn't necessarily know about. We all have our strengths and weaknesses, and we amplify each other's strengths and we dial down those weaknesses when we work together. We are using our joint talents to solve problems together. We also communicate a lot more, and we also communicate in far better ways. Now, this one for me is a little bit chicken and egg. You see, I don't know if we improved our communication, and so we improved our ability to pair program, or if we learned to pair program and then our communication organically evolved as we did so. I'm not sure. But either way, our communication did improve when we did this. And that means that we are now sharing knowledge by default at the beginning. And that gives a big advantage on its own. Everybody has more insight into the project. And that means that when that person wins a lottery and quits, or goes on vacation for 2 weeks, or is unfortunately ill, it's not the same huge problem that it was before. Because we are now pairing with each other. There's at least 2 people who know what's going on, 2 people who know what the state of a particular application and story is, each person in the pair. And that means that that remaining person, the one that is still in the office, they can now start a new pair. They can work with somebody else. And when we do that, we spread the knowledge yet again. We also noticed a huge improvement in our pull request process. It became smoother, it became simpler, and because it's an ongoing process now, it stopped us having to context switch. You see, when we do this right, that driver that's listening to the navigator, they are validating the thoughts of the navigator. They are validating the solution that the navigator is coming up with. And they are doing this in real time. They are catching problems before it even makes it to the keyboard. And we're improving as we go. And that navigator, they are watching what the driver does when they take that solution and that understanding and they turn it into code and they actually make the technical solution. And if they spot something there which they don't think is right, again, they catch it in real time straight away, which is the cheapest place to catch it. And that meant that when we came to our pull requests, and as a pair, we actually managed to keep our pull requests far, far smaller when doing this. And we kept them far more manageable because we kept each other on our toes and we made sure that we were concentrating on the right thing. Our pull request process was actually really simple. We double checked the changes that we were going to commit just to make sure that something hadn't crept in that we weren't thinking about. We then made our pull request because we had to for auditing reasons inside the company. The navigator ran back to their machine. The navigator approved the pull request. We'd grab a coffee whilst it was merged into the trunk, and then we would pick up the next task. Now, it is really important to say that whole thing of keeping each other on the toes, double checking your commit before you make it to make sure nothing is snuck in. This is really, really important for this. If you don't do those steps, then this whole benefit is lost and yeah, you might actually end up in a worse place than you were before. But if you put the effort in, if you keep on top of things, then it just makes everything so much smoother. And if I compare this to our old way of doing pull requests, well, basically, that involved finishing an amount of work, knowing that you were going to have a huge gap between finishing the work and getting your pull request approved. So you're probably going to do too much rather than changing 3-4 files and doing one atomic piece. You might change 20, 30. I had somebody send me a 500 file pull request at one point. I rejected that. And when you've got this pull request, you throw it at another person. You say, when you've got time, can you check this, please? That person has to come out of their flow. That person has to check the pull request. They have to understand what it is that you're trying to achieve. They have to check that you're doing it right. They have to completely lose track of what you're doing in 100+ files. As the adage goes, if I give you a pull request with 1 file, you'll probably find an issue or 2. If I give you a pull request with 10 files, you'll probably find 8 issues or so. If I give you a pull request with 500 files, it's probably fine. And they did this. They spent a lot of time doing this, taking them away from their work as well. And then they threw it back to me. I've now got a context switch because I'm now working on a completely different thing. So I context switch, I look at it, I either fix their comments and resolve them, or I answer their comments and give a reason why I'm not going to resolve them. I throw it back again, interrupt them yet again, and this thing ping-pongs, and the amount of context switching is just a nightmare. Like I say, when we're pair programming, the only context switch we had was when we got that coffee before starting the next task. Everything else was just a constant flow of work, actually keeping us in the zone rather than taking us out of it. Now, the last benefit that I really want to talk about actually came from our onboarding process and how we got to start working with new developers and new testers in our pairs. Whenever I've started a new job, it has always been a truly daunting task. You get a machine, you get a big stack of paperwork, you spend time trying to learn the system, working through that paperwork. These days, it's likely to be a wiki with loads of pages, and you just got to read off a screen, which is never fun. You're just struggling to try and be productive. And in some really complex systems, it can take weeks or so before you achieve this. So rather than doing that, we started to just let the person install their machine, and then we got them into a pair straight away. When we did this, we noticed that everybody got bonuses out of it. That newbie, that person starting, rather than reading this huge stack of paperwork, which might even be out of date, they actually got all of the experience about the code base, about the domain, about the business from their partner. They got all of these insights as they were going on. And don't think that the partner doesn't get anything from this, because that person also gets that clear insight that seriously only somebody who has never been connected with a project before can give. Everybody gets a benefit out of this, and even better than that, we are productive from day one with this person. Now, is this pair as productive as a pair that's been there for a while? No, of course they're not, because one person's still loading a code base and they're having to find things. But they're way more productive than they were reading that Wikipedia page. So when I talk about pair programming with people in real life, outside of doing this talk, a question that I'm often asked is, why do I advocate it? Why does this thing speak to you so much? And I like to paraphrase what Jeepor Hill says about TDD on Twitter for this. Basically, because we are in this for the money. Pairing, when practiced, when done correctly, it gets value into our users' hands, and it gets that value there quicker. And it gets value there with more thought about what it is that the user actually needs to be able to use our application with more ease, more thought about how we're going to structure our solution, and more thought about the code that we're doing in order to solve it. I love pair programming. I love it with one. I love it with multiple people. I love mob programming too. And I love it because of the benefits that I see that it brings to us as an individual, as a pair, as a team, as a company. Now, make no mistake, this is really, really hard. If it was easy, we'd all be doing it already. But I invite you to give it a go. Put that effort in at the start. Get past those sleepy stages. Figure out what you need to do to get into that strong state of pairing, and just see what benefits it can bring you. Now, I'd like to thank the partners again that managed to make this conference possible, and the conference organizers for making this all available to us, and of course to all of the communities around it. I've been Stacey Cashmore. I want to thank you so much for spending your time with me this morning. I hope you enjoy the rest of this fantastic conference, and have a good day.
Thank you, Stacey, for the wonderful session. So, like, I've been programming for more than 10 years. I'm just listening each and every word of yours. Is like feel I can relate, and I can feel that okay, we can improvise in the pair programming. Thank you for the wonderful session.
Sorry?
Are you able to hear me?
I can just about hear you. Yeah, sorry.
Yeah. So like I'm just working for more than 10 years, like in the same industry, and I just patiently listening your each and every word in the conversation. So I'm just been able to relate it for the past 10 years and what I've misstated, what I can improvise. So this is feels very interesting session for everyone. So thank you for the session coming to this technical track. It's more useful to understand and can grow and evaluate within the session. Thank you. Thank you for the beautiful content, Stacey.
Yeah, thank you very much for giving me the chance to give it again. It's and I really hope that people give it a try and see what it can bring for them. It's it, actually I've been programming since the mid 1990s, and seriously, the last 4 or 5 years when I've really got into pair programming, I have really seen how my own skills have improved. I'm really seeing how we can level each other up. It can bring huge benefits if you put that effort in to get it right.
Sure. Yes.
And if anybody does have any comments or wants to chat about it, then you can always find me on Twitter at Stacy_Cash.
Stay, we just wait for 2 minutes, and if we
Okay.
get any feedback or any QA, we'll share, we will discuss.
Is anybody watching? Have you got any experience with it, either good or bad?
No, I'm just more happy that now I can relate that okay, what I have done wrong, and now it's feeling like the pair programming, like oh, it's a very interesting part which we have missed in our the current industry standard we have missed for last. I'm really like worry about that, okay, why I missed this pair programming since this much of year having experience. Now I will just take your but I will revisit the same session what you just spoke with Dil. I will just listen one more time and take a note and what are the point you just mentioned. Definitely I will take it and slowly I will implement one by one.
Yeah, if anybody does want to give it a try, by the way, and I think this is worth mentioning as I've got a couple of minutes left on my time. I have had managers that have been really against it because for them it seemed like a bit of a waste of time. And what they came out with was comments along the lines of pair programming cannot be efficient because two people at one keyboard are never going to write as much code as two people at two different keyboards. And my answer to that one is always, as a software developer, you're not hiring me to put code into a keyboard. You're hiring me to solve problems. And in fact, the less code I can do to solve your problem, the better, because that makes it more maintainable. So, don't judge me on the lines of code that we're writing. Judge us on the solutions that we're giving, and that is where you can really get the benefit from pair programming. You will get those better solutions, and you have less lead time. So, you get your value back sooner.
Thank you for the beautiful insight. Like it's giving a starting point. I guess it will helpful for everyone. And so like so you just I just share the conference link feedback link. You can give a feedback and about the presentation and as well as the community. So I just mentioned the session code. So you just whatever session you feel that okay, this is session code refers to of the current session, and you can give a feedback with giving the session code. Thank you, Stace. Thank you for the wonderful session.
Thank you for having me.
Yeah, thank you.
Bye bye, all.
Bye bye.
Hey Dinny, welcome. Glad to see you.
Hello, nice to see you.
Hello,
Do you hear
nice to
me
see
well?
you. Yeah, I can.
Oh, nice.
Thanks for joining. It's your time. Maybe it's more than IST. So Danny is going to speak AI for the better. So Danny is a IT coach with speaker. He is from Belgium. Okay. So thanks for your time. So all the best your session, Danny. It's for you. Stage for you. Go ahead.
Thank you very much, and welcome everyone, and welcome to my talk, AI for the Better. I'm going to share my screen right now. Okay. I click window, I click full screen, I click 3, I click system sound. Okay. We should be on a roll, and you should be able to see my screen.
Yes.
Okay. then we can rock it on.
That's great.
So
Yeah,
I'm
that's great.
very okay. I'm very honored to speak for the India's largest Azure conference, the Azure Community Conference 2021. It's a real honor to be invited to that conference, to that virtual conference. And then I just want to thank. I just started thanking the major sponsors, the gold sponsors, the biggest sponsors, and then at the end, of course, I'm thankful for all the sponsors making this event possible for everybody. I'm Danny de Klerk, and I'm president, developer, and Microsoft MVP. I have my own nonprofit. I founded my own nonprofit in Belgium, the DSoft, and we help people from social field with IT. We help the social field with IT knowledge, with a big focus and emphasis on accessibility, but not only accessibility. But today for you, it's a talk about accessibility or a talk about how you can work with AI to increase the quality of life of people with disabilities. That's what I want to present you today. But as a speaker, I speak in common about a lot of topics. It's coming from really non-technical adult to very technical, but most of the time, or it has always a link with accessibility or social field or inclusion, sometimes in the broad sense. But yeah, that's my passion, helping people to live a better life with technology. And today the content will be, I'm going to give you a primer into accessibility. I'm going to talk a bit about the Microsoft Cognitive Services API. I'm going to give you some information about problems that people with disabilities can have. And then, of course, it's time for demos, because a lot of people like, and if I go to conferences or if I watch virtual conferences, it's also attending a conference. You love that speakers show you demos, show you in real life and not only slides. It's amazing to see demos, how easy it is to achieve quite nice things, honestly. But I should say start with start, and I should start with, I said, with a primer into accessibility. So why not? And if I talk about accessibility, I talk about making software solutions, IT solutions, AI solutions to make the life or the quality of life for people with disabilities better. That is the focus point if I talk about accessibility. And then you can start, okay, people with disabilities. What are you talking about? So you have people with learning disabilities, you have people with autism, people on the autism spectrum, you have people with visual disabilities, so that's people who have blindness or vision loss, people with auditory difficulties. This can be people who are deaf or are hard of hearing, people with motoric restrictions, and honestly, you have also a lot more. And you even have combinations of disabilities. For example, a person who have autism and an anxiety disorder, or have autism and has a visual disability. So it's all possible. But today, the biggest focus, not the biggest focus, but a very big focus today will be people with learning disabilities. And why do I do that? Because that is a group of people with disabilities that with the least software for, with the least solutions for. And the reason is the least people know that disability. A lot of people know about what you can do for people with vision loss, and it's great because it's really needed. Screen readers are working great, but a lot of people know if you have people who are hard of hearing or are deaf, maybe it's important to have captions below the videos. But learning disabilities, not a lot of people, especially not in the tech scene, know that kind of disability, and that is the disability that my major experience is in. So, and these are the people with the least of accessible tools, so where the most of work is need to be done to make the world inclusive for them. So people with learning disabilities have significant limitations in both there is intellectual functioning and adaptive behavior. So what is this? So we going split that up. And intellectual functioning is also called intelligence. So they have a lesser intelligence. You can also call that mental capacity. I don't like, if I talk about inclusion and accessibility, I don't like to be too strict and too rigid in numbers, but just have you an idea. The people who have most of the time have the diagnose, people with learning disabilities, you can think about the IQ score between 70 to 75. If you know that just normal intellectual functioning is about 120. But as I said, don't focus too much on numbers, but you see, if we talk normal 120 and then 70, 75, you guess what I mean, girls and guys. And to have the diagnosis learning disability, you always need to have, and you always also have difficulties or call it problems with adaptive behavior. And of course, that comes from the intellectual functioning or dysfunctioning. And, and adaptive behavior are conceptual skills, language difficulties, literacy, concepts like money, time, and numbers. So money can be very difficult, time, numbers, math. Social skills also, social responsibility, but also self-esteem can be lower or can be low. Difficulties with practical skills, there can be difficulties with activities in daily living, washing, brushing teeth, making dinner, food, personal care, healthcare. These are all problems that people can have. And if I talk about accessibility, I always start of the vision. I start from the vision of inclusion, and the principles of inclusions are that people with and without disabilities, you can even broaden up to all people in the world, so also people from other minorities. But yeah, my focus is people with disabilities, so I talk about people with and without disabilities are doing the same activities, are living in the same district, are working together, and of course, adjustments are done or can be done per person. So it's not an institution for people with disabilities miles away from their family and their parents. No, that is how the past was, and that's not how inclusion works, and that's honestly not the world where we live. You don't want to have a family member or a kid with a disability or a severe disability that you just place away. Of course, you want them to live as close to be and as normal as possible with adjustments. And technology can help there. Not only technology, also coaching, but yeah, at the technology conference, so and my impact is on technology. And if I talk about people, so technology, then I made the link to digital difficulties for people with disabilities. So PWD is the abbreviation of people with disabilities. So I say it clear and just to have some more space on the screen and a beautiful title. So if I think about learning disability, it's about reading, understanding. So maybe difficulties with reading the website, understanding the structure of a website or an app. People with autism can have difficulties with understanding, with seeing structure. People with blindness, with vision loss, so have a decreased ability to read, a decreased ability to navigate, by example. This can be navigating in the real world, for example, on a global positioning system, GPS, or on a website, a digital system. And people with auditory disabilities can have difficulties with hearing notifications. So if you work with notifications, it can be that it's not seen or not heard by people. And also following movies without an audio description. This can make sense into the world of software development. Some software is not so easy, and then you need an introductory video. But what with the introduction and video if you don't hear what they are explaining, by example? But our biggest focus, or our focus today will be people with learning disabilities, people on the autism spectrum, or people with autism, and people with mental health situations. I include them because lots of the solutions to solve the problems of the issues for people with autism or learning disabilities also indirectly or directly can help people with mental health situations. And both groups, people on the autism spectrum and people with learning disabilities, have often mental health issues. So why not then helping everyone with mental health issues, because it's inclusion, so not very stigmatized. So that was the first part about accessibility and what are disabilities. Now I'm going to continue with just completely other topic, Microsoft Cognitive Services APIs. And what is Microsoft Cognitive Services? That is the sparks of Microsoft AI platform on Azure. There's no need to know AI, so you don't need to know deep math algorithms. It's just really performing easy calls, AI. So you do a call and it performs AI for you. You have two possibilities. You have the REST style, so you can call REST endpoints and it performs a task. It can read the load things, it can analyze things. More about what it can do when you see later in this talk. So just you can do REST style API calls. And for some services, not for all of them, you even have SDK style. So for example, the major languages, for example, I'm a C# developer. For all the services, I can integrate with JSON and do REST calls. And for some of them, I just can go to a NuGet package, install a NuGet package, and do it directly via the SDK. But that's not for each cognitive service. And I place between brackets yet. I don't know how the plans are to roll it that for all the cognitive services. And the demos you will see later on today, you will see one service that has SDK style possibility, and one services that don't have or don't have yet a REST style SDK style possibility. So if you want to trigger that function or that API logic or that thing, we need to do a REST call. So, and I'm going to talk about some cognitive services that really can help to make more accessible applications. First of all, indirectly, each cognitive service can couple with other services to make the world more accessible. But we're going to go on direct things and not on indirect things, just makes to build sense. And then you have the speech service. There's really text to speech. And I really love text to speech. And there's a big difference between text to speech and voiceover or read aloud. Screen readers work like voiceover read aloud. And it's always the same. That starts on the top of the application. For example, if you are from Western Europe, it starts top left and it widths until bottom right. For the parts of the world, you have a different reading on this. Honestly, I don't really know for India. It starts bottom right and gets to top left. So that is voiceover read aloud. Text to speech is different. Text to speech, you can target specific what you want to be read aloud, and it's only that part that you need. For people with learning disabilities, it's very important. Let's imagine your eyes are looking at this custom voice. What? Your eyes looking at this. Bear with me. Okay. And let's imagine the whole text has screen, not only a blank field. So the whole text has screen. The whole screen has text. And it starts with the screen reader with the load. You see everything. Your eyes are targeted at this point, and it starts reading a lot of things that you don't need. And then you completely lose everything. You lose the context. If you are blind or really hard of have a bad vision, then it's not a problem. Then you really focus more on the audio. But that methodology don't work for people with learning disabilities. But then it can be very important to read some part of text because they can be due to the intellectual disability that they cannot read, but they see it. And we will see a demo today about speech service. You also can have custom voice. For example, this can be very personalized. For example, if a girl, for example, just call the name Lisa, is a girl with autism and anxiety disorders, and she has a severe form of autism, then it really can be helpful that the voice of, for example, a bot is really triggered and pre-configured with the voice of Lisa's mom, by example. You have the Vision API that can they can analyze images, and then that can, by example, let the people with disability take pictures and tell what it is, so for learning things and objects. But it also can help it can help more if you go further. Part of the Vision API, so a step deeper, is the Face API. And that can be, example, can be really good for parents, for example, or healthcare workers or caregivers. Maybe they can detect the emotion of the person, if he's really happy or if he's stressed. For example, then again, for the people with disabilities health, the Face API can detect facial hair. For example, if people are not blind but bad seeing, or maybe they have concentration difficulties with shaving themselves, an app just can predict if they are shaved well, for example. And if you go further, where do you need more shaving, for example, on facial hair? It's all possible. Bot service can provide bots, and bots can really assist people with disabilities. For example, just giving very clear guidelines. Bots can be combined with speech or with the load. It can be text. For example, being a very constant step guide for people with autism that can read, so who have literacy, but are very confused in their thoughts, then a really bot can do all the steps and give clear guidelines, provide yeah, that they are sure, that they are confident, can stimulate confidence. And for people who cannot read, it can be combined with text to speech, for example. The immersive reader is really great because it has accessibility features like reading aloud websites, linking pictographs to websites, even text appearance options. That can be great for people on the dyslexia spectrum. People with dyslexia can really help, can distinguish verbs, and do they have another color than nouns, by example, to help them. And then you have the translator API, and maybe you can say, should you include the translator API? Is it accessibility? I always point to inclusion is should be the start. So it's not only for people with disabilities, but you can imagine if you have difficulties with mental capacity, mental or concentration load, another language can be difficult. So maybe it can be more easy to sorry, that they also translate if it needs to be translated. And of course, it can also help people with disabilities. And then you're going further to problems that people with disabilities can have. Then I said literacy, reading information, understanding written text, recognizing money. By example, having an application with AI with your smartphone that you can take pictures with money or assist with money. Some banking apps, I think, should be more accessible for people, for example, with learning difficulties. Math, yeah, can be difficult for that people. Executive functioning is something that's a lot of time also difficult for people on the autism spectrum, like me. I didn't say in my introduction, but I am autistic myself, so I have autism myself. For me, I always say the joke. For me, going to doing my groceries at the supermarket is more difficult than planning a trip to the other side of the world. Yeah, but it's something special, but it's true. So it can help. Applications can assist. AI can assist, and trust and self-trust can be helped, can be gained with AI by repeating or just seeing, yeah, that this works. Even with assistant with AI, I can go to do my grocery or people with, for example, a maps application, a navigation application. Yeah, I get there. I can get to my parents by myself. I don't need to ask my dad to drive after me to come pick me up. So this really also this increases quality of life a lot. As I said, for today, I'm going to do demos. So the first part of this talk was a explanation about what's possible on accessibility and disability, and on cognitive services. Right now, I have 3 nice demos for you. And the demos you can find back, and also the slides will be uploaded on that link. If you go to https://go.ddsoft.be/taxhelp, it will redirect to my GitHub page, and then yeah, it will go to the text help project on my GitHub page, and the slides will be updated there later today or this week. But we're going to create a cognitive speech service. So I'm already, of course, preparing myself. And I'm going to log in. I'm already logged in into the Azure portal. I can click create a new resource. Then I can go to AI plus machine learning, and then you see a lot of services. I can also, if I know what I want, directly type in. I'm going to use a speech API for this demo. Speech. I can create. So I can give it a region, for example, Western Europe, where closest where I live. I can choose everything, pricing tier, and I can create. So I'm going to resource group. I'm just going to DD speech 2. West Europe, I go with DD speech, speech, right, demo. I have only the standard left. There is a free one, but I already used it. But it's very affordable, honestly. No, not worry about that. So, and then I can create. Click create. Yeah, it was maybe behind my face in that window. And I can go to the resource. Go to resource. I'm gonna click. And here is the most important thing: the keys and the endpoints. So here is key 1 and key 2. I have my location, my region, and I have the endpoint. I can use the endpoint, but for the speech SDK, I'm going to work with the SDK. I can show them, and I can show them. I can remove them because I'm not going to use that service. I just showed how easy it is to create, but now I'm going to delete that service because I don't need to load, and the service that I want to use, I have already prepared for you today, so I'm going to delete that. That was demo 1. Now, the next thing that we want to do, of course, is the speech service in action. I'm just going to... Here I also prepared some things. So I have text help. It's an application in GitHub. Visual Studio Code and Visual Studio and C#, and it's uploaded to GitHub. Here I have my webhooks for authentication. It's really a project that I want to grow and continue to grow, and even share as a demo in the open as well grow. But here, that part is the speech service. And the speech service, of course, I have my model with some extra properties like the language. And then I have the most important thing is this, is calling the SDK. So it's just the SDK that is worth the speech config. Speech config comes from the SDK, Microsoft Cognitive Service of Speech. And all the rest of the application here, and this console application is just all a boiler code and wrap up to make it work. Honestly, nothing more than that. It's not rocket science. I have my console, and I don't like consoles in dark black screens. So I just put it the white background and a red color. I do one speak. I need to submit my speech key, and I just copy that from another screen I have. Control C, Control V, and I say West Europe, and then I can say some text to get the load. Hello, India. How are you doing?
Hello, India. How are you doing?
You should be able to hear that. Can you confirm, please, or in the chat or in text, or because if you don't hear it, yeah, it doesn't make sense that I demo this. Did you hear everything? Yeah. Did you hear everything? I think you heard everything. Yeah. I assume you did. Okay, nice. The next demo will be. I'm not going to switch to the slide for that. Is a language is translation. So I'm going not press Y. So I'm going to close. And I'm going to start my application again for another demo. And yeah, and the next demo will be the same thing, but also with translation. So I want to translate and speak both. I press 3, and then I need my translate key also. And I need an endpoint, because for that we do via the REST way. So for the end user, you don't see the difference, because here also you need to do everything, fill in everything. It's just because it's open source on GitHub, and you are not all allowed to go on my keys. And if you see them, the keys will be refreshed after this presenting this talk. Also very important, you can refresh the keys. So you need to, yeah, it's just because it's open source. If you build it into an application, you should do budgeting and so that you don't need to add it all the thing. So I can type some text in Dutch in my own main mother tongue, and it translates and read aloud in English. There.
Hello, friends in India. Happy to be here.
So this is accessibility, I call it. And you can go very further in this. I only have 3 minutes anymore, so I'm just no slides anymore. Just one thing, future wrap, and while it's starting, I'm going to wrap up my slides while it's starting up the application. So I pressed, and until it's running, I'm going to skip to my talk. So translate service reduction. Then I have the future of app accessibility. That is the last demo I want to show. I'm going to show directly. I want to thank all the sponsors, all our partners, not only the biggest ones. I want to thank all the communities in India who are working with just hosting that kind of event for us. Q&A maybe in the chat, or you can contact me afterwards. But I only have 2 minutes anymore, and I need to show a demo. So this is a website that I built in Blazing and engage with AI with speech. And this is a website that is accessible for people with learning disabilities. Of course, in this case, for people with learning disabilities speaking English. So not where I live in the Dutch-speaking part of Belgium. And then I, for example, have, and you can just listen to specific parts that you want or that you need.
Optimism.
And purpose.
The more days that you are in this state, the more days that you are really happy, lucky, and healthy.
So that is really, I call it really the future, which is already technical possible, but if I say the future of website accessibility, I mean the future because, yeah, it's not used anywhere yet. So, and also here is really great, I think, in my prototype garden, the garden of prototyping, but to be able to build in productions and worldwide and even in Flanders, there need to be a lot of work to make it possible, financial and licensing and accreditation. But technical, it's there already. So if you have some questions, I have 1 minute. If you have some questions, I need to ask to feedback everything. And here are my credentials, Twitter, and my favorite hashtag, dreaming is believing. And if you have some questions, yeah, we have some time. There are no questions.
நீதானே தேங்க்ஸ் சொல்லணும். நோ क्वेश्चन நீதானே சொல்லணும் ஆன்சர் பண்ணோம்.
So hi Denny.
Hi.
Yeah, hi Denny. That was such wonderful presentation.
Thank
so,
you.
And got a more information about the process and the usage of AI, what you are talking about the presentations, had a much content, and what are the things just we have covered was entirely gave lots of messages So really thank for the great session, Danny.
Thank you very much. Thank you.
So I think I'm very much clear in your presentations and the things you explained in the real time of examples.
An example, yeah. How do you mean? Yeah.
It's a voice over recognition.
Sorry, repeat, please. Sorry, I don't understand you really well. Can you please repeat?
No, I was really impressed about the example you showed in a real time, just communicating with the AI process.
Thank you, thank you.
So that was amazing. So that's the thing just I want to convey from my end.
Thank you. I think, yeah, it is really important because people with learning disabilities are the people who have the less software, and you can build this for making recipe books, making their house planning, making just, for example, if you have an organization for people with disabilities, just being able to give the information that they need there, both the organization, both other organizations, making those websites accessible for them. And even, yeah, you can build apps to really assist them, that they are more and more independent for other people, or yeah, or less and less dependent, without being completely independent and take their own life in their own hands. Honestly, this is what accessibility should be, honestly, and what an inclusion is.
Okay, Danny, thanks for your time and thanks for your presentation.
Thank you very much.
Yeah. Hello, Eve. Hello, Alan.
Hi.
Yeah, the stage is yours. You can start talking about your presentations. And before going with our presentations, please let me know from whom you're going to start. Either Eve is going to start the presentations or from Alan.
Alan is going to start.
Yeah, please. Alan, the stage is yours. Please go on. Start.
Alan, I think you are in the mute. Just unmute yourself. Go ahead. Sorry, Eva.
Yes, I muted myself on purpose so I don't make noise while Alan is talking.
Yeah. So yeah, that's it. Stage for you. You and Alan. So go ahead.
And thank you. It's nice to have you on our Azure Community Conference. So we can share a lot of information so that the whole can be in the internet. So it's good to be here. So for our next upcoming session, we are going to.
Okay, so welcome to the session that I'm delivering. It's great to be able to speak at this event. Normally, under normal circumstances, I wouldn't get the opportunity to be able to travel to India and to be able to present at a conference. I'm based in Stockholm in Sweden, so it is nice that we've got these remote events, and it does enable some opportunities for us to be able to speak at events that we would otherwise not be able to present at. So I'm going to be presenting together with Eva Padri, and we're going to be delivering a session on reinforcement learning in gaming. It's something that we've both been looking at, working with hobby projects, looking at how we can actually leverage the artificial intelligence's technologies that we've got within Microsoft Azure and also within Python and other machine learning technologies, and then use gaming as a way of being able to explore these technologies and develop skills. There's also, within the gaming industry, increasing use of artificial intelligence. So it's great to be able to look at these services and be able to present some of the ideas that we've both been working on to prospective game developers who may be considering using these in their real solutions. So a bit about myself. I describe myself as a developer, trainer, mentor, as an evangelist. I'm based in Stockholm, Sweden. I'm also an Azure MVP, and I'm heavily involved with the community over here in Sweden. We've been organising the Cloud Burst Conference and the AI Burst Conference, and we've also had some. I've also had some activity within the Global Azure Bootcamp and the Global AI Bootcamp. And I understand that the Global Azure Bootcamp has been very popular in India at many different locations there. I do have a YouTube channel where I post some of the demos that I've been doing, so feel free to check that out. So what I'm going to be talking about is reinforcement learning, the way that we can take a game environment or a simulated environment and be able to work with what we call agents. It's basically players in that game environment that are using artificial intelligence technologies to be able to learn about the environment and to be able to perform within that environment. It's based on the principles of machine learning. So with supervised learning, what we typically think of is providing data and providing answers to the data. So for classifying images, we have images of dogs and images of cats, and we say these are dogs, these are cats, and develop the rules for understanding how to tell the difference between a dog and a cat. However, with reinforcement learning, we don't have the answers. We have a simulated environment, and what we do is the environment will have a state, and that tells us, technical details about the actual environment. We're going to feed in an action to the environment, and this is the player making an action within that particular game, and the action will modify the state. We also have a reward. Most of the games that we play, there's a score, or there's some kind of way of being able to do well within the game. The reward in a driving game may be how far you can drive without crashing. The reward in another game may be, how many points can you score within this particular game. So we can use the reward to compare how well these particular agents are performing within the game. So the agent is going to read the game state, it's going to make a decision, and it's going to send in an action into the environment, and that will result in a modification of the state, and the agent is going to get a reward for how well it performs during that game. So it's kind of based on the infinite monkey theorem. There's always this theorem that if you have an infinite amount of monkeys and you sit them in front of typewriters, one of them will write the complete works of Shakespeare. The others will just write regular expressions. So if we were to bring evolution into the theory, and we basically have a colony of monkeys, and the ones that are closest to writing Shakespeare, we can identify, and we can use those to crossbreed other monkeys and hopefully evolve a monkey that will be able to write Shakespeare. At least that's my real basic understanding of evolutionary theory. Probably isn't going to work in reality though, but that's kind of what's going on with this algorithm that we call a genetic algorithm. What we do is we start with an initial population, and very often these are created using random values. So we're going to be creating some random values, and they are going to be forming an initial population. We're then going to evaluate how well those actual initial population performs, and this is when the actual score comes in, or the reward. We basically put them into the game environment. They all do hopelessly. They all fail completely at solving the particular task, but some of them fail slightly less than others. So we can select the ones based on the score that have performed the best in that environment, even though they may not have performed very well. We can select those. We can then do a crossover by combining information in these population members and being able to see, well, there was something good in number one and something good in number two. Let's combine these things together and see if we can create a next generation that does have improved performance. And then we bring in mutation. We're going to randomly change some of the parameters of the particular population member to bring in a bit of variation into the algorithm. And that's going to go to the next generation, and we're going to be repeating this for a number of generations to see how the actual players or the population will evolve. So what I'm going to be doing is looking at rockets, and I was quite influenced by Elon Musk and the Falcon Heavy. I saw that launch with my daughter when they launched the Tesla into space, and I was amazed to see these two rocket boosters landing simultaneously. I'm a bit of a physics geek, so I was wondering about how much physics and how much simulation, and how do they do that? NASA hasn't been able to do that for its really long history, and Elon Musk can start up a new company and do crazy things with rockets. It's really good to see. So I'm going to simulate this in Unity with 25 rockets with these random configurations. We're going to basically simulate the rocket landing. They're all probably going to blow up, but some of them will land slightly slower than the other ones. So we're going to take the rockets with the lowest landing velocity. We'll do some crossover. We'll do some mutation. And that will lead to the next generation, which will hopefully be slightly more successful at being able to land. So what we're feeding in is we're working with the actual speed, and we're looking at the altitude. This is the actual state of each particular rocket. And we've also got a certain amount of fuel in the rocket. Now, when the rocket fires its booster, it's going to burn up fuel and the rocket is going to get lighter. So, I mean, if you want to calculate this, I mean, this is rocket science by definition. We've got to do quite a lot of calculations if we wanted to do this, using various tools and basic physics. It's going to be challenging to solve. The rocket's output is going to be the thrust. So this is the input that they're going to make into the environment, and then they're going to be scored on the actual landing speed, what speed the actual rockets are going to be doing when they hit the ground. Okay, so first demo, landing rockets with a genetic algorithm. What could possibly go wrong? So I'm going to go into Unity. And I've got this little simulation in Unity that I built. I'm not a good Unity programmer. So what I'm going to try to do is basically demo this. Last time I demoed this, it wasn't successful at all because the rockets are initialized at random. Most of them are going to crash, but it's looking like one of them did successfully land. So hopefully we'll be able to take the information in that successful rocket, and the next generation, you can see that we've got 3 rockets landing. And those top performing ones are going to be used to form the next generation, where we get quite a few more rockets landing. And as you can see, the success of being able to use the thrust appropriately means that every time we run a generation here, we're getting more and more rockets that are doing a successful landing. So you can see that this is just increasing in success. And we have now finally got these 25 rockets landing simultaneously, which is it's kind of, Elon Musk managed to land 2 of them, we've landed 25, but this is a very, very basic simulation showing how we're basically going through a number of generations. It is random. I'm so pleased that that demo works. The last time, I think it ran for about 25 minutes and the rockets were still crashing. So it is basically initialized with random variables. You can get quite random results when we are running through this. Okay. So a bit about the state. Selecting the state for a particular environment can be a bit of a challenge. What we've got to do is to look at the actual environment and decide which information is going to be important for the agents to be able to understand. The first computer game that I ever played was a lunar lander computer game. It was probably, I was about 6 years old, so it would have been in 1977 or 1978, somewhere around about that particular time. And the lunar lander game, you basically had a light pen, which you could use to actually adjust things on the screen. And I kept crashing this thing. I couldn't get it to land. But the important thing here that's going to be important for the actual environment is going to depend on the actual game that we are using. So in the lunar lander example, it's going to be maybe the fuel that we've got that is going to affect the weight. It's going to be the altitude, how high we are, the horizontal speed and the vertical speed. So this is the information about the state. The reward is going to be the score. When we land, if we crash, we maybe get 0 points. If we manage to make a sort of decent landing, a half decent landing and crash, then maybe we start to get points for that. So the amount of score that we get is what we're going to try and maximize. Also, these basic Atari games. Also, when I was about 11 or 12 years old, you could buy these Atari consoles. This was back in the probably in the early 80s at some time, and you could get these arcade games like Pac-Man. and various other things like that. Now, with these games, the actual state of the game is treated as each pixel on a screen being part of the actual game state. This is fairly easy to do because the games are pretty low resolution. You can see how big the pixels are on this Pac-Man character. So there's not that much information, even though we're treating all of the pixels as individual states of the game. So they have actually built AIs that can learn how to play these Atari games based on the actual pixels on the screen and treating that as the game state and using the actual score down here as a reward. And they've run experiments where sometimes on some of the games the actual AI players can get better than human players. Depending on the complexity of the game, sometimes it can be quite challenging to solve, but it is fairly successful. You can also download and run this code from GitHub using simulations of the Atari games. It takes quite a long time to be able to learn each game, but it is possible to do that. Now, as we get into more modern games, you can see that using the actual pixels on the screen is going to be really, really challenging because very often they're running in a very high resolution. And in the Pac-Man game, all of the information you could consider being relevant. We've got walls, we've got dots, we've got the Pac-Man character, and we've got ghosts and these Energizer tablets, and they're all kind of relevant. Whereas here, the road cones aren't that relevant. We've got the actual driver line here. The track we can see goes around this corner, but also the track also goes straight on. So how do we determine that we should be turning to the left instead of going straight on here? So this is a much more complex game state to be able to process. So what I did when I was looking at this particular example at Forza to be able to actually work with the game state is I did some processing. I built a filter based on the actual colors here, and I selected this particular color for the driving line and highlighted this as an actual bitmap image. So now by processing the image we get a game state which is much easier to understand by the actual artificial intelligence system. It can see that model, it can see whereabouts the car should be driving, and the signal to noise ratio in that particular image is much lower than it would be in the original game image. So sometimes we're going to be processing the states to give a meaningful input to the particular agent that we are working with. I also did experiment a bit with using the custom vision service in Microsoft Azure and training a model that is able to detect cars. So here we've got the car that we're driving. That one's been filtered out, so we're not going to always detect that, but we can detect two other cars here and see how we can avoid the car, because the other state would only give us the driver's line. It wouldn't pay attention to any other cars. So the action that we're going to take is going to depend on the game. It could be, simulating some key presses if it's a keyboard-based game. The Atari games will use a joystick, and the driving games basically use setting the steering on a controller for that. The reward in the driving game was the amount of distance that has been traveled. So however many meters you travel is going to be the reward. For here, it's going to be the score, and for here, it's going to be the score as well. So using different rewards in these different environments. So the driving game example, you can see that the input was the driving wheel, and we've got the state, and the reward is going to be calculating how far the car has driven. So I'm going to see if I can bring up a quick demo of that. I do have it on my YouTube channel, so I've just got to bring up the link to that. And let's see if I can locate that. Because this basically shows it's a bit complex to demonstrate the actual full simulation, but I think I do have an actual video that's basically showing this particular scenario. Okay, so I'll bring it onto this screen, and this is about 24 hours of evolution for this particular car. It starts off just crashing into the walls. Eventually, it figures out that driving in a straight line and following the driving line is a good idea. And when the driving line goes off to the right, the car turns to the left and goes into the field. So when it leaves the track, I say game over. That's basically what the distance driven is going to be. But eventually, I think after about 24 hours, it does figure out how to navigate basic curves. So you can see it is actually steering and attempting to remain on the track. So that is some improvement which will get rewarded in the simulation. And it generally gets better and better as we're running through this simulation. It's sort of managing to do it slightly better there. And what I'm doing is starting this further and further through the video and just showing how it's going to navigate to the next sector of the track. So I did see gradual improvement over probably about 48 hours of training. But what it couldn't figure out, if you go towards the end, it couldn't get round this particular corner here. It crashed into the walls and it was basically stuck for quite a long period of time, doing exactly the same mistake, but at the actual section there. So my conclusion there that this was quite a challenge. The game is, I think, Forza Apex or something like that, and I was using a simulated controller, but it never made it round that particular corner, which was a bit of a shame. It would have been nice to be able to get it to navigate the entire track. Okay, these are some sort of real-world examples of AI. When I was teaching a course in Sweden, they had an AI day and all of these demos. This is a street sweeper, and this is a prototype for a supermarket delivery van. There's no driver in this van. They basically use radar to be able to detect. And this thing was driving at about 1 kilometer an hour or half a mile an hour, just moving very, very slowly. But it was driving completely autonomously there. And it's interesting to see how that technology is used in these real-world developments. So if you would like to explore self-driving cars, there is a simulator called Carla, which basically provides simulations of those particular environments. I do have another quick demo that I can show you, which is going to be a bit more successful on the self-driving cars. I'm going to bring this up in Visual Studio. And before I built the demo using Forza, this was basically an early prototype of that demo. So what I've chosen is a very simple 2D environment. And what's happening here is we've got a generation of 50 cars. It will also evolve much quicker because I can run 50 simultaneous simulations. So it's showing that generation 1 got 249 pixels, and we're now on generation 2. And that has actually got 2 members of that population that seem to have solved the problem of being able to drive around the actual track. What we see here is the neural network, which is powering the cars. So we've got distance sensors, so it's sensing how far away the tracks are. And we're doing various calculations in the neural network to determine the steering of the car. You can see this is the actual steering in one of those population members, and this is going to be the throttle. So they seem to be driving okay. What I can do with this slider is I can modify the friction. So this is basically simulating them driving on ice. So you can see there, as soon as I add ice into the equation, the road becomes slippy, then they all crash. So this means that now they've got to evolve their driving skills to learn how to drive on ice because it's a lot more slippy. So you can see that they do seem to be adapting some of the members in the next population, and they are now able to kind of adapt their behavior to be able to drive. You can see the car is sliding around the corners now because there's very little friction on the road, and that's able to, within just one generation, solve that particular problem. Again, this is using random numbers, and I was surprised how quickly, in this example, it has learnt to drive both on regular roads and on ice. Sometimes it doesn't evolve so quickly, but other times it does, because of the randomness of this, seem to solve that problem particularly well. Okay, so if you have attended not the global Azure bootcamp, but the global AI bootcamp, you may have been familiar with the actual driving lab. We've run the driving lab in the global Azure bootcamp, but within the global AI bootcamp, we've basically been running this as an actual lab. And the idea was in the global Azure bootcamp that you could compete against other members in your location, but also people around the world. It would basically record what location you are at. So for the global AI bootcamp, I took the code that was used in that 2D simulation and adapted it to this simple 3D driving game. The physics is a lot more simple than Forza. Also, because I've got the code for the game, I can very easily figure out these distance sensors to the actual track barriers. And what we did was basically run this as an actual experiment where you could either drive the car yourself, or you could use your game to train an AI to be able to actually run in the actual game. So what I've used these kind of skeleton heads from Terminator for the AI players, and I've used these crash helmets for the human players. And this is showing the top 10 list. So you can see out of the top 10 list, the best performer is an AI player from Nigeria. And then we did have from Indonesia, we had human players coming in. But you can see that number 6 and number 7 are also these AI players. So in this particular scenario, I'd say the humans are still ahead because we've got the most people in the top 10. However, the AI drivers are catching up rapidly with us. So maybe after a few more generations, the AI players will be able to supersede the human players in being able to play a particular game like that. So if you'd like to explore working with this, Eve is going to talk about various services we've got within Microsoft Azure that can help with this, but they're based on technology which is known as OpenAI Gym. So basically, the code is basically providing simulations that we can use. This is an example of a cart pole simulation where the AI has to learn to move the cart and keep the pole balanced. We've also got, like walking simulations that we can look at, and we've got a lunar lander simulation, a basic one in there. And the gym idea is that you can build your own AIs to be able to explore these various environments and be able to understand how these particular games work. So just to round off, we also have the Atari games in the OpenAI Gym. This is the Space Invaders game. So this is based on using the pixel as a state and using the actual score as the actual reward, and figuring out how we can actually, get good at this game. You do sometimes get some unexpected results. One of the AIs that was built to work in a game and survive in a game environment, the actual score or the reward they were giving them was how long that the player can survive in that particular game environment. So what the AI decided to do was to press the pause button in the game, because that meant that it could survive for a really, really long time because the game was paused. So the AI has basically evolved and figured out that pressing pause on the game meant that you could survive, and that was what they discovered. So they had to modify the AI to basically say pressing pause is not an option. If you press pause, then you're not going to get any reward whatsoever. And then the AIs will stop doing that. I had something fairly similar occurring when I was looking at my game evolution. So I'll see if I can bring up the details on that. I think I've got it in my YouTube channel if I can find it. And basically what had happened was I had given the car information on the actual road, the road details. And what the car basically figured out, the car could actually have access to what was behind it as well as what was in front of it. And in the first generation, the car basically turned round and started driving backwards. And out of that generation, just by chance, because it's random numbers, the best performing car was driving backwards. So then in the next generation, it decided that driving backwards is a good idea. And the generations evolved and evolved and evolved and got better and better and better at being able to drive on the track backwards. However, the car can go at about 250 miles an hour forwards, only 100 miles an hour backwards. So this is kind of known as the false minimum. The AI has discovered a particular way of doing things which is not optimal, but it doesn't know that there is a better solution because it hasn't explored that particular scenario. So what it does is it keeps reinforcing the suboptimal behavior, and it gets better and better and better at driving backwards. So we do have to watch out for these kinds of unexpected behavior and this type of false minimum. So what I'm going to do is I'm going to hand over to Eve, who's going to talk about these ideas and how we can run these ideas, not with a single player, but with multiplayers in a multiplayer environment using multiple agents in these particular game environments. Okay, so I think I can end my screen share and Eve should be able to take over.
Hi everyone, I hope you can hear me. I am amazed that I can be one of the speakers of this amazing conference. Thank you a lot for all the organizers, for all the help and support we got, so that we can have a really great experience as speaker at the Azure Community Conference. So thank you, Alan, also for the amazing introduction to what is reinforcement learning and how can it be used for game development. I think you have shown a lot of cool projects, and I hope the audience also found it interesting, and I hope you will all find of time to try these out as well. So Microsoft made an amazing history in machine learning and artificial intelligence, applying machine learning to improve many of their products and services, such as for the suggestions made in the Office services. And I'm really excited now to share some insights and offer a first glimpse into how Ninja Theory's game, The Bleeding Edge, is allowing Microsoft Research to drive exciting experimentation into artificial agents that learn to collaborate with humans with the use of reinforcement learning. So I am Eve Bardi, consultant at Avanade. I am also an AI MVP since 2020. And since that, I am involved in different community activities. For example, I am one of the board members of the Global AI Community and co-owner of AI42. And AI42 is a series of lectures for those who would like to become data scientists or AI engineers. And both of the global AI community and AI42 is a community for you if you want to reach out to people who are interested in AI and want to learn more. I also write articles and speak about my investigations and projects at different meetups, conferences, or other community events. And I really hope that sooner or later we can actually meet in person as well. So my aim is to save lives and support humanity with AI and data, but it is really important to make people feel safe while using these intelligent applications, and also make developers understand how they should control their solutions. So I think it is really a good idea to look into the code that we are showing today, so you have a good idea how this works, how this reinforcement learning in gaming actually works behind the scenes. I also would be really happy to answer all your questions after the session. But if you have more or you're stuck somewhere while you're trying out the projects we show you today, feel free to reach out to us. You can find me on Twitter and Facebook, but you are welcome to reach out to me after the session in the chat. So, reinforcement learning became very popular in the recent years since these agents perform complex tasks really well thanks to reinforcement learning, causing real breakthroughs in the field. And there are many use cases in the world which uses this technology in the areas like robotics, chemistry, and a lot more. But the focus of this session is really game development. So think of a character or a bot in a game, and it has to understand, first the state of the game, who are the other players, what are the objectives, and then based on this observation, it is going to make a decision. And in reinforcement learning, these decisions are driven by rewards, which in a game could be provided as a high score or a new level for reaching a specific goal. And the cool thing about a gaming situation is that the policy of this agent is trained under the pressure of the game. So, for example, it could learn what to do when it's being attacked or how to behave in order to reach a specific goal. And Microsoft proudly announced the preview of reinforcement learning on Azure Machine Learning and at Build 2020. So this new reinforcement learning support in Azure Machine Learning Services provides scalability while training to CPU or GPU-enabled virtual machines with machine learning compute clusters that can automatically provision, manage, and scale these virtual machines. You can also use single agent or multi-agent reinforcement learning for your training scenarios. You can also use different gaming environments like the OpenAI Gym that Alan talked about for a sec. And then you can also build your models with your favorite framework like TensorFlow, PyTorch, and it also supports ONNX. You can also track your experiments and monitor the runs, because Azure provides numerous AI solutions to build, run, and grow your games. So Go on and accelerate your games with AI and machine learning to provide more realistic worlds and challenges for your players. So if you want to get started with reinforcement learning, you can check out the sample notebooks to train an agent. For example, to navigate a lava maze in Minecraft using Azure Machine Learning, which uses single agent reinforcement learning. So the goal of this agent is to reach the blue tiles while navigating through this maze by walking only on solid tiles. And the agent might fall into the lava, in which case it has to start it over. And it learns from its own mistakes, which is really cool, right? So, and since the maps are generated randomly, the agent also has to learn how to generalize and adapt. And non-player characters are the heart and soul of many video games, and new AI technology lets developers create characters that act organically and respond naturally to the players. I'm going to try and start up this video so you get to know something that you have maybe not seen before. So the goal of Project Paideia team of Microsoft Research in collaboration with game developer Ninja Theory is to democratize state-of-the-art reinforcement learning techniques for any developers through Azure Machine Learning, and to provide access to training infrastructure and easy integration tools. And by this, make developers able to apply reinforcement learning while building exciting games for their players. And when it comes to video games, reinforcement learning agents have typically been trained to win against human opponents, just like, this famous chess agent. But what if we taught them to collaborate with human players instead? So, the game I wanted to show you is designed to rapidly test this collaboration between two players. So I'm going to switch over to this page. This is the innovation page of Microsoft, where you can read more about the project that we are going to talk about today. This is the Project Paideia. So in this game, I am going to be a white little robot, or I don't know what is that. And there will be a blue one. And we are in a spaceship. And now the aim is to, get out from this spaceship somehow. And what we have to do is that while one player keeps this switch active, the other can press these buttons to open these doors to escape the room. So the agent already started to go ahead and take care of the switch. So I'm going to take care of these buttons. So one falls in, and then I take care of the other one. The other falls in, and then the door opens, and then we can escape. Now, let's see how the agent collaborates with me. If I, for example, okay, I go for the switch. No, I changed my mind. I'm going to take care of this. Oh, wait. I thought it's... And I changed my mind, so the agent already reacts on my moves and helps me out. Like, I don't know what I'm doing, right? But he still tries to help me in this, which is pretty cool. All right. So we actually be able to get out now. And look at this guy, he let me out first. Nice. So this agent is trained by putting it in a wide range of different game situations, like randomizing the positions of the switches, for example, the starting position of the agent. So it has gathered a lot of data of how it can interact in those different scenarios. So in this session, we look into how to train a multi-agent reinforcement learning scenario and use the following situation. The blue circles are the agents, and they start spreading around and observe their environment while finding the landmarks that are shown as black circles. And then they get rewarded if they find the landmarks without overlapping while spreading around. And for this, we're going to use OpenAI Gem's particle environment with Azure Machine Learning. Now, let's take a look into an example of how multiple agents can be trained with Azure Machine Learning in a simple gaming environment. So I switch over to my Azure portal, And to see this, you will need an Azure subscription. And then you also need a resource group and a machine learning workspace. So I'm going to create a new workspace. Say, no, wait, it's easier if I just go like this. There we go, machine learning. And then I click create. So first, we want to define a resource group. And the resource group is like a container that holds related resources for an Azure solution. And you decide how you want to allocate these resources into these resource groups based on what makes more sense for you. But generally, you can add resources that share the same lifecycle, so you can easily deploy, update, and delete them as a group. And you can create a new one from here. You just give it a name and then add that over there. Maybe if I use a subscription that actually works, then you give it a name. And see, a storage account, a keyword, and an app insight is also generated together with your service. And you can also define a container registry. And this should be generated together with the workspace. And this is used to register Docker images used in training and deployments. And to minimize costs, a new Azure Container Registry resource is created only after you build your first image. And when you're done and you're ready to deploy this solution, then you can just click Review and Create. I'm not going to do that because I have one already prepared. But when the installation is done, you can go to the resource and click Launch Studio. And when you do that, you should see the following page. And from here, you can choose to go with code-first notebooks, automated machine learning, which provides you the best fitting model with the best, hyper-tuned parameters and all that. And then the designer is a drag and drop interface if you want to start with learning and understanding how a machine learning project should look like. All right. So you can choose to work with notebooks. And here, I'm going to go and start up the Project Idea project. And I'm not sure how familiar you are with Python's Jupyter IPython notebooks, and which has a very similar folder overview like we have in here. I hope you have some familiarity with this, because then it's easier for you to work with. But before you start working, you need to have a compute ready for you to run. I switch over to my other one. Thank you. And one more thing you would need for this project is some extra files that are going to be used for the scenario. There will be some utilities, some training codes, and all that, which all can be found on a GitHub account over here. I'm going to share these links later on. So go back to my notebook. And so these notebooks have all the tools that you want to use installed for us already. But you might want to update all your environment when you are ready to use these required libraries. But then we want to return the machine learning SDK version, which is quite handy in case you need to do some debugging. It is also a good idea to define which Azure tenant you want to use, and so specify it with the use of this code. And you can figure out your Azure tenant from the Azure portal if you come here and look for the tenant properties. Then you can find this information for yourself. All right, so it is time then to connect to our workspace that we have just created. And you can use a predefined configuration, or you can specify it by defining the name of the workspace, the subscription ID, and the name of the resource group, where you put the workspace and the compute target. And then you can find the subscription ID also at the Azure portal if you come here and say subscriptions. And if the connection was successful, it will return the environment details. Then the next step is to create a new experiment, which will enable us to monitor the run. And as parameters, we pass the workspace that we just connected to in the previous command, and we specify a name for the experiment. And now we also want to create a cluster where the training is going to run. First, we define the name of it, and then we're going to look around in the system whether the cluster already exists. And if it is, then it's going to say, yay, I found the cluster, so I'm going to use it. And if it exists but stopped or not available, this code will return that information as well. Otherwise, if it's not generated yet, it will be done now. We should also specify the size, the number of nodes, and you can always change this code to an existing cluster. For that, you only need to change this here, the name of it. And the good thing about this cluster is that it will scale down when it is not used. If you define max node 0, then it is going to scale down, so it's not going to, take your money. So you are also welcome to increase these nodes, if you plan to run more than one experiment on this cluster. And when the cluster is ready to use, this code will return either cluster created message or yes, that it's found an existing compute and it's going to use it. As a next step, we are going to use a customized Docker image where all the necessary software and Python packages are installed. And the configuration for the training run is defined with the environment class. And since we also want videos to be captured and displayed as a result about the different runs of the particles, we need to set the interpreter path too. All right. And as you can see, I am playing around with code here because this project is in research still and it's keep improving. So there's always something to try out and add or remove. So it is always a lot of fun to figure out, okay, where it will fail again during a live demo. So, but yes, in the next step for training, we are going to use a multi-agent deep deterministic policy gradient algorithm. Okay, so it's called MADDPG, and as the name suggests, it will be able to train many agents in the same time. And if the training runs over 3 hours, it will automatically stop. Similarly, if a -400 reward is given. So we have to initialize reinforcement learning estimator with different parameters that are necessary for the training, like the source directory. So the source directory where we have all the files that we added in the beginning, the entry script that is also part of the files folder, and the scenario where we are going to train our agents. Then we also define the compute target and the training environment that we created a few steps before. And you're welcome to change the final reward parameter, but this code means that when it is reached by the agent, the training is over. And the -400 returns with a pretty good result. But if you want it to be better, training might take a bit longer. All right. So I'm going to start again and start up with running these because I wanted to show you some cool stuff, what you can do with Azure Machine Learning Studio. I mean, with the workspace, sorry. Yeah, it was called Studio for a while before. All right, so now I start this up. Training starts up. And what you can also see here, which is pretty cool, is that, you can see that the status is starting. You can see the start time, the duration, what is the ID of the run, and then you can see some log information as well. And believe it or not, this was not available a few weeks ago. So I'm very happy that this works finally. It's not working yet perfectly, but this is pretty cool already. Okay, so we can see the status, it's running. And we also want to see more information about the experiment while it's running. And the link is available to navigate us to the run details. And this we do, by the way, that is done by this part of the code, which runs the Azure ML SDK's run details widget. That is here. Right. So we go to the child runs of the experiment, and we start up this one. This is already running now, which is nice. And then we go to outputs and logs. And we can start from the beginning, see a lot of information. And we can see that it started up. Yes, it's running. And then the first iteration, the reward is 623. But we can see also all the iterations one by one. And then we can see maybe some better rewards that we are getting somewhere. It is going to improve with time. It takes a while to run through, but it's really nice that you can monitor the runs during runtime. Evaluation of the training is really important, and it is really possible to show videos about the different iterations as the particles try to find their path without colliding. And generated videos are saved in the logs folder and here. And we cannot show it inside here right now because of some improvements in the code, and there were some changes added. But what I will do is that I go back to an older run I did, where we can actually see the improvement between these runs. So go back to the child run, to the outputs and logs, go to logs and videos. And let's download one from the beginning. This was not very smart agents yet. So when I start this up, you can see that the agents are spreading around, trying to find their place, but they're not very good at it yet. But as we are going ahead, and let's look into like a midway. I didn't want to open it, but let's just download it. Yes. Then see, they are getting there. They are very close now. They're not colliding. They sort of have an idea where to go. And I don't know if you noticed it, but in some of these videos, we are looking at different maps. It's because these are also trained on random maps. So it's always changing. So that's how they are learning a lot. And then as we are getting towards the end, like let's see the final one. In this one, our agents are so smart that they go straight to the landmarks without colliding. All right. So I come back to my code, and I really wanted to show you some more cool stuff, and I will actually, because what you can also do is to get a tensor board that is showing the monitor in real time while the experiment is running. And I'm going to click on this, and if it won't work, I will still can show you. And it won't work, great. Because previously I wrote an article before the changes were added to this solution. And in here it was working very nicely, that if I started up the tensor board, then you could see it like each iteration, how did it perform? You can see the rewards in each iteration. And you know, it's like it is working like this, that first it is getting a bit better, then it is getting a bit worse, then good again, then it's bad again. So it's like going like this, this, and this. And if you follow it throughout the entire run, then towards the end, you would see that it is not going to be that big difference between the good and the bad results. So it is going to, like, at some point go standard. All right. So with that, when you use reinforcement learning in Azure Machine Learning, you can easily monitor each iteration and see all the training results live while when your experiment is running. So your journey in reinforcement learning should not stop in here, because if you want to read more and see the following resources, like you can find some blog posts from the build or some GitHub repositories with the samples, a lot of videos. My blog is also available about the story, and you can read a lot more about the Project Paideia or the Microsoft innovation as well, like how is it advancing in the project. And with that, I would like to say a big thank you for your attention. I hope you find this session beneficial when you build your next game, and I can't wait to see what you come up with. Also, let us know in comments which project would you like to try out the most from what Ellen and I showed, so we can share some resources for you. All right, with that, I want to say a big thank you again to the Azure Community Conference and the sponsors that we can be here and be a speaker of this conference. And we want to say a big thank you for all the support we got. And thank you, all of you, for being here and listening to us. And with that, I want to say thank you again and asking if you have any questions.
So yeah, thanks for your presentations. So as of now, we don't have any questions.
All right.
Yeah, thanks for your presentations, and thanks, Alan.
Thank you.
Yeah, bye-bye. So, hi Priyanka.
Hey, hi.
Yeah, hi Priyanka.
Hello.
Yeah, Priyanka, I can able to hear you.
Okay,
And
great.
so Priyanka is going to start about the topic with the machine learning with Azure. It's a IoT Edge. So Priyanka, the stage is yours. You can start your presentation.
Absolutely. If when I have to share a screen, do I also click share computer voice because I have some demos to share?
Yes, you can. Go ahead.
Okay. Okay, so I'm clicking on share system audios, all right?
Yes.
Okay. Great. Is my screen visible to you?
Yes, Priyanka, we can able to see your screen.
All right. Let's start.
Yeah, please go ahead.
Sure. Hey, good afternoon, good evening, good morning to everyone who's joined Azure Community Conference, and a huge event. Thanks for the organization, for the organizers for getting in so many people together at one platform for three, super days of technical learnings. All right. That being said, welcome to today's session, which will deal with machine learning with Azure IoT Edge. We'll basically learn about Azure video analytics and how to do that on the edge. So live video profiling or live video analytics on the edge. All right. So let's get started. So this is briefly about me, and to connect with me, you can have my Twitter handle, which is at fuzzymind1. All right. You can also reach out to me on LinkedIn. So the agenda for today's would be something like this. So we will learn about what is Azure IoT Edge. We will quickly see on the Azure portal about some fundamentals like what are modules, what is runtime, what is IoT Hub. Okay, so these are the concepts about IoT Edge. Then we will learn about Azure Video Analyzer, the terminology, some of the few building blocks, and look at some very interesting demos of video analyzer. And then we will actually see a demo on the edge where we'll profile a live video. All right, so throughout the session it is going to be an interplay between demonstrations, between code snippets, between Azure portal, highlighting some of the Azure IoT Edge related things. All right, and then interspersed with a few concepts here and there on the slideshow. All right. Okay, so what is Azure IoT Edge? So basically, not all of the time you can have your business all the time on the cloud. Okay, so there are few analytics which you may want to do via your devices. For example, you are wearing your HoloLens, or you're wearing some device which is recording audio or video, and then you only want intelligence about that particular video. So you don't want to actually upload the entire video on the cloud, process it on the cloud, and then get the analytics and then render it to the user. Okay. In many use cases, for example, when we are dealing with devices like Raspberry Pi or small recording devices, so those devices may not always be able to be connected to the cloud. All right, so many a times it may be like the devices will be capturing the feed, they may not be in the range of the cloud for various reasons, like currently they are out of there's no Bluetooth or there's no Wi-Fi. Okay, so they don't have any way of connecting to the internet. Okay, but then those devices nonetheless they capture your video, audio, or any other feed, and then it has to be sent later on to other devices. All right, or maybe then it has to be sent to the cloud for intelligent analytics or having some sort of business intelligence derived from that, which is where IoT edge comes into picture. So it moves the cloud analytics and custom business logics to devices. Okay, so our organization can only focus on the intelligent insights which we need and not on the actual data management. So I need not monitor the actual video, audio feed, and all the heuristics surrounding that. So what I'm concerned primarily would be the insights what my audio and video are deriving or can tell me about it. All right, so this is the primary goal and primary motive for why Azure IoT Edge comes into picture. Okay, so this is very your audio, video, and your insights. So your data and your intelligent insights are decoupled, and that is how your applications become more manageable. Okay, so this is for scaling out your entire IoT solution by packaging your business logic into Dockerized containers, so small modules. Okay, and then you can deploy this small logic modules or containers, what we call. So containers are nothing but your standard Docker containers, right? So your Azure IoT, the edge devices is consisted of separate small containers which have
So,
which,
Priyanka,
yes,
yeah, sorry to interrupt here. Could you please present your screen because we couldn't be able to see it? Just
I
change
am
it to present
presenting
mode.
my screen. Yeah, I
Change
am.
it
I
to
am.
present mode.
Yes, see. Is it correct? Is it visible?
Yeah, yeah. Just swap the session so we can able to see the notes. Just
Oh,
swap the
okay,
session.
okay, 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 okay. Got it, got it. This one,
Yeah, thank you.
right?
Thank you.
Correct?
That's cool. Yeah, cool.
Okay,
Thank you.
great. Okay, okay, all right. I think I'm connected on the monitor. That's why. No issues. Okay, so this is when when we talk of Azure IoT Edge. So it is comprised of small business modules which have all your business functionality, and they interact with each other. And can intercept messages between the devices, can communicate with the cloud. So all these things we will actually see in action. So what is IoT Edge? What are the modules? What do I mean by message buses, or what do I mean by heuristics or source and sync, and all of those things and much more we will see it in action. Okay, briefly we'll just touch up on the IoT Edge components. So it is IoT Edge is made up of three components, which is first are the modules which we already explained, like these are small containers which contain your business logic. Okay, it could be Azure services, it could be marketplace modules, like for example Azure SQL Edge, or Azure some predefined Azure sensor devices. But it could be your own services, like for example you wanted to install a Dockerized version of Neo4j as an IoT Edge module. All right, so all these things we call as the small Dockerized containers which contain your business logic are your IoT Edge modules. Okay, you can program them in a variety of languages, like be it C Sharp, be it Python. Okay, and then we have IoT Edge runtime. This runtime is basically like the the software which is required to run all these modules. Okay, so this is the sort of intelligence on which all of these modules and your IoT infrastructure runs on. And finally, you will have a cloud-based interface for you to remotely manage your IoT edge devices. So, what are the devices doing, and how they are communicating with each other? I should have some sort of a monitoring mechanism, right? So, what messages are being sent between the devices, and what are the topics and buses? Okay, so let us quickly look at uh, all these edge components. Okay, so before we move on, so this is when we talk of AI at the edge, so with the IoT edge infrastructure in tandem with artificial intelligence, what it looks like is, with IoT edge, the modules which we talk of, right? So modules can comprise of even your AI services, like for example cognitive services. Okay, or you can even have a predefined marketplace modules which are in Azure. So this is, you can leverage all of this to build your artificial intelligence at the edge. This is what we are going to see today, how to have a computer vision analytics on the edge. Okay, so this is how the edge runtime looks like. Okay, so you have something called as an edge device, and you will have modules. Okay, modules are nothing but business logic pieces. So some modules are giving you some actionable insights, some module are actually handling some events and then taking an action, some modules are just giving you telemetry information, and all of these modules are being synced to the IoT hub. So hub is like, the parent infrastructure which sort of controls all the devices which belong to the hub. Okay, and these are the independent, industry sensors or the small devices which are actually connected to the Azure IoT edge device. So this could be VMs, standalone VMs. This could be Raspberry Pi. This could be sensors connected via Bluetooth and all. So they are now, they are connected to this IoT edge device. They have these modules, okay, which are they are doing some insights, and then they are all connected to the IoT hub. To put it all this into perspective, okay, code wise and also portal wise, let us quickly look at how the IoT edge runtime looks like. Okay, so when you go here and we look at IoT hub, sorry, we look at type IoT hub. Okay, so this is my IoT hub, Azure IoT Hub. This is actually, if you click, when you click on create a resource and you can click on IoT Hub, it will it will create this IoT Hub resource. In that IoT Hub resource, you will see two things: devices and IoT Edge. Okay, so these are your edge devices. Okay, devices connected. And then if you look at that, these devices, so these can be your standalone VMs, or it can be your sensors which are mapped to that particular device. And these devices in internally, they will have modules. So if I click on this IoT edge device which I have created, so my device is currently a Linux VM. Okay, and that VM has several modules which we will see here. So if you see here, so these are the modules running on my device currently, which edge agent and edge hub are the by default modules which will be running in any Azure IoT environment. So these are like the orchestration parent components that will govern the child components, and these are my custom modules. So this is so as you see, agent and hub are system modules, and edge and this is some real time streaming protocol. So this is my RTP-SIM custom module. Okay, custom module could be anything, like, as I said, it could be some action you are taking. It could be just, outputting some insights, some telemetry information. So I have two custom modules here in my device, and the device itself is a VM which is connected to a IoT hub. What is the function of the IoT hub is, the devices, how they communicate with each other is via the IoT hub. Okay, so it's like, let me show you by having a working Visual Studio session. Okay, so this is, for example, when I'm talking about modules, right? So you see in your Visual Studio Code, this is my module. Okay, so module is nothing but a piece of logic. So this is my normal C# logic. Okay, this is my normal C# program in which I'm programming some logic. Okay, what logic is, basis some message received. Okay, so let's say my current piece of logic is taking care of the fact that when I am getting a message on some topic, right? So we have like, for example, we have producer consumers, right? So producer is sending a message on a particular message bus or a topic. So I'm listening. So my piece of code is listening for a message on a topic which is called as input 7. And it can listen on multiple inputs, right? So currently it is listening on let's say it is talk of input 7. So it is currently listening on a message bus called as input 7. And as soon as any message comes into this input 7 bus, okay, or input 7 topic, then it will have some response which is taken. Okay, so you see that once that message is received, it will take an action which is called a function which is called pipe message, and that pipe message basically does some processing. So it might insert into a database, it might just relay on the message to another module. All right, and on the Visual Studio itself, this is my Azure IoT Hub. Okay, so my Azure IoT Hub, this is the hub, and these are the devices. So I can have multiple devices. Okay, so these can be VMs, these can be your a Raspberry Pi sensor type of devices, this could be your blacknet boxes, right? All right, Linux boxes. So it could be like all these are devices, and then inside the devices, so let's look at one of the device. Okay, and inside the devices we will have modules. So this module, so you can see, right? So this is yeah, so you will have modules inside the devices. Let us look at another device here. Okay, so if you look at the devices here and the modules, then inside the device you will have modules, which is the edge agent. This we saw on the portal also, and this is also the same thing which is visible in your Visual Studio. All right. Okay, and then as I said, right, my device is actually nothing but a currently in my setting, it is a virtual machine, which means I can log into the machine. So let me log into a particular machine. So this is one of the devices which I have, it's actually a VM, okay, connected to the IoT hub. Now once a VM which is connected to the IoT hub, it will have the IoT edge runtime. IoT Edge runtime, meaning the runtime which is governing all of the Azure IoT ecosystem. All right. So it has certain commands, like if I give IoT Edge list, right, then it will list all of the modules which are currently running in my Azure IoT hub. Okay, on that particular device. So there could be multiple devices on one such device, which is a Linux VM. I have these many devices running. Okay, and they are the devices communicate with each other via some sort of messaging system. All right, so if you look at how the devices communicate, we just go back to our diagram here. So these are this is one sample device. Okay, all the devices are connected to the IoT hub. The IoT hub is the orchestration mechanism which will receive the messages from the devices and send them to the other devices. So all of the messages will go to the IoT hub. This is we call as the sync. Okay, and then it will orchestrate the delivery of messages to other modules as well. Okay, so just to see another play of interchange of messages in action. So if you go to the deployment template JSON file, which is the JSON file which we use for creating and deploying to IoT edge devices, the module deployment. Okay, so if you see, this is how the IoT modules will communicate with each other. So for example, there is something which is called as downstream to one module. Then what are the messages? Okay, what is the output? So from output of some module, I am listening to, I mean, the output of some module is sending something to my input. Okay, or from my input I'm sending out something to the IoT hub. So this is the messaging mechanism. Okay, so for my particular, which is called as the twin edge module, right? So for my particular module, what I'm actually doing is I'm actually doing something, listening on one particular endpoint and sending out messages to some other endpoint and stuff like that. All right, so this is how messages are relayed between modules. So it is like a listening mechanism. So from messages, modules, name of the module, and output bus, from that output which input topic it is sending into, and what happens when that message just reaches into that input topic, what action should I take, and after I process whatever, I mean, after my business processing is done, once the message is received in the topic on which I'm listening, and then what I should do. Okay, so maybe I might send it to the IoT hub, or I might, just print out the message and do nothing with it. All right, so this is the actual orchestration of messages between different IoT modules and the IoT hub. This is how modules interact with each other. So there's a huge documentation on how to establish routes and how to have modules communicate with each other. Okay, so that discussion is for a different point of time. This is not about IoT edge, so this is just an introduction to IoT edge, and then we will look about how to go around with your Azure video analytics or machine learning on the edge. Okay, so this was just a very brief introduction, doesn't do justice, I know. So IoT edge itself, like module and deployment and runtime itself, is a very huge topic, right? But for, I mean, with respect to the time constraints which we have, this is a very brief introduction and a very a quick look into how we have the edge hub and different modules and dockerized versions. So when I say modules, right, so these are nothing but Docker containers, right? So if you see, this is nothing but the Docker containers. As you can see, these are called from either from the Docker or from the Azure Container Repository, and these are the Docker containers which are encapsulating certain business logic, and the business logic will either take some action, output something, or then send the message to another module to take some another action. So maybe just imagine a scenario, something like yeah, so imagine a scenario something like this is a device. Okay, and that device sort of activates when it's a sensor, so it activates, it starts taking a video, it starts recording a video as soon as the door is open. So whenever you're entering an ATM, a bank's ATM for example, and you open the door, or once you enter that ATM area, maybe that time the CCTV recording will start. And as soon as the CCTV recording will start, it will start sending the messages to your edge device. Now there is one piece of code in that device, so one piece of module which will take the message and just print out information about that, so metadata like timestamp, received, and all. And then it will there is another module which is taking some actionable task, like for example inserting it into database. There is a third module after that, which is for example working on the database and calling some other third party intelligence to extract something else, or or to generate a Power BI report for example, or stream it to, I mean, to some destination, so it can output it out to a file or stuff like that. All right, so this is how you will understand the interaction between different IoT modules. Now these modules could be your AI services, it could be your custom AI modules, right? It could be normal Azure functions which are just doing, I mean, being triggered on some event and doing some other piece of action, or calling other modules, or relaying messages to other devices. Okay, and all of that is orchestrated via the IoT hub. So only the devices without the IoT hub are not of any use. So which means the devices, if the IoT, they lose connection with the IoT hub or they are down for some time, there is a buffer in which the messages will be buffered and then again sent out when the connection is active. Okay, all right. But then for an IoT edge device, you need to have an IoT hub. Okay. So moving on. Again, I'll have to swap the. Okay. So now once we have established some sort of familiarity with the Azure IoT edge and runtime and modules, right? Now let us look at the Azure Video Analyzer. So Azure Video Analyzer, if you are already familiar with the previous video indexer version, so this comes in two flavors. One is the video analyzer, which is in preview mode right now, which is specifically designed for IoT edge. And there is a video analyzer which was previously termed as video indexer for media, which is GA, and which is for the cloud or for your general use cases, like you have a video and then you have to extract insights about that video. What sort of insights we can extract, we'll see a very exciting demonstration of that. All right. So just very quickly about the video analyzer. The video analyzer is basically a intelligent platform to provide video insights, especially spanning the edge and the cloud. cloud. Okay, so it consists of an IoT edge module, the Dockerized piece of code which we saw, and an associated Azure service. The Azure service could be your combination of your cognitive services, or it could be your video analyzer service. Okay, it offers what does it offer is the capability to capture, record, and analyze live video. Okay, and also publishes out the results. Okay, then the video analyzer edge module, okay, is designed to be an extensible platform. Okay, so it will enable you to connect to different video analysis modules, cognitive services, and then use it to analyze your video streams. All right, so this is how thematically the video analyzer looks like. So you will have your this is your IoT edge. Okay, and these are your other cloud services, which could be your video analyzer, cognitive services, custom vision, computer vision. All right, that is parlayed to your business logic. That is a part of your business logic. Okay, these are your IoT sensors, which is sensors capturing videos, or these are your actual CCTV cameras, and some VMS, which is the video management system. Not that much of an importance here, but let's say you have your other business data, which is a metadata about your videos, or some data about your audio streaming and all, right? So these are your sources of audio and video. These you will be sending into the IoT edge. Okay, you will capture, analyze, publish. Okay, and then you will export out the insight into some sort of a business application. Cloud services are your cognitive services, your storage services, your Azure services, basically working in conjunction with your edge logic to provide intelligent insights about your video. Okay, before we go to the video analyzer fundamentals, I would want you to have a look at what sort of video insights we can have. So video analyzer functionality, what sort of insights it is able to extract out. Okay, so let us have a very quick look at some of the exciting features of video analyzer. Okay, so okay, so let's say let us look at one of the videos here. All right, and this video is of Satya Nadella.
There needs to be
and
a fundamental change in the inner.
So I won't play the video. It's a 9-minute long video. It is about Satya Nadella and Sam George speaking about some of the upcoming offerings and some of the exciting technology offerings for Microsoft. All right, and then what sort of video analytics we can extract out from the video itself. So video is playing. I can extract out people, which means who are the total number of people I see in throughout the video, and it will sort of extract out the best face, which means the best representation thumbnail picture of that person throughout the video. So I see two pictures here. One is Satya Nadella, one is Sam George, and it will also give you the number of times they appear in the video, and these are actually the places where they appear in the video. So if you click on those things, it will navigate to that. So if you see the jump to next instance, right, so it will actually jump to the next instance where
A piece of logic just being bound and running.
And actually see it. You can see actually it is navigating to those points in the video where I'm clicking and where that person actually appears. All right. Okay, so they can not only extract out the people, they can also extract out key topics. Okay, key topics, right, about what was being spoken about in the video. So this is something like text analytics cognitive service, wherein it will extract out certain keywords, key phrases. Okay, so this is the key topic, meaning what was the main theme of, or what was the main discussion being circulated around. So these are like unsupervised machine learning extracting out using topic modeling, so like identifying major topics under what your discussion falls under. So it has identified about like a few topics, and if you click on those topics, it will actually navigate to that particular point in the video where that keyword was being mentioned. So now I'm clicking on operational dashboard, and I say jump to next instance. Pardon me. Yeah.
Let's take a look at a operational dashboard.
So this will actually now, navigate me to the point where he's talking of the word operational dashboard, or same for click and deploy and IoT edge. It will also give me the sentiment, which means what was the overall sentiment throughout the video. Was it positive? Was it neutral? And that sentiment is not only based on what is being spoken, but how it is being spoken. Like what are your voice intonations, and what are your, your voice fluctuations, whether you're excited or whether your tone is, just normal, neutral, or you are putting some sort of emotion into saying what you are saying. So it detects that those sentiments also, emotions also. Okay, so it does audio as well as the video transcription sentiment analysis as well. Okay, it will also detect key annotations. Key annotations meaning uh, what are the salient features in few of the scenes which it has detected. Okay, so it saw persons, okay, which was Satya Nadella, Sam George. It has seen the setting is indoor. Then it has seen somewhere, there was a black screen. It has seen something somewhere where it is where it is discovering floor, ceiling, monitors, computers, Nintendo. Okay, so if you click on monitor, and then if you say jump to next instance, it will actually take you to that part where, it thinks that it has extracted out a monitor. So if you see this operational dashboard, right, so it is presenting something on the monitor. All right, okay, and it can also extract out transcription
for this machine, and it's got all sorts of interesting information, temperature.
So transcription is actually, transcripting real time about what is being spoken. So if you clearly see here what the speaker is speaking, it is transcripting out, also doing optical character recognition. So if there is some image presented in the video here, and for example, it try to extract out this Sandvik Corporation here presented here, and do OCR as well as real time transcription. So as the speaker is speaking, this will transcript it. This is like your, subtitles, what we see in your Netflix videos or your Amazon videos, where you're playing the videos and you have your real-time transcription as well as translation. So something is being spoken in Spanish and I'm having the subtitles in English. So transcription as well as translation, both of those are possible. Okay, so people, topics, sentiments, annotations, transcription, and it can also give you additional insights about like what are the number of what are the number of scenes in the video. The total video is comprised of how many distinct scenes, and one scene is comprised of how many shots and how many keyframes. All right, so all those things as well. So these are like the amount of things which you can extract out of the video indexer, video analyzer. Okay, uh, that being said, you can also explore this video indexer.ai media library. Okay, so this is where you will create your own video indexer account for analyzing your videos. Okay, so if you can you have your own videos, you can click on project here, and you can start out your own project. Okay, you can have your library of your own videos, and if you don't, you can just upload from any of your YouTube or any of your other channels your own video, subject to all the copyright and IP intellectual property restrictions. Okay, and then you click your project. So this is very similar to how you do your luis.ai or your customvision.ai, wherein you create a video indexer or analyzer service, and then you start using it on the AI portal. All right, so I have matched my Azure subscription here. So I have connected it to the video in analyzer with my subscription. Okay, and then if you don't have any projects, if in any videos of your own, you can go and have a look at the samples. All right, and in the samples, for example, if I go to this particular video, in the samples, I can see what sort of insights it will be able to extract. All right, so if you look at this particular video being played, my internet is too slow today, pardon me for that. All right, okay, so if you look at this particular video, look at the insights which it has given to you. Okay, so it has It has around nine people in the video, and then all the various times these people are being pictured in the video. The video is comprised of 23 topics. Like the discussion in the video was centered around 23 different topics, okay, which are ranging from technology, software applications, towards like software engineering, entertainment, gaming, video games, startup advice, strategy and stuff. And you click on those and just say play next, it will actually navigate you to that point of the video where this particular topic was being mentioned. It can also detect audio effects. So this is in preview mode. Audio effects, like for example, there is gunshot happening, or audience applause, or dog barking, okay, or some animated sound in the background. It can extract out keywords, okay, so keywords and key phrases from what is being spoken. So it has extracted around 30 keywords, okay. It has detected 139 labels. Like there are like persons here, human face, text, screenshot, like background screen cover, some green screen, all those things it has detected, okay. It can also extract out named entity recognition from what is being spoken, okay. So named entities, like it has extracted out location, I mean landmarks, celebrities, brands, okay, and countries, name of people, known name of people. So it has extracted out South Korea, Canada, UK as the countries. It has extracted out brands like Xbox, then MongoDB, Azure, Bank of America, okay. And then it has also extracted out emotions, like maybe there was 2.29% times there was joy. Again, basis not only the video but also the audio, the way the facial expressions were, the way the voice was, okay. So emotions were detected. And it has detected, like the video is comprised of 29 distinct scenes, okay. Scenes is basically between the time x and x plus 1. What is the thing which has changed significantly? So if you see, like these are two people talking, and then in the third scene there's a total complete shift over of a person and a building and fire. So this is like a different scene altogether. Same way, this is a different scene altogether. So the total video is comprised of 29 scenes, and each scene is comprised of a sequence of shots, okay. So this particular scene was made up of 22 shots, and each shot was made up of keyframes, okay. So keyframes are the representative frames of that particular shot, right? So maybe there was a person moving from point A to point B, and then that movement was one shot, okay. And that particular shot, I identified like that there were three keyframes which are distinctive representation of that particular shot, okay. So person moving, or person rotating from one to B, or a gun toting person rotating himself from point A to point B, was comprised of three keyframes, which is like his direction here, and his movement here. So those are the keyframes. And similarly, a few of these shot will make up a scene, and maybe then cut over to the next scene, where now maybe that person is shooting, or that person is talking to another person, or there is a third person coming in, or there's a total change of scene, and instead of this the person with the gun, we are moving to some other location, or some other locale with some different setting, all right. So these are also the things which you can very well detect with the video analyzer, all right. Okay, moving on. So this was something which very very interesting things, and you can play around and have some real how should I say real learning, as well as excitement when you are experimenting with this sort of features, all right. Okay, moving on. Now when you look at the, again I have to swap. Okay, now when you look at the video analyzer fundamentals, okay, so when you look at that, you will have like as I said, you will have a source, or sorry, you will have a device which is actually the source of your video, okay. You will be then streaming it out into the IoT edge. You will have a custom business logic which is comprised of AI services, third party marketplace modules, and then you will have a pipeline here. Pipeline is a series of steps which you will do, okay. So this is source, then you will have processor, processor could be HTTP processor, gRPC processor, it could be a real-time streaming processor. Okay, and then after all this processing happens, you are going to output it to a sink. Okay, so sink could be like the end where you are outputting out everything. So sink could be your IoT hub. Okay, so you're actually putting everything into the IoT hub, and the IoT hub will be transferring it to other set of devices or other, second IoT hub. So from one IoT hub to another IoT hub, that sort of from IoT hub to the cloud, it could be to the cloud. So these are the sinks. So there will be a source, there will be a processing, and there will be some sort of a sink, meaning some destination where all your processing logic will end up as. Okay, and then you will be outputting it out into the external world, okay, as an external service. All right, so these are few of the terminologies which we need to familiarize ourselves with, which is one is a pipeline topology, which I said, like, it is a series of steps. Like pipeline is, you have to define, even in machine learning you have a pipeline, right, where you source the data, then you transform the data, then you train the data, then you inference the data, then you have performance metrics. So this is a pipeline. Same way for the video analyzer also. So topology, the pipeline will define the series of steps that you take for having some sort of a logic or processing of the video, how the video is processed, right? Then RTSP is one of the processing protocols. So this is real-time streaming protocol. This is what we have also used in our the video analyzer Azure Edge demo. Okay, and then RTSP, which is real-time streaming protocol, it also allows you to capture, I mean, it supports capturing, analyzing, and recording video from IP cameras. Okay, so that support RTSP. Then you will after your RTSP, the processing, there is something called as a recording. Okay, recording could be continuous recording or event based recording. Continuous recording is something, there is a continuous feed being taken, okay, irrespective of whether there are certain events happening or not. So for example, the CCTV cameras in your home, right, so they do a continuous video recording. Event based recording is when some event happens, like for example, when someone enters the room or when a door opens, then only I should stop, then only I should start recording, or whenever the lights go on, right, or whenever there is an alarm which goes which alarm which is activated, and then maybe I should start recording. So these are the event based recording things. Okay, and then finally you have the video itself. For the video, you will have to associate it with the storage account. You will have to create a video analyzer account, as we saw, right, the video analyzer, and then you can use the analyzer to record live video from that camera, which supports the RTSP protocol, and then you can persist it to the storage account which you have created. Okay, so if I'm going to show you the Azure portal, and this is a one-click deployment of the resources which can happen. Okay, so one-click deployment meaning once you click on the deploy resources, it will create all of these ecosystem, the video analyzer, the storage account, the managed identities, and the edge devices, the IoT hub, everything it will create. Okay, and then these are some of the the other processing things, like you have gRPC, which is a procedure call. Okay, so this is a high performance remote procedure call framework. You can have streaming. Okay, so streaming for your streaming your actual video, okay, to clients using different protocols, so with HTTP based, or you can have web players like JW player or VideoJS or Google Shaka player, right? And you have VMS, which is your video management system. They are used for controlling and configuring the CCTV cameras, the speech. So these are some sort of video management systems here. All right, okay, so let us look at a real-time demonstration of our IoT on the edge. All right, not IoT on the edge, of machine learning on the edge. So sorry. So this is the video which which is on which this tutorial is based. All right, so I'm just going to play the video so that you know what sort of. So this is motion detection. This video will have motion detection, in which you see some vehicles moving, and that motion detection will let me know the real-time coordinates of these vehicles. Okay, So when you create this, when you follow this tutorial for detecting the motion, you will be creating all the resources. As I said, you just click on deploy to Azure, and it will, if you have all the requisite admin access on your subscription, and your Azure portal has the requisite required permissions to create the resources and the storage account and stuff, and then it will, by one click, it will create all the resources. So if you see my resources, it has created all these, like it has created the identity, virtual machine, network interface, the IoT hub, right, the video analyzer service, storage account, container registry, all of these are created. Okay. And so this is basically, what are we going to do in this live video feed is, I will be able to, once I start my profiling. Okay, so once I start my profiling here, I will be able to see some real time messages, intelligence about these vehicles moving, right? So now these are vehicles moving. At some point one car entered here, some bicycle entered here. All right, so it will provide me some telemetry information. Okay, telemetry information of the form, like for example, yeah, it will have some messages here, the topic, the event type, what was the event type, and then certain other session information, or information about, here the type was motion, and the bounding box, right? So bounding box and the coordinates of what was being moved. So all of these. So actually, if you see, this is a very how should I say, very very simple use case, just to demonstrate how communication happens. So that video is being played. All right, so when the edge device I created, it already has that video embedded in that. Okay, so when you create all the resources, the VM which is created, it will have that video created in one particular folder, and that folder is streaming this video to our IoT edge modules, and our modules are printing out the messages real time about what is the, what is the heuristics. So I will just uh, demo to you one particular functionality. Okay, here. So let's say, I'm going to use the command. Okay, so as you can see, these are all the messages being received real time. Okay, so these will tell me about the vehicle type, right? And for example, few properties, like what was the latitude, longitude, altitude, right? And what is being passed. So actually this is a communication happening between different modules. So I'm getting this message from some module, and then I'm getting some intelligence about the vehicle, what were the coordinates. If you see, the coordinates will keep on changing here, right? What was the capacity, and what was the type of the vehicle, right? So these are actually the messages which are being intercepted from that video module. So as the video is running, I'm getting all these messages as well. We will see another this thing also, another instance also. Again, you see, this module is not only getting messages, but it is enriching the messages also, right? So it is getting I mean, it is getting some message, and it is giving the timestamp, right? And then it is enriching the messages, and then it is going to insert something in the database, and then it should so you can see, right? This is actually SQL. So it is enriching some information and then passing it on to some other module. So this is all real time. So as your video is being played, different modules work in tandem to give out different functionalities. Some will be giving the functionalities of tracking the location. Some other might be, talking of I mean, enriching the data, and doing telemetry, and then passing the insights on to other modules and stuff like that. All right, so this can also be used in tandem with other AI services. Custom vision. Okay, so custom vision, so you can have actually a classification, right? So video, I mean, whatever is being spoken in the video, you can classify it real time, or you can audit out, censor out content about that video. So maybe this part is objectionable, or this part is confidential, I should not be able to stream it, or I should blur these frames because they talk of some NDA clause, or should not be out in the public domain. So all of these things also can be monitored and can be extracted out by detecting your videos real time. Okay, so it's not only about motion detection, it is also about analyzing video streams live real time. Okay, so that brings us to the end of our journey with IoT edge machine learning, and I'll be happy to take any questions.
Priya, can you give some real-time use case?
As I said, right, the real-time use case is your CCTV feed analysis, right? Or when you're, for example, most of the IoT related thing, let's say you have devices which are deployed in some old age home, right? And those devices now are actually recording the video, and then maybe some health alarm goes on, or someone presses the emergency button, and then only that time, maybe for the last 10 minutes, whatever feed was captured should be analyzed now, right? So now then that is the time when my devices will actually connect to the IoT hub, and then profile the video, get out the analytics, and try to convey whether what has happened, or does that video feed need to be analyzed, and what was the emergency, and then accordingly have the action taken, like should it be escalated to it should be escalated to the facility, or it should call ambulance, or it should be routed to 999, all those things. This is one of the use cases. Another use case which actually which we are actually working on, one such use case is where it is in the defense sector. Well, actually the soldiers are actually wearing live video cams, and then recording their locations, and then sending it out to the IoT edge for getting intelligent insights, like what is the shortest distance to my home location, or is this an enemy territory, or is this a real friendly territory, or how far am I from my own mothership, or my own group of soldiers. So those kind of, so you're wearing a device, okay, or you're wearing some sort of a GPS tracking tag, and then that tag will actually give your locations real time to some IoT edge module. Okay, that IoT edge module will be having some AI capabilities, which will then give you, like, basis your coordinates, real time tracking of your coordinates, shortest distance to your destination, or whether you are in an enemy territory or in a friendly territory. So those are some of the more practical applications of a live video capturing, or live stream capturing, coupled with the edge and AI.
So you mentioned about we can integrate with a different service like vision and etc.
Correct.
Like so, it's
Right.
like we can add. It's like a plug and play model, or we have to do a customization to enable that such feature in that current use case.
So see, for example, as I said, if let us go on to the Azure IoT Edge again. Okay, where is my IoT Edge hub? Yeah, okay. Let us go to the hub. There's something which is called as. Let us go to the devices. All right, when you go to the device, there is something called as set modules here. All right, so set modules. So now these modules, you can be your own user defined modules, or you can have modules from the marketplace. So there are certain dockerized versions of modules, like for example Azure SQL Edge is dockerized and kept on the Microsoft Container Registry. Or all right, or you could have what you can say, like if you have some dockerized versions you created for cognitive services, those you can directly use here. All right, let's go back to the module which we created. So in this program.cs, right, there's nothing that stops me from from developing a logic using custom AI, or using text analytics, or using a speech to text service. All right, and then this I will just right click and deploy. So if you just look at here, there is some option called as create deployment for single device, and then you can deploy directly to the device which you want. Okay, so you will click and deploy to the device of your choice, and this module will be deployed. So there is if using the portal itself, there are unlimited modules which you can add. Okay, so there are few marketplace modules of Azure, which is SQL, Azure SQL, or Azure Cosmos DB, or certain other simulated temperature sensor, and those things you can directly add. But let's say if you want to actually use cognitive services, you will have to write some sort of a Azure function or some sort of code to integrate that cognitive service which is out there. So use the consume the REST API endpoint of that cognitive service, and then do your programming logic and deploy it onto the IoT edge. So there it's a it's a trade-off between what sort of modules are directly available out of the portal, I mean out of the box in the portal, and what modules you need to code out on your own for deploying it to the IoT edge. I hope that answers your question.
Yes, Priyanka. And thank you for this wonderful session. And it's properly well and organized, the session as well as the demo.
No problem.
Can you share some resource link so that I can share in the comment or chat?
Sure. Let me give you some demo links which I had done here. Okay, so yeah, okay. And then let us go to video indexer. Oh, sorry, it should be AI. And let us go to Azure IoT docs, which is Azure IoT. Right. So these are some of the these are some of the documentation which you can follow. And of course, when you are doing the detection using Azure IoT Edge, yeah. Yeah, so these are few of the links which are detailing out the quick starts and about video indexer demos, and about video indexer website where you can start creating your own projects.
Thank you, Priyanka.
All right.
Yeah.
Thank you so much, and all the best for rest of the sessions.
Thank you, Priyanka. Thank you.
Bye-bye.
Bye-bye. So the next session given by Sweta, she's going to give a demonstration about how to optimize and about the cost and performance Cosmos DB workload. Shweta, it's your. You can go ahead.
Hey everyone, hi, so excited to be here at AZConf. Yeah, my name is Shweta Nayak. I'm program manager with the Azure Cosmos DB engineering team. And today I'm going to talk about how to optimize the cost and performance of your Cosmos DB workloads. Right. So here's my agenda for today. I'm going to do a quick refresh of the concept of request units in case if anybody is new to Cosmos DB. Then I'm going to talk about a few tips and best practices for workload planning or development on Cosmos DB. Then I'm going to move to some tips and tricks and best practices about read optimization, followed by write optimization, and lastly, how to use tooling to track the cost and performance in order to be able to optimize it further. Right. So Cosmos DB, as we know, is a managed service, and we charge for basically the throughput and storage, right? What is request units over here? So throughput is measured in terms of request units, and request unit is basically the abstraction of CPU, memory, and IOPS that is needed to perform an operation on Cosmos DB. Right. So as you can see on the right hand side over here, the RU depends upon the type of operation that you're doing and few other things like consistency level and the regions you are reading or writing to. So it could be different types of operations like read, insert, update, delete, and queries, right? So to give a simple example, a document read of 1 KB size from one region will cost 1 RU. Right. So similarly, the cost for insertion, updates, deletion depends upon the size of the document, and queries, it's variable, again, depends upon the type of filters that you have specified and more such factors. I'll cover more details about that in the upcoming slide. So usually the cost and performance optimization basically go hand in hand, right? And you need to lower the request unit in order to reduce the cost and to improve the performance of your operations. So with that basic concept of RU clarified in mind, I'll start with the first set of tips around planning a new workload or a new application or data set in Cosmos DB. Few tips are also around improving the development cost, discounts, and also making sure you have the right quantity of resources assigned at the right level. So I'll start off with the capacity calculator. Now, Cosmos DB capacity calculator is available on this link. And this is the first place you should be visiting to estimate the cost and throughput that you need for your operations. So let's take a look at the capacity calculator. So this is what it looks like. I strongly recommend signing into this capacity calculator just to be able to see all the options available. The calculator currently works for 3 of the APIs in Cosmos DB. So we have total 5 APIs, SQL, MongoDB, Cassandra, Table, and Gremlin, right? So currently it's available for these 3 APIs. You can specify the number of regions you want to use, whether you want to use multi-region writes, the consistency level, the indexing policy, whether it's automatic or you want to customize it, the amount of data you're planning to store, and whether you're planning to use the analytical storage. And then you can come down here and specify the size of an item or even upload a JSON sample, right? So this JSON sample should represent the structure and size of a document that you're going to use in your collection or data set, right? And then you specify the types of queries, the number of queries you're expecting to perform in your particular workload, right? So there are point reads, creates, updates, and so on. Like I said, the charge required for query may vary. So you might need to get an estimation of that from the portal query statistics. I'll show a demonstration of that also a bit later. And then you can specify the query charge over here, the estimate that you expect, right? So what are the overall steps? Basically, you start with identifying all the different operations that you are going to perform against your workload. You then identify the cost per operation. The calculator will help you with that as long as you specify all the other details that we saw. And then you want to enter all the top operations that you're expecting to incur the cost and get a sum. So something like this. And as you saw on the right-hand side, you'll get the total estimated cost per month, as well as a breakdown of the charges as per the operation types. Right. So this is what should be the first step in estimating workload, either a new workload that you want to introduce into Cosmos DB, or yeah. The next thing I want to talk about is the Cosmos DB emulator, right? So this is something that's super useful for local development, because this will be available on your desktop. You can install it either on Windows or Linux. These are the links, short links to both the versions. And it supports 5 APIs. And you can use SDK or REST API to interact with the emulator. So basically, the emulator can be initiated through a command prompt and command line interface. And there are parameters available to tell the emulator whether you want, which of the APIs you want to use. There are flags for that. So you can initiate it accordingly, and I can quickly show you. So it runs in your local host, and you get a URI and a connection string to connect by. And you can even, in SQL API, we even have a data explorer over here. You can import a sample data set and perform test queries against this data. And as you can see, this is the, you can even get an estimate of the operations of the request charge and the request charge and stats of the operation that you are trying to perform, right? So this is not a complete replacement for your actual cloud service, the Cosmos DB cloud service, but it's extremely useful for testing locally and developing locally. And the difference between this and the actual Cosmos DB service is basically this doesn't have the concept of different consistency levels or multiple regions, right? So it wouldn't take into account any of those factors. But from feature and syntax perspective, you can definitely start from here and then move to testing on the actual service. Of course, do not skip testing on the actual service. The next thing I want to talk about is free tier. So we recently increased our limits for free tier offering. So what we have right now is 1000 RU per second and 25 GB storage free each month. This is free for lifetime for one Cosmos DB account per subscription. Now, this is great because if you're provisioning the right throughput to stay within this limit, for example, if your workload is small and it needs less than 1000 RU per second, this could literally mean that your development environment or testing application or even small production workload can become free, depending upon how big your workload or how big your requirement is, right? So there are two ways you can use this. One, like I said, for example, if you create one collection and set 1000 RU per second limit to it, provision throughput limit to it, that can literally mean that your collection is free. Or it could be two containers, one with a setting of 400 RU, one other one with a setting of 600 RU provision throughput, still within 1000, so works well, right? So in that case, your entire Cosmos DB account will become free. Another way you can use it is you can use it as a discount. So you can say, I want to provision RU of 4000 RU per second or the collection or database. And the first 1000 RU per second will be free, and you'll pay for the additional usage. So that'll be the free tier discount that you avail. Right. So another great way you can reduce cost and optimize your overall cost for your environments. The next important thing I want to talk about is choosing the right throughput mode as per your workload, right? So we have 3 throughput modes available, and depending upon which one you choose, you can basically optimize the throughput mode as per the requirement of your application, right? One thing to keep in mind is that there is no warm-up period needed for scaling up and scaling down in Cosmos DB because the resources are already provisioned. It is not like we are going to provision vCores after you raise the request. It is resource governed in the background. So scale up and scale down is instantaneous, right? Another thing to mention is you can scale in increments of as small as 1/100th of a VM. So there is no such barrier for multiplying the SKU size or something of that sort. So let's take a look at the 3 throughput modes. So first one is provision throughput mode. This one is usually used when your workload has fixed requirements, right? You more or less know at a per hour level because it is metered at a per hour level, right? So you more or less know how much throughput your application needs, right? In that case, you can go with provision throughput mode. Now, this doesn't mean that it has to be same all throughout the month or all throughout the year. It is metered hourly. So let's say if you want to change it to a particular level during the day and reduce it during the night, or increase it during weekdays and reduce it over weekends, or even let's say increase it during ingestion and reduce it after the data has been ingested, right? So those things can still be done in provisioned throughput mode. So there is still that flexibility over there. The next one is auto scale mode. So in this mode, you can granularly scale from 10 to hundreds of millions of requests per second. What you basically need to specify over here is a range of throughput values. So let's say from a 10% to 100% range of the maximum RU value that you have specified, it can vary depending upon the requests that you're receiving at that given point of time. So this is extremely helpful for workloads with varying and unpredictable traffic requirements, where you do not know at which time of a day or of a period the traffic might go up and down, right? So that's why you can use autoscale and get the best performance per price. The last one is serverless, right? So in both provision and autoscale modes, you still need to define a particular value of throughput and RU that you need, right? But what if you do not want to pay for a specific reserved RU or even a range, right? So that's where serverless comes into picture. So this is a consumption-based billing model, and the limit that we have right now is 5,000 RU per second and 50 GB per container, which is collection, right? So this is suitable for spiky workloads where you might see intermittent traffic sometimes here and there. You do not know whether you want a consistent assigned dedicated throughput to this or not. So you just pay for the requests that you use. And again, there is no limit on the scalability though. As soon as a request comes in, it will get serviced. There is no warm-up period needed. So those were the 3 throughput modes that you must remember and know which to pick from for your workload requirements. Next thing you want to decide is whether you want to use shared or dedicated throughput, right? So this is basically you want to define whether you want to share resources at database level or you want to assign the throughput at single collection level, right? So the database level throughput, shared database throughput can be shared among all containers in the database. And you can even do a mix of 2. So here's the account. Basically, if you look at the resource model, there's an account, and inside that there could be multiple databases, and inside a database there could be multiple containers, right? So you can define you're defining shared database throughput at database level, and all the containers in that database will basically get that throughput. So you can use this in cases where you do not know which container, which collection is going to need more RU at what point of time. So you're basically leaving it flexible. The next one is dedicated container level throughput, right? So you have database, but you're not assigning a throughput RU at database level. You're assigning it to a particular container or collection. So that particular container will have that throughput reserved for it. The neighboring container cannot, utilize throughput of the other one. And the last one is the mixed one. So you can say that I am assigning throughput at database, and a bunch of collections in that database will use this shared throughput. But you also want to say that, hey, I have this one collection for which I want dedicated throughput, and you can assign dedicated throughput for that collection, and the rest of them can share the database throughput. So that's another way how you can optimize your throughput and cost, right? The last one I want to talk about today is reserved capacity discounts, right? So if you know that you are going to need N quantity of RUs for the next 1 year or 3 years, reserved capacity discount will help you save up to 65% cost. So these are a few examples of the throughput level that you are reserving versus the cost savings that you're getting, depending upon if it's a single region or multiple region, and the term that you're period that you're choosing, 1 year or 3 year term. And reserve capacity does not mean that you need to pay upfront for 1 or 3 years. You can still pay on a monthly basis, but avail the reserve capacity discount, right? So that's another great hack to save cost. So those were a few tips and tricks while getting started or while planning or reducing development costs and so on. Now, let me talk a bit about optimizing reads in your Cosmos DB workloads. So let's clarify the read types. So firstly, we have something called point reads. So in point reads, you are basically doing a key value lookup on a single item ID and partition key. So you're specifying the partition key. Partition key is what you use to for scalability in Cosmos DB. So you each partition key will define the logical partition that you have in the collection, right? So if you're doing a point read with an item ID, which is a unique ID of that document, and the partition key, which means you're pointedly reading one particular document in the collection, then the efficiency and the cost of your request will be minimum. So best practice is to try to maximize point reads in your application code as much as possible. Then there are queries. So in queries, you're not reading one particular document. You're basically filtering a bunch of documents from your data set. So this is the, from top to bottom is the order of efficiency. So the point reads are the most efficient reads that you can do. If you cannot do point reads, try to use queries where you're using a filter clause which specifies a single partition key. So it'll perform and scan for the query in that particular partition key, and that's the second most efficient thing that you can do. Slightly less efficient than that is querying with an equality or range filter clause on any property. So this will still use indexes, but it will still know roughly which partitions to scan. So this is something that you can do if you can't do either of the previous ones. And the least efficient and the least, try to do minimum of these, that's querying without any filters, right? So that's what you need to keep in mind while if you're using a read heavy workload and if you want to optimize reads in Cosmos DB. So we saw point reads, we saw queries. So what defines the charge of a query? So like I said earlier, it could be it could be varying, it could be subjective. So these are a few factors that define the query charge, right? So it depends upon the number of query results that you're getting in that filter that you have specified. So more the number of documents, more the charge. It also depends upon the number of predicates that you're specifying in the query, the nature of the predicates. So what is it asking to do? The number of user-defined functions, if you're using any in your operation. The size of source data. So once again, more the number of documents in the source collection, more it needs to scan to get the particular result set. That's the reason why the size of source data is important, as well as the size of result set, the number of documents you're returning in the response. And the projections, the fields that you are exposing in your query response. So these are a few factors to keep in mind because these affect query charge. And if you take care of these or look into these, you can basically optimize the charge that you are incurring for an operation. So now we have established what's point read, what's a query, right? And as we saw, the top two ways of incurring minimum possible charge with best possible performance is by using the partition key. So choosing the right partition key becomes extremely important in this case, right? The partition key in Cosmos DB is immutable. So once you choose it while creating a collection, you cannot change it right now. That's another reason why choosing it correctly is important right up front. You can choose any string or numeric value or field in your document as partition key. Make sure whichever field you choose has high range of values. So it should have multiple values for that particular ID or whatever document ID or whatever you're choosing, right? So it should have a large number of values. Do not be hesitant of using a partition key that has extremely large number of values. That will only help scale your app or your workload better. Second thing is it's important to have high cardinality. So these documents should be evenly spread across these partition keys and should have similar access patterns. So what it means is, so you're both in terms of your storage space for each partition key range and the request units, it should look more or less uniform, right? A little bit of variation is fine, but it shouldn't be too much like in this case where there is disproportionately high number of operations on one partition, and similarly there are a couple of cold partitions that do not get as many requests and as many documents, right? So that's another thing to keep in mind while choosing the right partition key. So few tricks that you can use is see what types of queries that you want to use against your data set and try to use the use a key that's happening to be frequently being used in your query, right, as a filter. So that will help you determine what would be the best partition key. What queries are you going to perform? It depends upon that. Multi-item transactions span a single logical partition, so you can choose a key that can work well in this way, right? I wouldn't go into too much detail about how to design a PK key, partition key, but yeah, these are definitely a few things to keep in mind while choosing a partition key for getting good read performance. The next thing is the data model. So again, few things to take care of while designing and defining your data model in Cosmos DB. So you can use embedding to reduce the number of reads. Basically, keep the properties together in one document, and that way you can reduce the number of reads. The next thing you can do is control the document size and the number of fields that you're reading. Now, this might be sounding a bit contradictory that we are asking to embed as well as control the document size. Basically, it depends upon the workload and which properties you want to read simultaneously and of which fields you want to read together. So You can keep frequently read properties together in a document and separate out infrequent properties into a separate document. So those options are there. Next step is do not store media data types such as images or large text of blob in your Cosmos DB document. You can use blob storage for that, for storing images or whatever else you have, and store a link in your document, Cosmos DB document, right? So this will help keep the document size small and improve the efficiency of your query or your read, and keep down the cost of the read. One pattern to be aware of is co-locating different entity types in the same collection. So I'll cover an example of this, but basically Cosmos DB is schema agnostic. So you can put different entity types in the same collection, although it might not be intuitive, but it works well in if your requirement is needs this, right? So I'll go a bit deep into both embedding and co-locating entity types pattern. So like I said, embedding documents might not be intuitive for folks who are from relational database background and are used to normal forms, but it works well in NoSQL. So when to embed versus when to reference, right? So you need to embed when you have one-to-one relationship between particular fields. So let's say there is a person name and a contact number. That's a one-to-one relationship. So it could be embed, right? One-to-few relationship could also be embed. So for example, a person's name and addresses, they might have 2 or 3 addresses, but it's not going to be like unbounded, right? So that's another scenario. You can also embed when related items are queried or updated together. So embedding is useful not just for read optimization, for write optimization also. So basically, if you have a workload and you want to read particular fields or properties together, you can choose to embed them. So that's a general guide. When to reference. So if you have one-to-many relationship, especially if it is unbounded, then you can probably choose to reference. An example would be, let's say there is a movie and the reviews for that movie, right? So movie reviews can keep adding up and it can literally be an unbounded array. So it might be a better idea to keep it in a separate collection or entity. Also reference when it's one-to-many, many-to-many relationship. So for example, if you have many people, person documents and task documents, right? So that could be multiple. So you can choose referencing at that time. And related items are queried or updated independently. In that case, you can once again reference. So those were a few guides on when to query versus when to reference. So here's where the approach between SQL and relational, NoSQL and relational is different, and you can keep that in mind. The next pattern which I told about is co-locating entity types, right? So this leverages the schema agnostic nature of Cosmos DB. So you can basically add, it's a hack where you can basically use a field called type. So in this case, in this example, so we have sales order and we have a customer, right? Now, typically we would keep this in separate collections, but let's say if you want a similar, you have a similar access pattern on both of these documents, and also you have scenarios where you want to read both of these together, right? So in this case, you can use this type of co-location, specify a field called type, and keep both the types of entities in the same collection. You're specifying the partition key as the customer ID. And what you can do is when you're reading with customer ID, you can basically read both the documents. So effectively, it's like a relational join, right? So that's one great pattern that you can use. Next aspect to optimize reads is indexing. So typically in SQL API of Cosmos DB, all the fields are indexed by default. But if you're using one of the other APIs, you might need to customize the indexes based upon the query pattern that you want to use. So frequently used filters and sorts, do create indexes for them, because that will greatly help reduce the cost. You should use compound indexes when you're sorting. You want to sort and filter by multiple fields. If it's single field, you can just use wildcard index. If you are using multiple fields and multiple single field filters, and you can use wildcard index or single field indexes. But if you're filtering or querying by multiple fields in the same operation, then choose to use compound indexes, because that will be more efficient. Next thing that we you introduced recently is indexing metrics, right? So these are supported currently in the SQL API .NET SDK version 3.21 later, and Java SDK 4.19.0 or later. So what do we mean by indexing metrics? So this is a sample output of the indexing metrics that you get. So you get to know if a particular index is a high impact index or not. You also get guidance on potential issues. So here's what we are seeing. It's recommending us an index spec with these two compound indexes based upon the queries that we are doing. So another great way to figure out and optimize your read cost. Couple of other tips for reading. Use TTL or change stream to archive data. So like I spoke in the factors that affect the queries, one of the factors is the number of documents that you have in the collection, and the response, the number of documents that you get in the response, right? So TTL will help keep the cost of queries as well as storage low. So will change stream. So you're basically archiving data that you don't need, so it doesn't need to scan over all those unnecessary documents and incur more charge. You can also use, if you have multiple regions, you can choose the second region or remote region for ad hoc queries. So you have, let's say, a estimated workload and a provision throughput assigned on your primary region. You don't want to disturb that, but you want to check something that's ad hoc. You can use a remote region for that. So that's another great tip. So those were the best practices about optimizing reads. Now let me talk a bit about optimizing the writes. By the way, are there any questions? Maybe we can get to them later. All right. If you have any questions, do post them in the chat and we'll get to them. So optimizing writes, right? So let's take a look at the tips for that. So once again, just like reads, the item size and the number of fields that you're writing does affect the write performance and cost, right? So do make sure you keep that in check. I've already covered the embedding versus referencing best practices earlier, so I'm not going to repeat that, but a lot of those do apply to write optimization as well. And once again, don't store images, binary text, or large chunks of text, I meant text, in the document. Instead, store them in blob storage and use a link in the document, and that can help you keep the costs low. Next thing you want to do, especially if you have a write-heavy workload, is customize the default indexing policy, right? Now, like I said, for at least SQL API, all the fields are indexed by default. But this might be a problem if you have a extremely write-heavy workload. The reason is because every time you write a document, you are incurring an RU charge, not just for writing the document, but also for writing the indexes for all those fields that you have defined in the policy, right? So do customize the default indexing policy, especially if it is a write-heavy workload. Next tip is to use streaming wherever possible and try to avoid batching process. Batching process is an anti-pattern, so use streaming because that spreads the writes evenly. For large ingestions, so if you want to say, let's say, ingest bulk data instantly, you can use bulk executor. This is available for SQL API, and it is designed to saturate the throughput. So it'll use your maximum possible throughput. So your writes happen, your ingestion happens as fast as possible, as well as it takes care of the rate limiting that you might see. So it keeps all of that in check depending upon the provision throughput that you have defined, and takes care of the bulk ingestion. So that's a great way to, you must use bulk executor if you're using SQL API and SDKs for ingestion. Or if you're not able to use the bulk executor, or if you're using one of the OSS APIs like MongoDB, you can spread the writes over a period of time by controlling the batch size. So you can define the batch size depending upon the quantity of data that you're ingesting, as well as the size of each document. And you can tweak that and make sure it stays within the provision throughput limit, but still completes as fast as possible, right? So you can do that for write optimization. So we spoke about the tips and best practices, but I also wanted to talk about how to track where your majority of the cost is being spent, or what is causing that bad performance, right? What's contributing to the cost as well as the performance. So there are a bunch of tools that we can use for this. So I'm going to quickly cover some of those. The first thing to use is query metrics. So you can check the query metrics from the portal or SDK that you are using. So basically in the response, you will get query stats, and it contains details about the request charge, first of all, the number of documents the query has returned, the documents, the response size, the indexes, whether or not it has hit the indexes, and how many of the documents were from the indexes, the query engine execution time, and so on. If you have any user-defined function, it will show a split of that as well. So you get a better view of where your time is being spent, and how much is the charge being incurred for a particular query. So again, you can get this from the portal. So in the portal, you can just go to the Data Explorer and run a query, and on the right side, you'll see, this is the portal screenshot actually, and you'll see the query stats over there. You can also get it from SDK. You can check the query stats for a previous operation. You have different, it's called different names in different APIs. So you have explain command, which is a native MongoDB command, which provides the same functionality as well. And in Gremlin API, you have execution profile, which is kind of, again, it meets the same purpose. So use either of these methods based upon which API you're using. The next great thing is insights, right? So you can basically use these Azure Monitor insights. And so it's available over here. So if you go to the Azure portal Cosmos DB account, and you have the insights blade here under monitoring, you can choose, you can view the insights by particular time range. So in this case, I've customized the time range. You can filter by database and by collection. So you can see the metrics or the insights for that particular database and collection. Here it is. Right. So there are a bunch of blades and bunch of views over here. These are default views available. So as you can see, you can view throughput, the requests that you're receiving. So how many of those are throttling errors? What are the different types of operations that it was receiving at that particular point of time, and so on. So as you can see, you also get details about the index, the storage, index usage, as well as the document usage. In the overview, you get a split of the requests as well as storage as for each collection that you have in the database, and which one is high, which one is low, and so on. So bunch of things that you can view over here. So I just wanted to give a few examples of some of the key metrics related to performance and cost in Insights, right? So the first one is normalized RU. So what is normalized RU? Normalized RU is basically the maximum RU percentage used by any partition key ID range in the collection, right? So if so this is one view, and as you can see here, the normalized RU is hitting 100% for one of the partitions, and this view is also showing the normalized RU by partition key range. It's available at the same place right here, where I showed in the portal, right here, right? So you get a split by the partition key range ID. In this case, I have only one. So yeah, so this is what it looks like. And hitting 100% of normalized RU might not necessarily be bad. It just means that you're using the database optimally. So you want to look at the normalized RU as well as the throughput, the throttling errors that you are getting, right? So if also few throttling errors might be again normal, that means you are effectively using your provision RU. But a lot of throttling might mean you're under provisioning, right? But at the same time, normalized RU being extremely low, like for example, in this case, it is constantly around, maximum 8%. So that means I am underutilizing my provision throughput, and I might need to rethink if I need that high of provision throughput, right? So that's one key metric. You can also use Insights to track hot partitions, right? So like I said before, hot partitions mean that you have unevenly distributed requests over the different partition keys that you have. So this is an example of a hot partition. So you can see that one partition has extremely high, this is a heat map of the requests. So one partition has all the requests being bombarded to it, and the other partitions are quite okay, right? So this is a bad pattern, and you can use Insights to detect and fix this. Second example is example of even distribution across partition key ranges. So it's blue and evenly distributed. There is no glaring high value for one partition key range and so on. So it's all good. This is where you want to be. The next thing that you can track using Insights are the number of requests that you're getting, the type of requests that you're getting, and whether there's throttling happening and so on. So that you can see in the requests tab of the Insights, and you can see the split by operation type over here. And the last thing is the latency, right? So where is the time being spent? Is it being spent on the server side or somewhere on the client side, right? So this will help you determine the server side latency and help you decide whether you need to tweak or tune the performance on your Cosmos DB collection data or on your client side. There are multiple ways to troubleshoot the client-side issues as well. I'm not going into that in too much detail. Today, I'm focusing on the server-side optimization. So this is a great insight to look for and track. Right, so the next tooling piece that you can use is log analytics. So this is disabled by default, but you can enable it to troubleshoot and get more details about the requests that are being performed against your Cosmos DB account. So you can either keep it enabled throughout, or you can, let's say you want to debug and figure out where the charges are being getting incurred. You can enable it for some period of time and disable it later. So there are two modes in which you can use the diagnostic settings for log analytics. So one is the Azure Diagnostic Farm, which is the old model, but the new model, resource specific model, is again a bit more cost efficient because you can choose which type of logs you want to keep in the log analytics. So here are a few basic log types you can start with: data plane requests, query runtime statistics, partition key statistics, partition key RU consumption, and control plane requests. So it'll log all of this data in separate tables in the log analytics workspace. Right. So this is available once again from the portal, diagnostic setting, Blade, and yeah. So this is where you define the diagnostic setting and the log analytics workspace that you want to use, right? Second thing you can also do is enable full text query. So this will log the complete query that you're using in the log analytics requests, right? This wouldn't be enabled by default. Again, you have to go ahead and enable this from features and full text query. So my status is on right now. So let's go to the log analytics workspace, and I want to just go through a few examples of the queries, the log analytic queries that I can use to see what operations that were performed, what were the operations performed against my data set, where and use different parameters and conditions to see to track my performance, right? So first one is filtering queries that are taking longer than 10 milliseconds, right? So let's run this one and see how many queries I have. So this is KQL, Kusto query format. You can also save the queries over here like I've done, and you'll be able to view it from the save list. There are also a bunch of default queries over here, but you can choose to add comments like this and save your query and look at them later. Right, so these are the requests that are taking more than 10 milliseconds, and I can see all the different fields over here. I've not restricted the fields in my logs. So let's see what other things I can see. I can see the account name, the operation name, the connection mode, so whether it's gateway or direct mode if it's SQL, the activity ID of the request, the user agent from which it is coming. So in your application, you can tweak this user agent. And if you have like multiple applications, then this can be a good way to track which was that application causing that spike or higher requests, right? You get other things here like the status code of the request, the client IP address, the request charge of the operation, how long it took, length of the request, length of the response, the region name, authentication type, and yeah, that's pretty much it. So bunch of these fields might be useful for you to understand the cause of your poor performance. So this is a great view to have. Another example is I'm doing the same thing that I did before. I am filtering queries taking longer than 10 milliseconds and summarizing them by client IPs. So as you can see here, this is all a Kusto KQL format. So you can refer Kusto documentation, Data Explorer documentation for that. Yeah, so you can basically, as you can see, I'm getting the requests based upon the client IP address and time generated. Another example of query is the number of requests that I'm getting over time, right? So as you can see, so this is what I'm running, and I'm rendering a time chart. I'm summarizing the count of requests by the time generated and splitting it over 5-second intervals. So here's the pattern that I'm seeing for the requests. So if there was a particular period of time where you saw extremely large number of requests, you might be able to figure that out from over here and troubleshoot that further. Highest RU operation in a given time window. So if I run this, once again, I'm splitting the I'm checking the maximum request charge of an operation over a 10-minute period over here, and I'm getting the view by operation type. So as you can see over here, there were a particular query set of queries that took up to like 14 RU charges in this time interval, and yeah. So again, you can use this to track the operations that are incurring high RU charges and go ahead and debug that. Operations taking most RUs. So I'm ordering it by request charge over here. So let me see. I've basically taken 2-hour interval over here. Let me increase it to 6-hour, and hopefully I should see a bunch of more queries over here. So yeah, so these are the requests I received over the last 6 hours, and this is sorted by request charge, ordered by request charge. So yeah. And last example, average query charge over 5-second interval. So here, once again, I'm filtering the particular account, Cosmos DB account. In this case, I'm specifying that I only want to look at the queries and get the trend or the pattern of the max average request charge for queries over a period of time. And this is what I can see. So any anomaly, any outliers, I'll be able to detect using these and go ahead and use my performance best practices, optimization best practices, right? That's all I had for today. I hope this was useful. You got some tips and best practices through this session. Do reach out to either me or Cosmos DB accounts on either on the chat or over Twitter or LinkedIn, and we'll be happy to answer any questions that you have. Okay, I'm just going to look at the chat. Okay. Hey, Vijay?
Yes, Shweta.
Yeah.
Yeah, I have one question. So I'm just working for in Cosmos DB more than some around 3 to 4 years. So is this newly introduced, like the Cosmos calculator, or it's previously it's there?
I think it was there before, but we have hugely improved upon it quite recently and also added APIs. So yeah, I think some functionality was definitely there, but it has become better over the last year or so. Yeah.
Okay, thank you. So if the calculator will work for the multi-region, or it will be just one single throughput we can?
No, it will work for multi-region. So you can specify the number of regions you want to use over here, and it will, depending upon a document size and the operations, it will calculate the operation cost based upon how many regions you have. So you can increase, for example, you can specify 2 or 3 regions over here, and it will take that into account while calculating the estimates. So I can run this quickly over here, and you will see that. Yeah, you can see here the amount has increased, even though I just increased the regions, but didn't change the operations.
So it will be applied for serverless mode also, right?
Yes, if you want to, but this is basically, so serverless mode, it doesn't matter, right? You only pay for the requests you use. So there's no need for estimation because you're not provisioning a specific value like in provision throughput mode or a range like in auto scale mode, right? So serverless doesn't need this. But yeah, this would be more useful for provision and auto scale, definitely.
Okay, so sometimes while architecting the solution, we have to give the estimation, rough estimation to the client that, hey, this will cost this much. So that time, but end of the day, we choose serverless only. But for at least a rough estimation, like it will cost around $50 to $100. So we can use this.
Correct. Yes, you can.
Yeah. Sure. So you can stay on the call for next 5 minutes. If any feedback or any question you get from the chat, you can reply.
Definitely, yeah.
Thank you, Shweta. Thank you for the wonderful session.
Thanks, Vijay.
That was a lot of fun. I'm like, let's go dance music.
Hey, hi, welcome, Rob. So our Rob going to present how to choose a Docker, use the way of using Docker in Azure. Is your platform.
Very nice.
Enjoy the day. Yeah.
Choosing from the many ways to Docker in Azure. There's lots of ways to run containers in Azure, and we're going to take a look at each of them and understand when it may make sense to use that particular form of containers in Azure and when it might make sense to choose something different. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been that person chasing the speaker, and it didn't work out for me very well either, which is why you can head to robrich.org and you can download these slides right now. Let's head out to robrich.org. Here is choosing from the many ways to Docker in Azure. The slides are online right now. While we're here on robrich.org, you can click on About Me and learn some of the things that I've done recently. I'm a Cyril developer advocate. If you're struggling with your data mesh, I'd love to learn from you. I'm a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start Friday after work. Sunday afternoon, we deliver completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in India or wherever you're connecting from, hit me up on email or Twitter and let's get a Give Camp in your neighborhood too. Some of the other things that I've done a lot with Azure and with containers. SQL Source Control Basics, mine is Chapter 8. That was a lot of fun to build. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's talk about Azure and containers. There's lots of different ways to run Azure, run containers in Azure. We have Azure Kubernetes Service. We used to have Azure Container Service. We have Azure Container Instance. We have Azure Service Fabric. We have Azure App Service. We can install Docker in VMs or spin up our own Kubernetes cluster. And we can even use Azure Container Registry. So the natural question then is, well, which one should I choose? I'm going to frame that a little bit differently and talk about less about which one should you choose, and rather, when should you choose each one? Because each one has its place. Now, you're probably not going to use all of them, but you may use a few depending on your needs. Let's talk about Docker. Now, Docker is this mechanism around container virtualization. Docker didn't invent containers. Containers were already here. Docker just made it easy to use. Containers are this lightweight kernel virtualization. We're virtualizing the operating system instead of the hardware. And so Docker is this ecosystem that makes it really easy to use. Docker didn't invent containers. Docker just made it easy, much like XML HTTP request and AJAX. What's the difference between XML HTTP request and AJAX? Well, from a technical perspective, nothing. But from a user experience perspective, everything. XML HTTP request is the thing that powers the Outlook right-click menu in Outlook 2019. In the 90s. By comparison, AJAX is a methodology of using it that powers Google Maps and Facebook and that app that you're going to write tomorrow. Docker didn't invent containers. Docker just made it easy for the rest of us to use them. C groups, namespaces, jails all existed before. This mechanism of virtualizing the operating system instead of virtualizing the kernel became a lot easier when Docker created this mechanism. So as an industry, we're probably almost past this, but just to level set, on the left, we have traditional virtual machines. On the right, we have containers. On the left, we can see we have a duplicate copy of a lot of the operating systems because we're virtualizing the hardware. So we need to put an operating system inside each virtual machine. By comparison, on the right, we still have a hypervisor. We still have the same sandboxing, but we don't need that duplicate copy of the operating system. We only need the difference between the host operating system and the content that we need to run in containers. So we'll run Linux containers on a Linux host, and we'll run Windows Server containers on a Windows Server host. What's missing? Well, what about GNOME and KDE? What about Red Hat and Ubuntu? Can I run a Red Hat container on an Ubuntu host? Yes, we can, because what we're virtualizing is not the Ubuntu-ness, we're virtualizing the Linux kernel underneath it. Well, how about Windows Desktop and Mac? I went to docker.com and I downloaded Docker Desktop for Mac. Well, the interesting thing is for local development, we actually create a different mechanism. Here on the right is what we'll want to do in production. We'll want to run as efficiently as possible. But on the left, we can take some additional steps to be able to run on operating systems that are not natively supported. So here's my Windows laptop or my Mac laptop. I'll install Windows on it. On Windows, I'll install Hyper-V. On Mac, I'll install HyperKit. And then we have a guest operating system installed there. This is a Linux operating system. And then we can install our Docker hypervisor and run our Linux containers on a Windows host. Now, if you're using Windows 10 and WSL2, then WSL2 can be this Linux host, which means the Docker engine can really elegantly integrate into WSL. That's amazing. So we can see that we're already using our hardware much more efficiently by virtualizing the operating system instead of virtualizing hardware. Now let's add an orchestrator. Now, what is an orchestrator? An orchestrator takes a set of machines, pools them together, and can make decisions about starting and restarting containers, distributing them across all the machines. Now we'll give an orchestrator a question like, can you start 3 copies of my web server and make sure they're across availability zones and keep them running if something happens? I'm not explaining which machine should run what. I'm only explaining, hey, go make that happen. And the orchestrator gets to choose which machines need to be running and can monitor those containers and move them around if the load becomes unbalanced or if hardware fails. Now that's excellent. That orchestration engine is that process that will schedule, start, and stop a group of containers, distribute the containers across the machine. Automatic and manual scaling can happen in the orchestrator, monitor container health. Often we'll load balance scaled containers, and we usually have a management UIs associated with our orchestrator. Now, unlike just regular Docker, where we're just starting and stopping singular elements, with an orchestration engine, we're probably running things at scale, where we want lots of copies, lots of machines, and that's the orchestrator's job, is to run these containers at scale. So, an orchestration engine, it basically keeps containers healthy. There's lots of orchestration engines to choose from: Kubernetes, DCOS, Docker Swarm, Azure Service Fabric, Amazon Fargate. All of these are orchestration engines, and you may choose any of them. They all pretty much do that job. Now, if you don't have an opinion yet, Kubernetes might be a good choice. Kubernetes has become quite popular as of late. But if you're using a different orchestration engine and you're comfortable there, then by all means, that's probably your best choice. Let's take a look at the Docker ecosystem. What is that mechanism, that magic that has made Docker containers so popular? Well, we start with configuration as code here on the top left. That Docker file is the configuration as code that explains the content that we need inside of our container. Now that Docker file, we'll use that to build an image. Pardon me. Now that image is the binary blobs, all of the details associated with how we run this container. Then we'll take our image and we'll start it as a container on a hypervisor. In this case, Docker machine, but also Kubernetes or DCOS. We have a Docker file, we build into an image, we run as a container. Now we can choose to share images with Docker Hub or pull images from Docker Hub. And the beauty here is, unlike GitHub, where we would share our source code, with Docker Hub, we're sharing our binary blobs, our built content, which means I don't need to recompile it once I pull it from Docker Hub. That's excellent. So let's build up a Docker file. Now I have an empty directory here, and we want to build a container. Okay, let's scaffold out a website. I'm going to say .NET new MVC. I'll give it a name of, what is the name? Site and an output of the current folder. Now, I could definitely say file new inside of Visual Studio, and that would work out great. I could avoid passing in the name and site parameters, but if I didn't pass in a name, it would use my folder name, in this case, demo. If I didn't pass in an output folder, it would create a new folder inside that. So then I would have a nested folder. But here we have that right here. Let's open this up in VS Code, and we have our website ready to go. We have some controllers, or in this case, only one controller. We have some views. Here's our home view and our index view, and it says, welcome. Let's say, welcome to Azure Community Conference. Excellent. Now our job is to get this site into a container. The first thing we're going to do is we're going to create a gitignore file, .gitignore. Now here in the gitignore file, we want to ignore all of the content we wouldn't commit to source control. Bin, obj, all of the build content, star.user, star.suo, .vs folder, all of user specific things. Also packages, things that we download, and temp files, star.tmp, star.log, any of those temporary files. So we have those four groups. We have content that we download, content that we build, user-specific content, and logs. Our next step in containerizing this is to build a .dockerignore. .dockerignore, and it has an identical format as a .gitignore. In fact, if we didn't have a .gitignore, it would use a .dockerignore instead. That's perfect. Ah, yes, VS, I would like the .vs code folder. Thank you. Now there is a fifth group that we need to add here to our dockerignore file, and that is development content. We don't want that in our production container. So we're going to exclude app settings.development.json, and we're also going to exclude here in properties, the launch settings.json. Launch settings.json. Now those two files are development settings. They're definitely helpful as we build, but we don't want them in a production container. Now that we've got our dockerignore file in place, let's create a Docker file. Now it's important that this is Docker file and not dockerfile.txt. If you accidentally named it dockerfile.txt, easy enough. Pull the .txt out, and now we have Docker file. Now I have the VS Code Docker extension installed, so I have this nice whale icon here. Now let's do the standard things. We have pretty much four main verbs in our Docker file. We have from, copy, run, and cmd. If you understand these four commands, you can probably read most Docker files. So let's go off to Docker Hub and let's go find the content that we need for this image. So hub.docker.com, I'm going to search for .NET, and let's pull up this .NET repository. Now this one happens to be a meta repository. It references lots of other repositories. Samples is great. It has lots of Docker files that you might choose from. Runtime depths is everything we need to be able to install .NET, but it doesn't have .NET installed on it. .NET Runtime builds on top of that and includes the things to run console apps. On top of that, ASP.NET is our web server. And on top of that is the build tools, the SDK. Let's start here. We want to build inside of our container. So let's go grab this. Here's that tag. And we can see that scrolling down a bit, this one is built on top of Debian. There is one that's built on top of Alpine, and that's a very small Linux distribution. Let's use that instead. So back here in VS Code, we will say from, oh, apparently I launched. Let's kill off the second VS Code. Back in our original VS Code, haha, from there. And we'll do the Alpine variant. Next, we need to copy everything from the directory where we'll run our Docker build command into the current directory in our build file. Now, what is that current directory? Let's set the workdir to /src. Now, we could say var, lib, whatever, but in this case, src works out great. We've just copied all the files from right here into our image in the src directory. Next, we need to run some commands. If we're on the command line, the commands that we'll run are .NET restore, and then .NET build. We'll build in release mode. .NET test. We'll build this in release mode as well, so that we don't accidentally end up with both a test, release and debug build. And then .NET publish. This is not that unlike right-click publish inside of Visual Studio. But in this case, we're doing it inside of a build file, so we'll know it'll be identical every time. And then finally, so now we've got those 4 commands: restore the NuGet packages, build, test, and publish. Now, these are just the console, the lines we'd run in a console. And so we need to run them as part of a Docker build. Let's run this one. Let's run this one. Let's run this one. Let's run this one. And now they are Docker commands. Next, let's set up the CMD, the thing that will start when we start our Docker image, or when we start our image as a container. So we'll say .NET site.dll. And we'll need to change our workdir to /dist now that our content is there. And let's also copy in a few environment variables that will get us where we need to go. There we go. So this just says run in production and listen on port 80 and expose port 80 so that others can connect to it. Now, we could definitely go to production with this Docker file right now, but we could also improve this just a touch to take advantage of some excellent Docker features. Now, we looked at the .NET SDK. Let's also take a look at the .NET ASP.NET one, the one that runs web servers. Now, in this case, this is pretty much the same, but we'll grab this. We also see that there is an Alpine variant of it as well, 5.0-Alpine, so let's use that. And let's come here and we'll say from Alpine. Now we've just split our build in half. We have this top half that is our build server image, a build server image, and this bottom half that is our production runtime server image. Now I put server in air quotes because they're not servers, they're containers, but server kind of is a good metaphor here. Now we can do all of our building in this one, and then this one does not have any of our source code or our build tools as we publish that into production. That's much lighter weight. Excellent. Now we do need to fix this up. Let's say this is in the app directory, and then we need to copy the content from the dist folder, this dist folder over here, into that current directory. Now, as it stands right now, it would try to copy it from over here. We don't want to do that. So let's say from equals build, and let's name this one as build. Now it will build the content here and then copy it into this new image that we'll use in production. Now this is perfect. We have now a multi-stage build that allows us to remove the build tools and make this production container much smaller. Next, let's, I forgot to start Docker Desktop. Let's start Docker Desktop and let's optimize this a little bit. Let's restore our NuGet packages first. Now, Docker is going to cache each layer. And so if I come in here and I just change a CSS file or a JavaScript file, I don't want to restore my NuGet packages. So let's restore our NuGet packages, then copy everything, then do the build, test, and publish. Now I do need to copy in my manifest. So let's copy in site.dll or site.csproj into the current folder. And now we've got a build file that is ready to go. Now this build file is great at being able to do all of the things that we need. Our build tools are not in our production image, and we're taking advantage of Docker caching so that if I'm only changing source code and not my NuGet packages, I don't need to restore my NuGet packages. Now let's see if Docker is running. Docker image list. Nope, not quite. Okay, we'll come back to it once it's, oh, it might have just finished. Let's come back to it when it's ready. So we got to see building up a Docker file. And the cool part is, as we deploy this to Azure, all of the things that we'll do, we'll use this same Docker file to create a standard image and just deploy that image in interesting ways throughout Azure. Okay, so let's talk about the Docker registry. Now, the Docker registry is a place where we can store images. Now, by default, the Docker Hub is a great Docker registry, but for our private things, we may not want to expose them to a public Docker registry. So what if we had a private container registry up on Azure? Now, that's exactly what we can do. Docker Hub is a great public one, and we can use the paid plans to be able to host private images there. But we could also host our images on Azure Container Registry. Now, Azure Container Registry is great for private images. You can build content either in GitHub Actions or in Azure DevOps, and you can publish it to your private registry, and it will never get exposed to other users. That's perfect. So let's take a look at Azure Container Registry. Docker image list. Are we ready to go? Ah, nope, it's still starting. This may be a very different demo. Okay, so registry. Let's go browse through Azure and some of the other content that we have here in the registry. I'll move this off screen. Here's my Azure Container Registry, and this registry includes the various images that I've pushed there. So let's take a look at those images, and I have here this Level Up DevOps image. I also have this Docker in Azure image, and so I've pushed these to my Azure Container Registry previously. That's perfect. Now we do have a latest tag. We have a v0.1 tag, and I've just done a Docker push to get there. So I realize that Docker isn't running yet, but we would say a Docker build, and we would tag it with our registry. So in my case, it's robrich.azurecr.io/Docker in Azure, and give it a version number like 0.1, and then dot. That dot specifies the current folder where I want to build. And so that's that magic piece that allows me to connect the dot inside my Docker file. When I copy all the content from that current directory is that directory that I'm specifying right here. Okay, once I've done the Docker build, I can do a Docker push, and I don't need to specify the server because it's here tagged in my image. So I'll Docker push this, and that'll get up to Azure. And now we've got that content here in Azure, and there it is right there. Perfect. So we're able to take a look at how we can get our content into Azure. Now, I definitely needed to log into Azure first, so I did an AZ login, and I provisioned that content. There's a few more steps than that. But an Azure Container Registry is a great place to store these images that then you want to run in Azure. Great, so we've got an Azure Container Registry ready to go. Now let's look at ways that we can run our containers from those containers stuck in the, that we've set inside the Azure Container Registry. Now we've probably looked at a similar thing here where we take a look at cloud hosted things. You know, what does cloud mean? We have on-premise things where we own all of the pieces. We have infrastructure as a service where we've outsourced the infrastructure, but we still own the operating system and the middleware and the runtime, the data in our applications. We have platform as a service where we own only the data in the applications, and even the runtime is abstracted away from us. And then we have software as a service. Now we've probably seen diagrams like this. The cool part is we can run containers in each of these steps, or perhaps we might have intermediary parts where maybe Azure Kubernetes service kind of sits here between infrastructure and platform as a service. And then Azure Web Apps kind of sits, or Azure Container Instance kind of sits in between these two. Now, we've chosen to outsource some things so that we can focus on the business logic that we need. Or we can choose to own those things to ensure that our customers are serviced by exactly the content that we expect. So that's what we're going to look at as we crawl through these various Azure compute mechanisms. What do we want to outsource? First, let's take a look at Azure Kubernetes Service, then Azure Container Instance, then Azure App Service, and finally, we'll take a look at installing Docker on virtual machines. So what do we want to outsource? All of these are actual real Docker. We choose what we want to outsource. We choose our orchestrator when we choose these. Now, the container that we built, the Level Up or the Docker in Azure container, is the exact container that we're going to use in all of these places. It's a real container running real Docker. It's not a different Docker based on the different ways that we outsource this. So for each item, we're going to talk about what we choose to own, what we choose to outsource, some of the pros and cons of each one, and when we might choose each one. Now, the cool part about this is that Azure will meet you where you are. And so whatever your needs are with these various tools, you can find one that exactly matches your needs. Azure Container Service. I'm going to flag this one as legacy. They're working to shut this down. This was ARM templates that allowed you to spin up container runtimes in really interesting ways. You could provision DCOS, Docker Swarm, or Kubernetes this way. But they only provisioned them for you. After that, you owned all of the content. If you wanted to upgrade, it was on your responsibility to maintain this hardware. Part of it is, so with Azure Container Service, we outsourced the provisioning and the initial configuration, but we owned all of the product upgrades, all of the VM upgrades, Windows updates, node scaling, all of that was on our side. Now, the cool part about Azure Container Service was we could choose our orchestrator really easily, but for the most part, we've chosen Kubernetes, so maybe that's not necessarily a question we want to answer anymore. Azure expired on January 31st, 2020. So if you're not already off of Azure Container Service, now is the time. Service. If you use DCOS, you can use to Mesosphere's open source cloud. If you use Docker Swarm, you can move to Docker Enterprise, now owned by Mirantis. And if you use Kubernetes, it's natural to move to the Azure Kubernetes Service, where you can outsource a little bit more associated with running your Kubernetes cluster. As you grab these slides from robrich.org, you can click on each of these blue links to learn more about each of those topics. Next, let's talk about Service Fabric. Now I'm going to flag this one as legacy, and that's probably a little presumptive on my part. It's not going away, but it is a little weird. The cool part about Service Fabric is that Azure owns the orchestrator, but provisioning is a little weird. You create a new project template inside of Visual Studio, and you get this kind of Service Fabric dialog. It was cool for hosting not only containers, but other content as well, much like Azure Web Apps does today. And then when you're ready, you just handed Azure Service Fabric your application or your container, and it would handle all of the provisioning of nodes and scaling, and you really didn't have to worry about anything, which is wonderful. It's a really elegant system in that respect, in that you don't really need to manage very much. Now, in this, we've chosen to outsource cluster management, VM updates, node scaling, container restarts. That's wonderful. We can just completely outsource that content. And we only need to own the process running in our container. Great. With Service Fabric, there's no hardware to maintain. Azure manages everything. It is a little bit more favored towards Windows, but it works on both Windows and Linux. On the downside, that project configuration is a little weird. And if you are running Linux containers, because of its focus on Windows, you might have a little bit of things with case-sensitive file systems or slashes going the wrong way. There are just some little quirks there. Now, if you really like that outsource the everything, or you have other content running on Service Fabric, then Service Fabric can be a great choice for you. If you have mostly or all Windows containers, and you don't mind the aversion to open source, then Service Fabric might be great. Service Fabric is now open source, which is really helpful. So you can run Service Fabric on your on-prem cluster too. Next, let's talk about Azure Kubernetes Service. Now, Azure Kubernetes Service is kind of an upgraded version of the Azure Container Service focused exclusively on Kubernetes. What I love about this is that Azure Kubernetes Service is real live Kubernetes. This isn't a Microsoft port of Kubernetes. This is real Kubernetes. And the cool part, when you break Kubernetes into two pieces, there is the control plane that manages Kubernetes, and there's the worker nodes that do all of the work. We only pay for those worker nodes. The control plane is completely managed by Azure and is no cost to us. We just choose the size and quantity of our worker nodes, and that's the content that we pay for in Azure Kubernetes Service. So let's take a look at Azure Kubernetes Service. Now, we already have this container published into our container registry. So let's come in here to our command line, and let's do a, let's go grab some Kubernetes YAML files here. Let's walk through them for a second and take a look at the content that we have here in our cluster. Now, we start off with the deployment file. This deployment specifies the number of instances that we want. In this case, there's only one. It specifies the container that we want. Here's the container inside of our container registry. It's a little bit mad at me because I didn't specify a resources section. So let's specify that real fast. And not there, there. And now this is how we spin up our pods. Now, pod is a wrapper around a container. So we might choose to have multiple containers in a pod. When you understand why sidecars are important, then that can be helpful. In the meantime, a good rule of thumb is one container per pod. Okay, so we've got our deployment that will spin up our pods. Then we'll have a service around that, and the service will load balance across all of the instances of our pod. In this case, we'll only have one, so this will round robin across that one. And then we'll also have an ingress that will map DNS into our cluster. Okay, so let's kubectl apply those. We're here in this folder with the K8s, and let's say kubectl apply-f K8s/deployment. We can also deploy an entire folder at once. So let's say kubectl apply-f K8s, and that will just enumerate all of the things in our folder. And the cool part about apply is it is an insert or update. So in this case, it said, hey, the deployment is already there. It works just fine. Great. So now we can head off to this URL in our cluster right here. And it will take a minute for DNS to propagate. So probably this won't resolve yet. But we can port forward into the service. So let's do that. Let's say kubectl port forward service/docker in Azure, and we can forward port 80 on our local machine to port 80 inside the container or inside the service. But if we have port 80 in use on our local machine, let's flip this to port 8080. Kubectl port forward. I did mean port forward. I spelled it wrong. Port forward. Now we can go into that service. Let's go to localhost 8080. And now we get to our website running in Azure. That's perfect. Now we've got our website running in Azure Kubernetes Service. And so now we can say kubectl get all, and we'll also get our ingress. And so now we can see all of our services running in Azure. We have one pod that was started by this deployment. We have a replica set, which is kind of this intermediary object between deployments and pods. We have our service, we have our ingress, and we also have our Kubernetes management IP. That's perfect. Here's that host name, and once it finishes propagating DNS, then then we can also get to it straight from here, but it does take a few minutes for that to happen. Okay, so let's go delete all of those resources running on Kubernetes, kubectl delete -f kdes. And that was great to be able to see Azure Kubernetes Service. Azure Kubernetes Service is great. In Azure Kubernetes Service, we have outsourced the control plane. We've outsourced container restarts. We've outsourced node scaling. We own the container process, and we own the Kubernetes version. Now, the cool part here is that inside the Azure Kubernetes Service, we can choose the version that we're running. So let's come back to our Azure Kubernetes Service, and let's pull up the cluster configuration. And right now, I am running 1.21.2, but just with a button, I can upgrade to 1.22.2. Now, I'm not going to do this in the middle of the demo, but that's really easy to do. Upgrading your cluster version is so simple with Azure Kubernetes Service. Now, when would I use this? This is real live Kubernetes. So if you're familiar with Kubernetes, then this is a great place to go. The control plane being free is amazing. And actually, Windows is no longer in preview, so you can do both Windows and Linux containers on Azure Kubernetes Service. Push button scaling, push button cluster upgrades, all of those are really impressive. Now, on the downside, that YAML file was a little bit obscure. So if you don't want to deal with Kubernetes YAML files, then Service Fabric might be a better choice. It may take a little bit to get the latest version of Kubernetes up into Azure Kubernetes Service, but they've been good at becoming much faster in this. I think the last version they were able to get up in a week or two rather than the month that I've said here. Azure Kubernetes Service. When would I choose this? If I had lots of microservices, I would definitely run it on Azure Kubernetes Service. If I prefer open source in comparison to more closed source options, then this is real Kubernetes, and it's a really great choice. Now, I may need an ops team on site to be able to manage this because Kubernetes, there's a lot to it. And if I want the bleeding edge, I can definitely do that with Azure Kubernetes Service. Next, let's take a look at Azure Container Instance. Now, Azure Container Instance is a REST API for spinning up containers. It doesn't have an orchestrator that will auto-scale, but we could build that. It's a nice API that allows us to spin up containers, and we get utility billing based on the container, as opposed to Azure Kubernetes Service that bills us based on the node, the virtual machine that we're running them on. Now, we don't get any auto scale or auto restart, so if our container crashes, that's it. But it's perfect if we want to build a service around it. Perhaps we want a multi-tenant service and we want to be able to pull in various content from various systems. We can have this REST API that really quickly spins up a container and does what we need to do. So let's take a look at Azure Container Instance. Now, I've got, let's come here and let's run this. Now, this is a massively long command, so let's walk through it. We're going to create a container. We'll name this container Rob Rich Docker in Azure. Here's the resource group that it'll run in. Here's the image inside of our container registry. Here's the registry authentication details. I'm using 2 environment variables in this case. We're going to connect on port 80, and we'd like to give it this DNS name so that we can connect to it from the outside world. Finally, we want to go grab the fully qualified domain name once it's running. Now, we'll take it a minute to spin up, but it's only a minute, so it's totally worth waiting for. This, to be able to spin up a container and automatically get DNS all the way running is just really cool. Once it's running, and I'm probably going to end up racing it, it just finished. Cool. So here's our URL. Let's grab this URL and let's head off to Azure, HTTP there. And our website is running in Azure. That's great. Oh, it looks like DNS hasn't propagated yet. That's totally fine. Now, the cool part is we just spun up that container in Azure, and it would be really easy for us to spin up a whole lot of containers, do what we need to do. A DevOps pipeline might find this very exciting. AZ container list. I'm going to say -o table, so it won't spit out JSON. Here are the containers that I have running in Azure. Now, in this case, I only have the one, and it can tell me both the image and the IP ports. This one is public. Here's the resources that I chose to run it on. And that's pretty cool. In the same way that I can do a Docker logs, I can see AZ container logs. I'm going to give it a name of Rob Rich Azure Docker in Azure resource group of Kubernetes, and it will give me the console logs coming from this container. Now, much like we were able to do this with Docker or Kubernetes, here's the way that we will do it with Azure Container Instance. And then finally, when we're done, let's say AZ container delete -- name Rob Rich Docker in Azure resource group Kubernetes. And yes, I really do want to delete it, so it won't prompt me. And now I'm only billed for the half a dozen seconds that that container was running inside of Azure. That's perfect. Azure Container Instance is really fun. With Azure Container Instance, I have outsourced the host infrastructure. I've outsourced VM patching, but I choose to own the container process and the container health and restarts. In effect, I'm choosing to own the orchestration responsibilities. If I want to scale it to multiple instances, then I'll need to do that as well, calling Azure Container Instance starting multiple things. Azure Container Instance. It's great because it's utility billing based on the container, not based on the virtual machine. If I have, for example, Azure Kubernetes service, and I don't have anything running in my cluster, I'm still paying for the cluster. With Azure Container Instance, I'm not. I'm only paying for places where containers are actually running. On the downside, there's no auto scale, there's no restart on container fail, so I'll need to build a process that will monitor these and restart my containers if I need to. When would I choose this? It's a great platform to build on top of. If you're building a multi-tenant system, then Azure Container Instance might be great. It's also great for quickly testing a container, so maybe a DevOps pipeline or a local development environment might be perfect. Let me just push these to Azure Container Instance and fire it up in the cloud. Let me show you Virtual Kubelet. Now, the cool part about Virtual Kubelet is it marries the best of Azure Container Service or Azure Container Instance with Azure Kubernetes Service. Basically, in Azure Kubernetes Service, we create a virtual node, a virtual machine. That is one giant thing inside of Azure Container Instance. So you can have a really, really small Azure Kubernetes Service cluster, and you can spill all that content into Azure Container Instance. So now you're only billed for that utility billing, but you're still using the full power of Kubernetes. Virtual Kubelet is amazing, and it is open source. Head to these slides on robrich.org, click through these blue links, and you can learn more about the Virtual Kubelet. Next up, let's look at Azure App Service or Azure Web Apps. Now, Azure Web Apps is great for publishing ASP.NET sites, but what if you want more control over the configuration? Or what if you want to run in Linux? Then containers can be a great source here. Now, the cool part about Azure App Service is you can deploy only a single container and it auto restarts like any IIS app. It works on both Windows and Linux. And so whether you're hosting .NET Framework or .NET Core, Node, Go, Rust, anything, you can run it on Azure App Service as a container. So let's do it. I'm here inside of the portal, and I'm going to say create a new resource, and I'm going to choose the I see I missed a demo. That's going to be cool. Let's come back to it. Azure Web App. Web app plus database. Website. I'll just do it here. create a web app. Now, I'd like to use my existing Kubernetes namespace. What do I want my web app to be? I'll say Docker in Azure. Is that one taken? Nope, that's good. And I'm going to choose a Docker container. Now I'll choose my operating system. In this case, I'll choose Linux. Let's choose East US because that's where my container registry is, East US. And now I can choose a service plan. Now I could choose a new service plan. Let's do that. A service plan represents the all of the app services in one single billing unit. And then I can choose this size. Now, Premium V2 isn't bad, but I could also choose in a dev test cluster a really, really small one, which is cool. So let's choose, actually, let's choose this one in this case. Next. Now I want to run a single container. That sounds great. I don't want to run the quick start. Rather, I want to pull from my Azure container registry. Let's pick that Docker in Azure image, and let's choose the v0.1 label. If we choose latest, the cool part is we can just then push something to a registry and it'll automatically show up in Azure Web App. So that's really cool. And then the start command, I'm going to leave this blank because my container handles this just fine. Next, I don't need monitoring, so I will turn that off. And let's come into review and create. And let's create this Azure Web App. Now, the cool part about this Azure Web App is that I'm now only paying for this one container, and it will keep it running in all the ways that it needs to. Because I've chosen latest, it will automatically create a webhook that will listen to my container registry and work through content there. Let's come back to the other demo that we were looking at with Azure Container Instance. I'm going to come back here to my container registry. And if I just want to try out one of the containers in my registry, let's come here to repositories rather. We'll choose the Docker in Azure, and then we can right click here, or rather left click here, and we can say run instance. Now, the cool part about it is this will run this on Azure Container Instance. And if I were to fill in all of these details, then I would be able to launch that in Azure Container Instance really easily. This is a really elegant way to be able to use Azure Container Instance without having to build up that big command line. Although the majority of the time when I'm using Azure Container Instance, I just take that command line and I stick it in a batch file and I don't worry about it. But I love the ability to quickly provision containers here from the Azure Container Registry. Let's come back and see if our Azure Web App is done. Nope, it's still deploying. That is totally fine. We got to see how to create an Azure Web App though. And the cool part about that is it is a single app that runs in the normal way that we would run any Azure Web App. So what did we choose to own and outsource in the case of an Azure Web App? Well, we chose to outsource the host infrastructure, the VM patching, container health, container scaling. All of that is now owned by Azure. That's amazing. We don't have to worry about it anymore. We only need to own the process running in our container. That's amazing. Now, when would we use this? On the upside, Azure manages everything. We don't need to worry about it. It's drop dead simple scaling. We just grab that scale bar and we can do what we need to do. On the downside, it's only a single container and only a single port. If you need to host UDP traffic or TCP traffic, non-HTTP traffic, then you might want to choose a different source. Or if you need to host more than one port coming out of your container, then you might choose a different source. If you need many containers running in concert, then this might not be a good choice. But if you just have a monolith that you've moved into a container and you want to host it on Azure, Azure Web Apps is the perfect way to run that container. So when would I choose this? I would choose it if I had a few containers or maybe only one. If I'm modernizing my monolith and I want to get it in a container, Azure Web Apps is perfect. And if I don't want to worry about the orchestrator, then I can use Azure Web Apps to just handle that for me. Next up, the ultimate power move. I could choose to grab a bunch of virtual machines. I could pull them inside of a VLAN, and I could install Docker or Kubernetes into those virtual machines. Now, the cool part is I can provision whatever orchestrator I would like. I can choose to scale it in the way that exactly matches my needs. If I need, for example, Kubernetes to be the exact same version across all of the public clouds, I would probably choose to create my Kubernetes cluster on virtual machines so that I could very specifically control when I wanted to update each node and what the details about those nodes may be. On the upside, I manage everything. On the downside, I'm now responsible for everything. What did we choose to outsource? Well, basically the only thing we chose to outsource was buying the hardware. We own the installation, the configuring, the patching, container health, cluster health, scaling. That's kind of a lot. And so all else being equal, if we don't have that need, then Azure Kubernetes Service might be a wiser choice here. When would I choose this? When I need to be able to have identical setups across public clouds. I can grab a pool of virtual machines on Azure, and I can grab a pool of virtual machines on Google Cloud, and I can make them identical in every way. On the downside, I need to do all of the things. So all else being equal, if I don't have that cross-cloud need, then Azure Kubernetes Service might be a better choice here. Installing Dockers and VMs. When I'm creating a software as a service platform, or when I want to create a hybrid on-prem and in-cloud version, then this might be a great way to ensure consistency across those environments where I control all the on-prem resources, so I may as well control all of the cloud-based resources too. Docker in Azure. We got to see lots of different ways to be able to run containers in Azure. We got to see that it is the exact same container that we're running in all of these places. We could build up these containers using a regular Docker file, and we got to see how we could live code that process. And so for the most part, Docker can meet you exactly where you are. Let's look at these on a scale from most managed to least managed. On the most managed side, Azure App Service. Everything is pretty much taken care of for us. Next up, Service Fabric. Next up, Azure Container Instance. Next up, Azure Kubernetes Service. And finally, virtual machines, where we pretty much own everything. Let's compare them on how many containers we can run. With the most containers, Azure Container Instance allows us to spray a bunch of containers. We're only paying for them while they're running. Next up, virtual machines. We could definitely continue scaling up the number of virtual machines, but we're paying per virtual machine to do so. Azure Kubernetes Service does let us scale to really high limits, and we can always call them and ask for more. Service Fabric, much like Azure Kubernetes Service, allows us to scale up as much as we need to if we call them first and let them know. Azure Container Instance, if we're using dev test, we can run a few containers really easily because we can just fire up a few command lines to be able to get that in place. And finally, Azure App Service, where we're only running a single container. If we need to run multiple containers in Azure App Service, pardon me, we need to spin up 2 different app service instances to run those multiple containers. Here's that spot where you may want to pull out your camera and take a picture. Here's that group of all of the different axes that we looked at and how each of these services compare. Now, what's really elegant here is that I've not identified which one you should choose, rather given you the metrics that you can use to pick the one that is most applicable to your environment. Now, I'm not exactly sure what you need, but I know that Azure can meet you there. Whether you need lots of containers or only a few, whether you want to outsource a lot of things, or whether you'd prefer to own those things. Azure can definitely meet you where you are. And that's just what I said. Azure will meet you where you are and power your container workloads. This has been a lot of fun getting to share with you the many ways to Docker in Azure. You can grab these slides at robrich.org. And if you're watching this video later, hit me up on Twitter at rob_rich, and let's continue the conversation. For those of you who are here live in the event, what are your questions?
Hey Rob, this is a very wonderful session that you consolidated everything in a single presentation. I'm working in the Docker and Kubernetes so long. So now this given an overall idea about, hey, the Azure can power up in any way, any situation. Thanks for this wonderful session, and you presented very well, and it's like very close to me. This is a closing session, but very beautiful session I heard today from you. And thanks a lot for making so much of precious.
Most definitely. I'm so glad to share this knowledge and to be able to condense it in a way that is easy for you to grab. That's excellent.
Sure. Yeah. So the mostly probably like you already the presentation itself saying that it's answering the question, because sometimes we have a question that in what situation we going to use in what services, but you have a presentation ready that answers our question.
Oh, perfect.
Yeah. So still no questions raised, Rob.
One of the questions I often get is, how do these Azure compute services map to other compute services? Like, what's the Fargate equivalent in Azure Web Apps or in Azure? And the answer is Azure Web Apps. Fargate allows you to spin up content inside of your cluster without having to worry about the underlying architecture. And so Azure Web Apps is the best comparison to that. You could also compare this to Azure Virtual Kubelet, because you can run Fargate in Kubernetes mode. And so that's a good analog there.
So for Rob, any idea about Azure Dev Space? So still it's like workable, or
Azure Dev Spaces is really, really interesting. Azure Dev Spaces allowed us to debug containers running inside of Kubernetes. They've since retired Azure Dev Spaces. And so there is a replacement that allows you to proxy content into your local machine to be able to debug. It doesn't work exactly the same as Azure Dev Spaces, but now with Dapper, that's kind of built into the Dapper architecture, where you can deploy a lot of your content inside of Kubernetes and then just get that one service to forward outside of a container onto your local machine.
so most probably people will more fear about, hey, I don't have that much of configuration in my system so that I can run Docker in my system. It's getting stuck, it's gonna hang. So for that, people like any suggestion for them, like, hey, this is the best way you can at least explore the Docker, because the people try that I don't have a configuration in my system, I can't use Docker, and it's getting hang. For you, any suggestion from you, Doc?
Yes, most definitely. Getting started with Docker is actually really fun. Inside Visual Studio, you can add Docker support either as you create your project, or later inside your project, you can right-click on the project and choose Add, and then add Docker support. That will scaffold out the Docker file, and that Docker file is a little bit more confusing than the one that we built together. But with that Docker file in place, you can just push play inside of Visual Studio, and you will be debugging your website running inside the container. From there, start getting familiar with the command lines that you can use. Docker build command, the Docker run command. You may choose to leverage Docker compose as well. And then you can start futzing with Docker files and get a feel for how to build your own Docker files that are most optimized to your workload.
Thank you, Rob. And we got one question from Anand Kumar. And his question is like, best container service in Azure to launch SaaS product in multiple region.
Ooh, what is the best product in Azure to do it? The cool part about this is that it really depends on the architecture of your workload. If your SaaS product is more monolithic, then maybe Azure Web Apps is a good choice. If your SaaS product is more microservices, then maybe Azure Kubernetes Service is great and allows you to spread out through that process. If you have any multi-tenancy in your application and you want to provision each client into their own piece, and you want to take control over the orchestrator, then you might choose Azure Container Instance and build on top of it. Probably that's more work than you want to start with. And so a good rule of thumb is many services look towards Azure Kubernetes Service, and a few containers look towards Azure Web Apps. But ultimately, I'm less familiar with your architecture, and so I'm confident that I'm missing something, and you may find another solution that will work perfectly.
Thank you, Anand, for the question. And so we are at the end of your session. Rob, thank you for the wonderful session and all the best. And thank you
Most
so
definitely.
much.
Thanks for letting me join you here at this event. It's been so much fun joining you today.
Thank you, Rob. Thank you.
Yep. Bye-bye.
Bye-bye. Bye-bye. Hey everyone, behalf of Azure community, we would like to thank all our attendees, speakers, and volunteers who joined us today. You all are a very important part of our conference, and we sincerely appreciate your attendance in a day one. We hope you learned something new, explored something new, had a fun, and we hope that you can't wait to come back tomorrow for a session day two. Until then, bye from AZ Conf team. Thank you.